to Fab TV, and welcome to day three of FAB16.
Barry, just pause a little. We're having the same issue as the other day. Wait a second.
Do you want us to start over when you're ready?
Yeah, go ahead. Go start.
On your mark, get set.
Go.
Good morning, good afternoon, good evening, wherever you are in the world. Bonjour le monde.
Bon matin, bon après-midi, bonsoir, bonjour le monde.
I'm Sherry Lassiter, broadcasting today from MIT's Center for Bits and Atoms in Cambridge, Massachusetts, and it's Wednesday morning, August 11th, 2021.
Je suis Monique Chartrand chez Communautique à Montréal. Aujourd'hui, nous sommes mercredi matin, le 11 août 2021.
Good morning, Monique. Just want to say hey.
Hey, Sherry.
Welcome to Fab TV, everyone, and welcome to day three of FAB16 Montreal. We have lots of exciting programming coming to you today from the Fab Lab Network, great videos and live sessions from across the world. But first, let's talk about the weather. So, today in Boston, it's partly sunny, patchy fog in the morning, warmer during the day with highs in the lower 90s Fahrenheit. We have southwest winds 5 to 10 miles per hour. The heat index values are up to 100 in the afternoon, and boy, is it humid. It is so humid, it's horrible. Monique, how is it there?
Okay, today in Montreal, it's mostly cloudy with a 70% chance of rain and thunderstorms. Low temperature around 74 degrees Fahrenheit. And dew point will be around 70 Fahrenheit with an average humidity of 80%. Winds will be 9 per hour from the south.
Okay, well, I'd like to share my screen, and let's go to the international weather now. So here we have a map of the world, and as you can see, all the green places are rain, which is kind of interesting. We see rain right across the equator right here. And we see a lot of rain down very, very far south near the pole. And then a little bit up here in the north. So we have these three bands of wet weather, and pretty much, but it's not a whole lot of wet weather. You know, not a whole lot. What do you see here, Monique? You see, this is great. I mean, I know nothing about the weather. What do you see?
I see a little bit of green. I don't know exactly what's going on this earth, but seems pretty interesting.
Looks like we have a lot of action out over here in Cambodia, Malaysia, Indonesia. So anybody out there who has an update on the weather from that, please send it to us in the chat. Let me see now. I'd like to show you, let's look at the severe weather. So this is what we've all been hearing about a lot more. The yellow is like very hot. The orange is kind of, you know, getting to the warning level, and these sorts of reds and oranges and purples, that means it's severely hot. And so I would say, looking at least the northern hemisphere, that it's hot today. What do you think, Monique?
I think so. It is the summer in the north of the planet, and a hot summer, of course. And we can see more and more hot around Washington, I think, and Montreal. So most we are on the north, most it's hot. Very strange, don't you think?
Yeah, you guys look terrible. This is awful right here. Well, I think that might be it for the weather this morning. Let's move to the COVID report. So hold on just a second. Here we go. It's just awful, isn't it? So this is the Johns Hopkins University map of the world. And as you can see right now, total cases in the world, 204 million, I guess, historically. 4 million deaths, total vaccination doses 4 billion, 4.4 billion, my God. And if you look at this map down here, well, first of all, the U.S. has the highest number of cases and death rates, and it looks like Indonesia and India are right behind us. In Canada, you are like way down there. Where are you? Look at you. You're like way, way, way, way down. Anyway, you're doing very well compared to us. So,
yes.
Yeah, go ahead.
Yes, and Canada has opened the border this week, Monday, to the United States. So I think it's going better and better.
I don't know. It seems like it doesn't seem like really good timing, does it? I'm going to stop sharing my screen. Oops, excuse me. Hold on just a second. Anyway, so we have an incredible day today lined up for you. Sorry, a little technical difficulty, my friends. All right. At any rate, we hope all of you are safe and vaccinated or soon to be vaccinated, because your safety and your contribution to this world is so important. If I were in Great Britain right now, I would say that I think the newscaster would say, "And now for sports," but we don't have any sports today, so we'll forget that.
FAB16 is almost a sport, no?
Yeah, that's true. It's true. FAB16 is very much a sport these days. So here's what to expect today from our TV show. We're going to have live action at several points today. So at 8:30 a.m. Eastern Time, 2:30 CEST, we have AgriLab from Central Europe, which will be followed by Armenia. They'll both be live. And then at 9:30, we'll be broadcasting from Montreal, finding out about the state of Fab in Canada, as well as, I think we got a cooking show. Is that right? Who's doing the cooking?
It's the team of the Fab Lab Nation tours. So you're going to see Marc-Olivier, Guillaume, and Pansavan. She's back.
Well, that's awesome. And then at noon Eastern Time, 6 p.m. CEST, the Nordic Network is going to give us a tour. And then just about a half an hour later, we get to visit the Proto Lab here at MIT's Center for Bits and Atoms. So Gershenfeld and his students are going to host us and show us not only the lab, but some of the research that they're doing here, which will be very cool. And then we're following that at 1:30. There's a very special session on the FAB16 research papers, which will be led by Peter Troxler and Cindy Kotala. So there's lots to be seen. And in between all of those live action pieces, there'll be lots of beautiful videos by the network. There will be a few co-hosts today. So I believe Marc-Olivier Ducharme will be joining us from Montreal. Is that right, Monique?
Yes, he will be with you in a few minutes.
Okay. Oh, well, that's good. And then this afternoon we have Beno Juarez from Lima, who will join us and host. And then we might have a few little surprise visitors that might pop up during the day. So keep tuned in. And so we'd love for you to stay tuned for on YouTube for the next 12 hours of eye-popping, heartwarming videos, live action, and fun. But before we do that, I would like to share my screen, because I wanted to give a shout out to the. I'm going to share my screen now, gang. All right, and I need to put this in presentation mode. Sorry. Okay. At any rate, I'm not sure how to put this in presentation mode, gang. But here we go. Presentation. So just to thank our distributed community. Yeah? You're not. Okay, because I did not share it properly. All right, hold on. Sorry, gang. Go. Now you should be able to see it. So just thanking our distributed community, Fab Academy, the Aegean Fab Lab, Barcelona, Botrop, there are a lot of labs, Oanina, the Nordic Fab Lab Network, Crefab, and then we also have the North American distributed labs, the African distributed labs, the Asia labs. So, and then we have our local hubs and our community partners. Yeah, local hubs, lots of local hubs, our community partners, and our graduation hubs. So all of you have made this wonderful experience possible. We just want to thank you so much and give you a big hand, big applause for the great work that you're doing. Monique? Oh, I think we need to hear Monique.
All right. We'd like to thank our incredible FAB16 Montreal partners and sponsors. So, of course, community, we are part of it. Centers of Bits and Atom at MIT, the coopérative Fab Lab Québec, Fab Lab Barcelona, Tourist Montreal, McGill and Jean, McGill Musculoskeletal Biomechanic Research Lab. Sorry.
I'm glad you have trouble with that. I did too.
And Procédurable, Dassault Systems, SolidWorks 3D Experience Lab, and Tratec, and the governments of Canada, the governments of Quebec, the City of Montreal, and les Offices Jeunesse Internationaux du Québec, and of course, the Fab Foundation.
I'm going to stop sharing my screen. All right.
And now I can announce that we're going to have some video from Montreal this morning. So we're going to begin with the Fab Labs de la Ville de Montréal, Fab Labs from the City of Montreal. And we have something special. That's a punch pandemic video. I won't say the punch. So, and we have the Fab Labs Nation tours that we made in 2017 to remember that we presented at Santiago in order to win the FAB16. And we have the 3D experience SolidWorks for makers after that.
And now, from Montreal.
il n'y a plus personne sur Twitter. Ceux qui restent, ils font que parler de pain de mie, ça me fait chier, tu vois. Pain de mie. Parler de. Pain de mie. Ils font que parler de pain de mie, ça me fait chier, tu vois. Pain de mie. Parler de. Pain de mie.
Pandémie. Pardon? C'est pas pain de mie, c'est pandémie. C'est une putain de pandémie.
Pain de mie. Parler de.
Pandémie.
Pain de mie.
Pandémie.
Thèse. Pain de mie. Thèse. Parler de. Pain de mie.
Pandémie.
Fun. Thèse. Pain de mie. Thèse. Fun. Ils font que parler de pain de mie, ça me fait chier, tu vois. Pain de mie. Parler de.
Pandémie.
Pain de mie.
Pandémie.
Thèse. Pain de mie. Thèse. Parler de. Pain de mie.
Pandémie.
Fun. Thèse. Pain de mie. Thèse. Fun. T'aimes la
Pandémie.
Because I have not found anybody in this area that has a similar interest, you know.
About 6 years ago, we had a problem in this town, and it was that the people who make things or like to make things had no place to interact. A couple of us got together and decided that we would change that by making a place.
I joined the makerspace to be able to network with local makers and nerds and be able to utilize our brains and collaborate on stuff and to build projects that we wouldn't be able to necessarily build by ourselves.
Puis ici, en fait, d'avoir un Fab Lab, je trouve que ça fait le pont entre la techno, l'aspect vraiment très technique et puis l'aspect plus créatif parce que c'est un espace de création pour moi.
It's something that I do that somebody else didn't think of, and there's definitely something that other people are doing that I'll never think of, and having a forum to really be a part of what other people are doing is, I think, very important.
On doit tous apprendre à se connaître, de diffuser ce qui se fait ici et ailleurs pour nous permettre justement d'avoir cette interrelation-là qui est souhaitable. De mon point de vue, elle est souhaitable, puis c'est ce que j'espère qu'on va pouvoir réussir à faire tout le monde ensemble.
In the course of our travels, we found a whole bunch of things that don't work. We found some things that do work, and we would be interested in sharing them with others.
Le partage au niveau aussi de la résolution de problèmes, là, on se familiarise avec les machines-outils, mais il y a peut-être d'autres gens avant nous qui ont vécu les mêmes problèmes, là, donc on peut ensemble se partager notre compréhension de tout ça.
currently training to be an engineer, so problem solving is my favorite thing to do.
Ben, moi, j'aimerais beaucoup qu'on fasse appel à Fabule pour des projets nationaux. Donc, on pose une question, puis nous, on peut essayer de travailler en atelier sur ces questions-là à l'intérieur du Fab Lab, puis qu'on documente tout le monde ensemble au même endroit. Je pense qu'il pourrait y avoir une motivation.
Si je pense à mes élèves, je trouve que ça leur donne une possibilité de rayonner. On est à l'éducation des adultes, tous les gens ont des parcours différents. Quand ils investissent du temps, quand ils investissent leur talent, ils peuvent ensuite avoir des répercussions auxquelles ils ne s'attendaient peut-être pas.
For me, it would be seeing something that made it easier to start these kinds of things and easier to expand them, to explain them, and add legitimacy to them.
I think it'd be really beneficial. Like in the past, we've been in contact with Maker Labs in BC, and they've really helped us just build a business structure and really gain understanding of what it actually takes to run a lab itself.
L'infrastructure, pour qu'elle soit en place, ça va être, en fait, c'est une force commune. C'est les idées d'un tous et chacun mis ensemble qui vont pouvoir rendre les idées à un autre niveau.
The members and the people participating in the Fab Lab are what make it a community. And so we want to reach out to the larger community. We want to be a bigger part of the Fab Lab nation so that we can extend this beyond our own borders.
Here at Hacksmith Industries, we use SolidWorks, the best 3D design software in the business, to make stuff like this, and this, and this. Needless to say, we would not have been able to make it real over the years without the help of their game-changing software. And that's why we're so excited to help announce that SolidWorks is changing the game again, this time for makers, hobbyists, and DIYers everywhere, with a new ultra-affordable offer just for you.
That's right. For the first time ever, we have a version of SolidWorks that's just for makers. And if the opportunity to get SolidWorks design software at a super low price for personal projects wasn't enough, you're also getting
next-gen cloud-based design tools like 3D Creator and 3D Sculptor that run on any device directly from a web browser, so you can make any type of designs from anywhere. The ability to collaborate with other makers and hobbyists like you from anywhere in the world, sharing your ideas, your 3D designs, and your questions and expertise with others who do what you do. Your own storage space on the 3D Experience platform with SolidWorks connected directly to it.
So are you ready to make it real? Check out SolidWorks.com to learn even more about what's included and how you can get SolidWorks today.
Thank you, Montreal. Thank you, SolidWorks. And now we have a guest from Uzbekistan. We have Ornella Marketchan. I'm not sure I got that right. Did I? How do you pronounce that, Ornella?
Yes, yes, Makrita Chan.
And so Ornella's live from Uzbekistan. Where are you in Uzbekistan?
In Tashkent, Uzbekistan.
In Tashkent. And so you have a lab there, or you're about to set up a lab there?
We're about to set up a lab.
Ah, all right. Well, I understand you have some video for us, so maybe I'll turn the air over to you.
I'm going to present, share my screen now. So it works. Hi everyone. I'm going to talk about the first Fab Lab in Uzbekistan today. And recently, the Government of the Republic of Uzbekistan approved a project called Youth Center for Inventive Creativity. And Fab Lab is one direction of our center. Our center will be ready in about half a year, and you may see how it will look like on this picture. This will be the first Fab Lab that will provide technological support to schools and technical universities, and will be equipped with the most modern full-cycle equipment. The main feature of our Fab Lab is involvement of young people in solving urgent problems of domestic enterprises in the real sector of the economy. And there are various ways to achieve sustainable development, and some of them are through innovation and continuous improvement. Fab Lab is a high-tech innovation center where anyone can design and manufacture almost anything from cars to simple household items. And Fab Lab is therefore focused primarily on innovation. Enterprises, on the other hand, prefer continuous improvement of technological chains and production optimization rather than innovation. Thus, in order to involve young people in solving urgent problems of domestic enterprises in the real sector of the economy within the framework of our project, we must implement the Kaizen ideology. Since Kaizen is a systematic tool that allows for continuous improvement of technological processes in industrial enterprise. On this slide, you may see how process improvement works by introducing innovations and how it works by using the Kaizen approach. And you may see how Kaizen approach is very efficient. Kaizen is a tool for continuous improvement, and it allows for loss reduction, improving the efficiency of devices, optimization of management, and correct organization. According to the Kaizen ideology, the potential for improvement in any industrial enterprise is very large, and losses should be identified to make improvements. Examples of losses could be overproduction, stocks, transportation, defects, excessive processing, displacements, downtime, unused staff potential, and etc. The Deming cycle is a method used in the Kaizen ideology for the control and continuous improvement of processes and products. As was noted in the report Factor 4 produced by the Club of Rome, we can live twice as good at the same time spend half the resources that is necessary for the sustainable development of humanity in the future. And the solution is to use electricity, water, fuel, materials, fertile land, and etc. more efficiently, often at no additional cost and even profitably. This ideology makes it possible to integrate the Fab Lab ideology with the IAC program. IAC stands for Industrial Assessment Center Program and is funded by the US Department of Energy, and its main objectives are: first, training of the future engineers based on a practice-oriented approach implemented at specific industrial enterprises, and second, provision of services to industrial enterprises to improve energy efficiency and reduce greenhouse gas emissions. As of August 2021, there are 31 IACs in the United States based in their most technical universities. Centers conduct research in the field of energy efficiency through energy audits and industrial plants. Within the framework of our project, it is planned to simultaneously create a Fab Lab and a company operating as an IAC. The IAC in Tashkent, Uzbekistan will conduct energy assessments to identify opportunities to improve productivity and competitiveness, reduce waste, and save energy. The IAC will conduct energy audits for industrial enterprises to create a technological map and formulate their actual problems. The Fab Lab will then provide the digital manufacturing of devices that will solve the identified problems. Finally, within the framework of our project, we're intending to create a legal group that will be specifically working to help the Fab Lab community. It will be tackling various legal issues with a focus on intellectual property rights. There is an increasing tension between the public domain and proprietization and regulations, and providing legal help to individuals in disputes related to intellectual property rights is essential. Individuals want to create, however, roaring intellectual rights may hinder innovation. Our goal will be to strike the right balance to protect the public domain and individual creators. In the long term, we're thinking to expand our legal services into other areas of law and to offer our services to our fellow Fab Labs around the world. Thank you for your attention. We hope that the Fab Lab community will be interested in the proposed new directions of the Fab Lab development in Uzbekistan, and that our proposal will initiate a discussion on the further development of the new approach. I'm going to stop sharing my screen now.
Thank you, Ornella. This is amazing. So your Fab Lab will be really focused on sort of manufacturing and how you use maybe the Kaizen protocol, right, for efficiency and for sustainability, and also you'll be offering some of the services, including intellectual property, legal services to the rest of the network. Is that right? Is that what I understand?
Yes.
Yeah.
Yes. So it's very interesting for us to create our project because, firstly, we'll involve young students. Then, yes, we'll be trying to achieve sustainable development in Uzbekistan by using our equipment and our young potential. And thirdly, we'll be creating a legal group to provide legal support to our students, to other Fab Labs in the world, and tackling various legal issues.
So, what's your timeline? When will all of this be ready and available?
So we're planning to open our center in 6 months.
In 6 months. Well, I have to say congratulations. Welcome to the network. We are so very excited to have you.
Thank you very much. Thank you.
So next up, we have several videos from Spain and specifically from Barcelona, that design capital of the world and the heartbeat of one of the heartbeats of the Fab Lab network. And we have an entry from Ireland as well. So with that, let's take a look.
Kia ora. I'm Wendy Neal. I'm talking to you from Wellington in New Zealand, right down at the bottom of the planet in a completely different time zone than most of the rest of the planet. It's raining, it's winter. I've been the director of Fab Lab Wellington up until a couple of months ago, and I started that in 2012 when we hosted Fab8 in New Zealand, which was amazing. But the first Fab Lab I ever went to was Fab Lab Barcelona. And when I first saw it and met the people, I was like, this is going to be magic in New Zealand. The people, the connections, the projects. And I was right, it has been absolute magic. The thing that I've absolutely loved about being involved in the Fab network is the people, the understanding and the connections, understanding the economic, spiritual, social, cultural differences, yet that we can work together with or without a bit of friction, but often with a lot of fun. I did Fab Academy in 2013. I had no idea how difficult it was going to be, but it was a great challenge. Bars, our mentor, talked with us once a week from Iceland and helped us with a lot of problems because the classes were at 3 o'clock in the morning for us, so we could only watch the videos and we didn't really connect with everybody. Until Fab9 when we graduated in Japan, which was a fantastic conference, and I am only sorry that I was so unwell. I had the flu during that time. But as I said, the connection with the people, the best experiences that I've had, or the most memorable experiences that I've had, was in 2018. I was really fortunate. I was able to go and live and work in Dubai, work with Fab Lab UAE for the first half of 2018. And then after that I went to Amsterdam and participated in Fab Academy. And during that time I visited so many other people, fab people, in their own, in their natural environments, whether that was Egypt, Lyon, Switzerland, and I also had people come and visit me while I was in Dubai and in Amsterdam, and it was fantastic. And you can appreciate in New Zealand, not a lot of people come and visit here. People have. Since then, I decided that I needed to come home and become more locally productive again. And you know, it has been a pretty good time, and it's been a tough couple of years for all of us, and some of us more specifically. I've been involved with food fermentation, food sovereignty, and developing vernacular architecture in New Zealand. So it's exciting times. I hope you're all enjoying the conference and connecting with each other, and I wish you all the best.
Hi everyone, long time no see. For those who don't know me, I'm Alex, and I started the Fab Lab Amsterdam back in summer 2008. What was really interesting is that even only 3 months in, one day my colleague Bas van Abel came to me and said, "Hey Alex, there is this Fab Academy program, a pilot from Professor Neil Gershenfeld at MIT Boston, and we can participate as peers for the first time." And I thought, well, that's interesting. When does it start? And he said to me, well, today from 6 o'clock. And I thought, well, all right. Okay, let's try. So that was a really hard journey because I had no mentor. Luckily, there were these awesome guys like Jonathan Ward, who really gave me a lot of support, and that was also the beginning of video conferencing, which was at that time new to me, talking about fall 2008. And so I went through the whole program along with Frosti Gislason from Westbanier and Thomas Diaz from Fab Lab Barcelona, among a few others, but most of them gave up. But Thomas and me, if I remember correctly, we did the whole program together. And so after that, a year later, I had my most amazing time in Norway at the Fab Lab Lingen, along with Neil Gershenfeld, the crew from Barcelona, among others. And I never forget, I had this wonderful tortilla made only from onions by no other than Vicente Gallard. Well, for almost 10 years, I ran the Fab Lab in Amsterdam. We had the most wonderful FAB6 conference back in what was it, 2010 or so, 2009? I don't remember exactly, but it was a great conference. So since 2017, I started this place here, which is called Contact, which is a sort of breeding zone. We have about 40 tenants in the house, 2.5 square meters of space, and a big lab, actually 2 labs, a smaller one and a bigger one. Of course, I have a full-size milling machine, which is actually also an interesting project that I did together with my dear friend Jens de Wiek, which you know as well probably. He went into machine design and he designed these awesome fabricable machines, as he called it, and together with him in Oslo with 2 shop bots, we created the first full-size milling machine together, which was really exciting and quite a job. 10 days milling on aluminium on 2 machines simultaneously. I changed some mechanics on it. I did precision glide blocks and then ball screws, and now it has really a good precision. About 50 micron, like the modeler, but I'm not really out of the network. Actually, I'm doing still the same. It's just not called the Fab Lab here, but a makerspace. And just what I'm doing now, very recently, is I try to focus on design for animals. I started to design like Bauhaus type of birdhouses, and also want to make houses for owls and bats, but also I want to do high quality houses for cats, dogs, and among other stuff, but always with a focus on design for and with animals. What else can I say? I really miss you all, because one of the things I always enjoyed the most is all of you.
She Makes is an international She Makes is an international community of partners and labs engaged in empowering women to innovate and contribute to a more sustainable textile and clothing industry. She Makes offers a series of opportunities for inspiration, skills exchange, and networking. Our community combines 2 powerful networks, Fab Academy and TCBL, which is short for Textile and Clothing Business Labs. Fab Academy is a group of Fab Labs that provides higher education at the intersection of digital fabrication, textiles, and biology. For She Makes, these labs are developing a free series of modules to learn skills that combine tech and textiles, such as wearables and smart devices. These activities are models that can be brought into any space, from libraries to museums, incubators to businesses. Labs are also thinking about how to overhaul existing production processes, like, is there a better way to make wool? Through workshops and working together, we'll find out. The other half of She Makes, TCBL, focuses on the business side of things ensuring that the business and social innovations that come out of She Makes Labs are tested in real-world situations. TCBL associates, from companies to citizens, meet in real life or online to discuss the latest trends in sustainable fashion and imagine how we can work together to transform the industry. Together, She Makes partners, labs, and companies are focusing on female innovators in textile and clothing. Why? Because women in this industry tend to be in the lowest paying jobs, and their natural and acquired skills just aren't valued. But women managers statistically generate more success than men and tend to be more focused on social and environmental issues. So that's why we need more female fashion innovators at the helm, building a sustainable future for all of us. If you believe in the values of innovation, sustainability, and equality, take a look at the shemakes.eu website and social media. Sign up for our newsletter or reach out to one of the participating labs to take an active part in the future of fashion. She Makes has received funding through the Horizon 2020 program. For more information, see www.shemakes.eu.
Now that you are wearing the future, how you feel?
It's smelly, I would say, but no, but it's great. It's like I'm feeling that I'm wearing something that is light. The texture is totally different from the aesthetic.
Feel comfortable or uncomfortable?
I mean, the form is super comfortable, so I would say yes, comfortable. But it's like feeling that I'm wearing like a nomadic lifestyle, you know? This is like something that I really can feel back.
Can you imagine a future where you can grow and craft your own clothes?
If we want to be really honest about this, maybe we can see it in really long future, but not so close, because people still don't understand what's happening in their environment yet. Like we don't have enough knowledge about bio stuff, and then when you try to make them understand, it's sort of like saying, this smell, this like gonna be disgusting or something like this. But at the end, you will see the benefit of this systems.
Do you think you will join the revolution of biomaterials?
I think we are in the revolution. It's happening now. It's not just like yesterday or it's not going to be tomorrow.
So will you spread the voice to your friends and relatives?
Absolutely. The minimum thing that I can do for the environment is just trying to help people to understand that there are alternatives.
Can you imagine a future where you can grow and craft your own clothes?
I think it's difficult if the system is like now, because today we can grow our vegetables or whatever in our garden, but maybe we don't do it because we don't have the tools or the time to do it.
Do you still think that there are no alternatives to plastic?
No, I think that we have alternatives. We need them because plastic is finite and vegetables apparently are removable. You can do one time, twice, and whatever. It's different the industry also, I think, and the impact in the environment. And I think if we think we are wearing vegetables or things, natural things, it's warmer and it's more nice to our souls.
Now that you are wearing the future, how you feel?
I can smell wood inside of my mask and I love it. The poncho is super warm and comfortable and I feel really cozy.
Can you imagine a future where you can grow and craft your own clothes?
I couldn't think about it because I always heard about it and now that I'm wearing it, it's different. I can feel protected and it's nice. It's a really good sensation and feeling on my body.
Do you feel you are reconnected with nature?
Yes, I feel the elements around me, so I can smell wood, I can feel the fibers on my skin, and it's really nice.
Do you think is a way to hack the fashion system?
Yeah, I think it's important to spread because people just don't know. We think that there are no alternatives, that there is no way, but I think the problem is that people cannot imagine it, so it's important to show them that it's possible, it's here, and we just have to change our perspective and our bad habits.
Now that you are wearing the future, how do you feel?
It feels reassuring, really. It feels connected. The material, it feels real, and it's guilt-free, and feels like a warm hug from nature.
Can you imagine a future where you can grow and craft your own clothes?
I could possibly imagine a morning where you wake up and you step into an organic goo, and you grow a shoe in a few minutes to use for the day.
Do you think is a way to hack the fashion system?
Making our own garments is definitely a way to hack the fashion system. This is something that that in India they did. Gandhi did his own clothes, and I think making your own clothes is empowering, and it's some sort of a really effective rebellion against an industrial machine.
Do you still think that there are no alternatives to plastic?
I always thought that there are alternatives to plastic. The mixture of the body of this material that gives structure, it's a really effective one, and I truly believe that that it could be a strong alternative to outdoor garments.
Do you think you will join the revolution of biomaterials?
Yes, I would definitely want to join the revolution of biomaterials. Especially, I would like to investigate it using in our everyday objects and furnitures and other industrial applications.
Welcome to Fab Lab Barcelona. Action research. People-centered approach to innovate using technology, digital fabrication, and circular economy principles to improve global and local livelihoods. education. Contemporary learning programs to support growth and innovation to achieve goals and understanding for future challenges. Strategic partnerships. Helping organizations to foster a dynamic, authentic, humane, and sustainable culture of innovation.
At Science Gallery Dublin, we set out to tackle mental health and wellbeing management in young people. We created an open call for people to get involved in the journey, to dream up potential ideas and to bring their solution to life. This cultivated a diverse gathering of young people, mental health professionals and charities, teachers, parents and researchers. The group quickly identified education as a key avenue to support young people, and they co-created the Open Mind educational programme, with tools and activities to equip young people to manage their wellbeing. The programme was piloted and refined over several iterations in schools nationally. The main goal of the Open Mind programme is for students to learn the importance of having personal hobbies and interests and to empower them in their school community.
We aim to see the Open Mind Toolkit embedded into the national curriculum and used by schools across the country. Furthermore, we hope this pilot can act as a pathway to the Irish education system to adopting a co-creation methodology across the board and involving young people in all curriculum design. This will foster collaboration between policymakers, teachers and parents to centre the student voice in learning and well-being. We demonstrated the value of using youth-centred co-design to develop educational programmes. These learnings can be used to equip schools to work with students as active contributors and initiators of their learning. This will foster an environment that focuses on promoting wellness through co-creation and student empowerment, ensuring the student voice is centred in the development of learning practices.
Kia ora. I'm Wendy Neal. I'm talking to you from Wellington in New Zealand, right down at the bottom of the planet in a completely different time zone than most of the rest of the planet. It's raining, it's winter. I've been the director of Fab Lab Wellington up until a couple of months ago, and I started that in 2012 when we hosted FAB8 in New Zealand, which was amazing. But the first Fab Lab I ever went to was Fab Lab Barcelona. And when I first saw it and met the people, I was like, this is going to be magic in New Zealand. The people, the connections, the projects. And I was right, it has been absolute magic. The thing that I've absolutely loved about being involved in the Fab network is the people, the understanding and the connections, understanding the economic, spiritual, social, cultural differences, yet that we can work together with or without a bit of friction, but often with a lot of fun. I did Fab Academy in 2013. I had no idea how difficult it was going to be, but it was, a great challenge. Bars, our mentor, talked with us once a week from Iceland and helped us with a lot of problems because the classes were at 3 o'clock in the morning for us, so we could only watch the videos and we didn't really connect with everybody until FAB9 when we graduated in Japan, which was a fantastic conference, and I am only sorry that I was so unwell. I had the flu during that time. But as I said, the connection with the people, the best experiences that I've had, or the most memorable experiences that I've had, was in 2018. I was really fortunate. I was able to go and live and work in Dubai, work with Fab Lab UAE for the first half of 2018. And then after that I went to Amsterdam and participated in Fab Academy. And during that time I visited so many other people, Fab people, in their own, in their natural environments, whether that was Egypt, Lyon, Switzerland, and I also had people come and visit me while I was in Dubai and in Amsterdam, and it was fantastic. And you can appreciate in New Zealand, not a lot of people come and visit here. People have. Since then, I decided that I needed to come home and become more locally productive again. And it has been a pretty good time, and it's been a tough couple of years for all of us, and some of us more specifically. I've been involved with food fermentation, food sovereignty, and developing vernacular architecture in New Zealand. So it's exciting times. I hope you're all enjoying the conference and connecting with each other, and I wish you all the best.
Yo llevé el Fab Lab del 2011
Hi everyone, long time no see. For those who don't know me, I'm Alex, and I started the Fab Lab Amsterdam back in summer 2008. What was really interesting is that even only 3 months in, one day my colleague Bas van Abel came to me and said, hey Alex, there is this Fab Academy program, a pilot from Professor Neil Gershenfeld at MIT Boston, and we can participate as peers for the first time. And I thought, well, that's interesting. When does it start? And he said to me, well, today from 6 o'clock. And I thought, well, all right. Okay, let's try. So that was a really hard journey because I had no mentor. Luckily, there were these awesome guys like Jonathan Ward, who really gave me a lot of support, and that was also the beginning of video conferencing, which was at that time new to me, talking about fall 2008. And so I went through the whole program along with Frosti Gislason from Vespanier and Thomas Diaz from Fab Lab Barcelona, among a few others, but most of them gave up. But Thomas and me, if I remember correctly, we did the whole program together. And so after that, a year later, I had my most amazing time in Norway at the Fab Lab Lingen, along with Neil Gershenfeld, the crew from Barcelona, among others. And I never forget, I had this wonderful tortilla made only from onions by no other than Vicente Gallard. Well, for almost 10 years, I ran the Fab Lab in Amsterdam. We had the most wonderful FAB6 conference back in, what was it, 2010 or so, 2009? I don't remember exactly, but it was a great conference. So since 2017, I started this place here, which is called Contact, which is a sort of breeding zone. We have about 40 tenants in the house, 2.5 square meters of space, and a big lab, actually 2 labs, a smaller one and a bigger one. Of course, I have a full-size milling machine, which is actually also an interesting project that I did together with my dear friend Jens de Wiek, which you know as well probably. He went into machine design and he designed these awesome fabricable machines, as he called it, and together with him in Oslo with 2 shop bots, we created the first full-size milling machine together, which was really exciting and quite a job. 10 days milling on aluminium on 2 machines simultaneously. I changed some mechanics on it. I did precision glide blocks and then ball screws, and now it has really a good precision. About 50 micron, like the modeler, but I'm not really out of the network. Actually, I'm doing still the same. It's just not called the Fab Lab here, but a makerspace. And just what I'm doing now, very recently, is I try to focus on design for animals. I started to design like Bauhaus type of birdhouses, and also want to make houses for owls and bats. But also I want to do high quality houses for cats, dogs, and among other stuff, but always with a focus on design for and with animals. What else can I say? I really miss you all, because one of the things I always enjoyed the most is all of you people. Thanks very much. Have a good time. Cheers. I remember those? If not, ask Neil. Ciao.
Hello, this is Alejandra Diaz. I say hi from Mexico. I am Mexican. I'm living here in Monterrey right now. And I am the co-founder of Fab Lab Kids. I co-founded it a few years back in 2014 with Hilaria Lamana and Alex Garcia. We were very active for many years, and then when the pandemic started, and also when Hilaria moved to Qatar and we started having different time zones to work with, well, Fab Lab Kids started to be less active, and that's why probably you haven't heard from me in a few years. But well, the first time that I heard about a Fab Lab was from Vicente Guayar. He was giving a talk in IAC where I was doing my master's degree. He introduced the subject and I just fell in love with it. Of course, the first Fab Lab that I visited was also Fab Lab Barcelona. And after my master, I decided to stay there and do the Fab Academy program. So it was great to do the Fab Academy there. It was packed with a lot of people. So I was also going back and forth to Sitges, to Beach Lab with Francisco. So it was fun. It was really great. And I love the Fab Academy. I think it's a great program. It demands you to learn many skills, not only technical skills, but different soft skills in a very short period of time. So you have to work under pressure, but at the end you learn to be able to, integrate different things into one functional project. And I think that's very important nowadays. I love the program. I think more programs should be like that. And I teach at the university, and sometimes I still send my students, to the repository to check what's there and to, follow the documentation if they want to know how to make something. One project that I remember that is probably the best one that I've seen in Fab Academy is Roberto Gallo's Beaten Atoms pen. It's a pen that creates a G code as you are writing or drawing, and it sends it to a machine. So as you are, moving your hand doing things, it's actually also creating something in the laser cutter or the 3D printer. So I think it's genius. It was very well executed, and probably my favorite project from all. I'm still working with Fab Labs. We recently opened a Fab Lab in a community here in Monterrey, but I'm not working maybe in the Fab Lab network, where I'm working a lot locally, bringing education and STEM education and Fab tools to children and young people here in Mexico. We're working with many ministers of education and culture, and it's been very cool. But my main focus right now is in my PhD. I wanted to formalize all of these skills that I gained from being part of the Fab Lab network, because I'm an architect, but I was very interested in learning about science, technology, and engineering. So right now I'm halfway of my PhD in engineering science. I hope to be back into the more active in the network when I'm done with that. And then, of course, I also had a child. I have a girl that is 1.5 years right now. So that's my other full-time job. And it leaves me a little time for interactive, but I'm very excited to go back. So you're probably gonna be hearing from me soon again. And well, for now, I just say, have a great Fab16. See you soon.
Hi, my name is Eloise. I'm from Brazil. I started my Fab life in 2012 when I did the Fab Academy at Fab Lab Barcelona. It was Benito Juarez, my friend from Peru, that showed me this fantastic network. I started the Fab Academy, and for me the big surprise was the horizontal and collaborative learning. It was fantastic to have the guiding, of course, of Professor Neil Gershenfeld, giving us all the technical part, talking about the process, the techniques, but learning with our peers, with our colleagues, presentially or not, was the big surprise for me. It's something that I bring with me in my work, in my professional life, in my personal life. It's something that I really believe. I studied with a small group. We were 5 or 6. I studied with Santi Fuentemilla from Barcelona, Mark, Rumin, Blanca Duarte, and Tomás Frontilla. It was amazing to learn from them. It was amazing to give the skills that I had at this moment. It was really a family studying together. We are friends until now. It's amazing. At the Fab Academy, I also had some help of people that were not at Fab Lab Barcelona but studied at the same time. Núria from Leon, a bunch of people from Fab Lab Amsterdam, and it's one of the most wonderful experience that I had. Fab Academy is really that. Well, nowadays I'm in France. I'm living in France with my family. Actually, I met my partner inside the Fab Lab network. I'm still connected with the Fab Lab. I created a company in 2014 to bring to big companies the Fab Lab practices like collaboration, agility, creativity, prototyping. I created a methodology that help big companies to develop new services, products, and experience through the principles of maker movement. We help them to work in a more hands-on way. It's amazing to see how we can give them more productivity and more innovation, but also it's really nice to see the impact of that in the life of people working with us. It's a mindset change. After this experience, they rethink the way of work, what they want to do for life. It's really amazing to see the impact of the practices into people. I'm also working in a parallel project with an innovation center here in France. We are creating an entrepreneurship program in Angola. I'm leading the part of opening a Fab Lab to support the incubator, the master program, and the research market lab. The idea is to help people from Angola to develop some skills that they don't have at this moment and to enter the market job easily. I hope this Fab Lab will be open next year, and I'll be happy to come here and tell you a bit more about this beautiful project.
Hello, everybody. My name is Victor Freund or Freund, however you want to say it. I mean, it's okay for me. I remember that about the Fab Lab movement, I knew about it in 2008 or 9. I remember that we had this program like a scholarship that I took with some people. Here, I want to share with you the background of that. I have that image. Yeah, here you can see the people in Peru. We were part of this, the idea was to get a scholarship to study the Fab Academy in Fab Lab Barcelona in 2009, when the Fab Academy used to take like 1 year. And I was very nervous because I didn't know anybody. But luckily, I got it, and I had the opportunity to travel for the first time to Europe and know these beautiful people that I know today. I began in the Fab Lab Barcelona, but part of the program with ISC, with MIT, with IAC was to implement the first Fab Lab here in Peru with my friend Benito Juarez that you know. And we had this first Fab Lab at UNI, that is the Universidad Nacional de Ingeniería. I remember that my mentor was Thomas, Thomas Diez, the famous Thomas. Here you can see Thomas. And I also about the classmates. Yes, I have another picture with my classmates. Here you can see it. Here you can see Beno, Melat, Susana, Bereketnesh, Neil, myself, Asheshim, and Tomas. We were really young, we were innocent. We didn't know about the problem that we were going to cause in the future, and we didn't know about the impact that it was going to have now, no? And share. I remember, I know, maybe the anecdote is that with the expressions from the Spanish people, like "que pasa, tío," that I didn't understand. It's like, what do you mean with "que pasa"? What's going on? Nothing is going on here. No? And I know, maybe there are a lot of anecdotes. Maybe the time that it began to snow in Spain, I really loved that day. And I don't know if everybody loved the snow, but I loved it because I was not used to that. No, well, come on. I mean, we all know that the Fab Academy, all the programs from the Fab Academy or the Academy are great. I mean, we learn a lot about the digital fabrication tools, but not only that, we also learn about, for example, how to talk with people, how to share our thoughts, our ideas, how to connect with people from any part of the world at any time, any day. And that's what I really love about the program, about the Fab Lab network. No, as a student and as a mentor, yes, it allows us to know the people, to understand their feelings, their concepts, their needs, their problems, the happy moments. I mean, it's a great opportunity to share a lot of things. No? Well, I admire a lot of people. Come on, but I don't remember all the projects actually. But what I really remember is this. No, it was my first experience with the board. No, with soldering. Making my board, no, it was a really nice experience. Yeah, I think the picture is like it's not correct. Maybe you can try to have it in reverse, or mirror, but it was a great project. Actually, I mean, in the present, I'm not doing that. I'm not working on electronics or soldering or programming. But I really miss that part of the Fab Academy. I hope I can have the time to continue with that because I really enjoyed to have the patience to do it. No, now I'm working in the public sector. I have been like a consultant in different entities from the public sector here in Peru. For example, in tourism, also in the Ministry of Transports and Communication, also in Concitec, that is the entity that promotes science here in Peru. So yeah, I've been part of different public entities and also universities and institutes. No, the idea is to help public servants understand about the potential of these new technologies in order to solve the different problems or needs. No, so now what my future plans are, I don't know yet. No, I always look for different projects. I always enjoy the projects because I always try to find different adventures. No, I like to know different people from all the part of Peru, from all the world, but I want to continue in the public sector. No, and so yes, I hope I can continue working in the public sector and trying to connect with the Fab Labs and all the network and all the people, because I believe that we can share as people, we can share a lot of things. I mean, from everybody, from anyone, from all the parts of the world, different mindsets. I mean, that's a huge potential that we have to develop as a network, no? So that's the video. And thank you very much for this opportunity. I think it's taking too much time to talk about it. But I hope to see you soon. No, see you in some weeks, in some days, actually, no, virtually, and maybe in the following years, maybe I can visit, no, and the new location, and continue with this adventure of the Fab Lab. Thank you, guys.
Fab TV, and thanks to Nuria to invite me to do this. So for the people that don't know me, my name is Hilaria Laman, and has many architects in the Fab Lab world. I started with the master 10 years more in 2010, at YAC in Barcelona, and then I was involved in the Fab Lab where I developed the project, the open thesis fabrication project, and then I stayed there also for develop some project. I remember, of course, my mentor and guru and professor of YAC, it was Thomas Diaz, and I remember that I started to design the first kit of Smart City, that was a small box in acrylic with all the sensor inside. And yes, I remember that was my first project inside Fab Lab Barcelona. And during that year, I also had the chance to meet Victor and Bano, that they were doing the academy actually there. And always there was all the machine and everything and there. So the machine and Victor, the machine and Beno, all the time, 24 hours in the Fab Lab. And I remember that Victor, I didn't know very well him at the beginning, of course, and I was watching him that he was going to the toilet always with a notebook and a pencil. So I said, I got expiring in the toilet, and he does the idea in the toilet. So it was an anecdote that I remember of him. And of course, then I went out many times with him, also late party, and was not expected from him, but was nice time, long time ago. And about the academy, actually I didn't do the Fab Academy, but I did the Bio Academy, that changed a lot my mind and actually my passion about bio design. So I really recommend for of course the big network of people connected, in this case in biotechnologies, that you can have, and also for the knowledge that it's something different, for example, that you can teach at the university. And from I think 5-6 years I'm giving class to the University of Argentina, now online, but also in the university in Italy, and also in Qatar where I am. I'm giving class about biodesign, and everything started because of the Bio Academy. And then where I am now and what I'm doing now. So I'm in Qatar since almost 3 years, running a Fab Lab design for youth from 7 to 18, that it's supported and is a governmental project from the Ministry of Transport and Communication. So here is where I am, and actually yes, I'm more round than usual because I'm in my 8 months, almost 9 of pregnancy. And yes, this is my life, always change place to live, and my life according of the Fab Lab where I am. So start from Barcelona, then jumping to Argentina, Latin America, Italy, and now Qatar. So thank you and bye bye.
Hi, my name is Tomás Diaz from Fab Lab Barcelona. I started in the Fab Lab movement in 2006 when I arrived to Barcelona from Venezuela. I was supposed to stay 5 months to finish my urban design degree, and then by coincidence I got in front of the challenge to set up the first Fab Lab in Europe in the European Union. Fab Lab Barcelona, which we managed to open in 2007, in March in 2007. I had many mentors at the beginning, of course. Maybe the two most important ones have been Sherry and Neil. For many reasons, for the knowledge, for the support, for the care they have put in building this network together with a group of a global team. And also I had some local mentors such as Lucas, Victor, Vicente, Caroline Lichtenberg, who really supported me in specific moments in my Fab life. I had my year on the Fab Academy or Academy was very special. I was part of the team that made the Fab Academy 0, so it was 2008. And my classmates as Alex Schaub, who is somewhere, I think, somewhere in the Netherlands, also working in the maker movement, and Victor Viña, who really was a crazy person who I learned a lot from. One of the key anecdotes, I think, for me inside the Fab Lab network is the fact that it's something that it found me in a way, and it was a perfect match, and here I am around 15 years later, still engaged in projects that connect directly to it. So for me, the Academy, is a key platform for the growth of a Fab Lab network and also to expand its impact in society. We started with Fab Academy. As I said, I was part of the initial, batch of students, but also I coordinated it for a few years. Then I passed this role to Ana Casiunas, and then to our beloved Luciana Sinari. So I saw it growing, and I saw how important it was as a glue for the network. No, there is a Fab Lab network before the Fab Academy, and there is a Fab Lab network after the Fab Academy, and I hope it happens the same with the Academy and brings a lot more possibilities. Many projects are important for me. I think that I admire anyone that finishes the Fab Academy, to be honest, and also I admire a lot the mentors of the Fab Academy, the gurus, the tutors, because I know how hard it is, not only at the global level, but especially at the local level, in order to help students to develop their ideas and take them to reality. My big current project is Fab City. As you know, I'm trying to, together with an amazing team of humans, we are creating the Fab City Foundation, which is already established. It's based in Estonia, but it's a global team operating from Colombia, from Barcelona, from other parts of Europe, and from Indonesia, where I am also. I'm planning to open also here a Fab Lab Bali, in collaboration with my local partners, which are part of what we call the Meaningful Design Group. And I think that the next big project, or the project that will always be part of my life, is helping to support this network and make it more relevant for society, and making it a key element to transform the way we live, work, and play in cities, or anywhere that we are, but also to fundamentally transform the way we produce and consume almost everything, in order to detach ourselves from systems of extraction and systems of oppression and colonization. So I hope that you share some of these goals, and we're always open in Fab City, in Fab Lab Barcelona, and soon in Fab Lab Bali, to work together to make it happen.
Talking about someone that I would like to have news, I'm curious to see what José Pérez de Lama is doing at this moment from Fab Lab Sevilla. We worked together there for 6 months. It was amazing time too in this Fab life. I don't have news for the last years. I would like to know what José Pérez is doing and what Fab Lab Sevilla is doing too.
Friends, again, with this picture, I miss everybody. I miss all of you, actually. No, but I think I would like to know about, for example, Melat, about Susana. Come on, I know about Beno, Thomas, or Neil, but I want to know what happened with them. Melat, where are you? Susana, what about you? Bereknesh, Bex, Ashashim, our friends. I really miss you, and I miss you all. And I would like to know what's going on with you, what's happening, what you are doing, and maybe in the future we can develop new things.
And I would like to know about Beno Juarez. What is Beno? I was used to, when working in the Fab Lab and the Amazon project, I was used to know about him, float with him, but I lost it. So ¿Dónde estás, Beno Juárez? Por favor.
This whole concept of soccer table a little bit further and make it really our own thing, and very importantly, make it open source. It could be a very good learning project since you go through all kinds of digital fabrication methods.
Table got a video camera in it, it got electronic scoring system, it got sensors, so everything is interactive and automatic. We can do something more sexy, you know, like something that is nicer to see than just LEDs.
E c'è la rete olandese con dei dubbi sulla posizione di un altro giocatore, ma il tocco di Van Nistelrooy. Dobbiamo rivedere.
This has to be the best documented project we have ever done so far.
Well, thank you so much to the teams from Spain and Ireland. Those were amazing videos. She makes, continues to impress us. They're showing the power of women, yes! And the Fab Academy documentary on the Eco Chamant Guard project was pretty terrific and inspiring. EAC and Fab Lab Barcelona are a force. But I have to say, what a treat it was to see Wendy from New Zealand. I think she may have gone to bed now, but she was in the YouTube stream earlier. And Walter from Peru, at his best, of course. And to hear from Alex Shaw, boy, Alex was here pretty much from the start. And he was part of the first group to take Fab Academy back when Neil was experimenting with the distributed class. I think that was in 2008. And he and Tomas and Danny from Barcelona, all those guys, they really didn't have many mentors from the Fab Lab network to work with. So they were really kind of feeling their way through all of this. So Alex, we miss you too. And Alejandra, Eloise, Victor, Ilaria, Tomas, etc. That was just, they were just amazing. But they all remind me, and they all remind us that the community really isn't about the machines, and it's not really about the technology. It's about the people, these very special people, and how we share and how we collaborate. It's a very special community, and you know, we've been growing for almost 20 years now, which is pretty astounding. I think the first lab was in 2002, back in rural India. And so, I mean, that's quite a while. So if you don't mind, I'd like to share my screen with you for just a moment. I'd like to remind you that we have about 3 more hours. Sorry, I shared it. No? Okay. No? Oh, sorry. Wait a minute. Hold on. Hold the door.
To Zoom.
Yes. Okay. There we go. No, this one. Okay. Share. Okay. Now we got it. If I can figure out how to present. There we go. So we only have about 3 more hours before our license, so to speak, expires for The Peacemaker Returns. This is that amazing film, new film by Skawanati. And so I would encourage you, even though it's competition, I'm going to stop sharing my screen now. Even though it's competition, I would encourage you to try to see this because it's a very special opportunity. Let's see, what else do we have going on today? Well, I believe Marco, we have Marco here from Montreal.
Good morning, Sherry. Good morning, everyone. How are you?
I am well. How about yourself? What's going on there in Montreal?
Good. Today's rainy, and today is everybody's kind of in a rush for the Fab City Summit. So that's going to be quite interesting. And then a little bit later, we have a conversation with Guillaume, with Ponsavin, with Monique. So that's going to be interesting as well. And we will probably show you how to make poutine if everything goes well, and we can make poutine live. so we'll try to do that.
That sounds great. Well, you know, before I turn it over to you to Marco, I think we have one special thing we'd like to do.
Yeah.
I think we have just one moment that we'd like to take to congratulate Adrian Torres from Lyon, because it's his birthday today. Happy birthday, Adrian.
Happy birthday.
Hello.
This is a really big, yay! This is a really big week for you. It's a big week.
Thank you so much. It's amazing to participate in this Fab event. I think it's better face to face. We hope to see you in Bhutan this next year, and thank you so much for my birthday.
Well, Adrian, it's a big week. You graduated from Fab Academy. Was it yesterday or the day before?
The Monday.
On Monday. So
Fab Academy, yes.
And now you've been helping us produce Fab16 from behind the scenes, and you're celebrating your birthday. So just to help you along, I think we would all like to sing happy birthday to you. So, happy birthday to you. Happy birthday to you. Happy birthday, dear Adrian. Happy birthday to you.
Yay!
Thank
you so much.
I hope you have a great celebration tonight if you're not too tired.
Yeah,
Nice
thank you
to see
so
you.
much. Thank you.
All right. Well, Marco, the air is yours.
So we have much content, but first of all, I will transition to Luc. So Luc is, I'm not sure where Luc is actually. He's in Europe, but I'm not sure where. Luc, the floor is yours.
Yeah, we are in France, in Beauvais, but and we are in AgriLab. And as you can see, I have many people behind me because we are holding a regional gathering. And it's not just, it's the result of a really great year of collaboration with several Fab Lab, and I will let people the time to quickly introduce yourself. But how did we arrive to this kind of gathering? Each week, just before Neil lessons, we meet all together and we exchange between instructor, also students, like what did you do, what kind of idea, and this is really create a bond between people, and that was of course because of the pandemic virtually done, and so we are so happy to meet today and the day before together. And also we did a lot of great practical hands-on workshop, and I think the following people will have a bit of time to present themselves and maybe show quickly what they just did.
Yeah, I'm Henk from the Waag Fab Lab Amsterdam. I had 8 students, so a part of them is here behind me. Quieter. Louder. Lower. Louder. Okay. I had 8 students. They all graduated. They made perfect projects. And what Luc told so about the original gatherings, so it was not only helpful for the students and helpful for the instructors, but it was also fun. So I thought the biggest part of this event that we're now having live here in AgriLab is the social event. So at night we eat and drink together till late at night, and it's big fun. Okay, so.
Hello, I'm Nicolas from Fab Lab ULB, University of Brussels, French-speaking university. I'm here with one of my students only because we had 2, but the other one couldn't come, and Quentin, the other instructor, which is there. I'm just playing the local bank in here, and we bring some electronic challenge in here. That's it.
Hello, I'm Quentin Bolsé. I'm also from Brussels, and I've been working on the USB stepper motor that Neil is working on right now. So we made it here in the lab, and I'm working to improve it a bit.
Hello, I'm Ferdy from Fab Lab Camp-Lintfort with my 3 students, Jeff, Harley, and Gerhard. And yeah, we're very happy to be here in France. We are busy building all kinds of stuff. Gerhard is going to make some holographic chocolate. Jeff and Harley were busy helping in, amongst others, making we made a cow that we're going to do in molding and casting with gelatin glycerin mix. And yeah, I hope we have some great projects to show for afterwards. Greetings to the Fab Lab world.
Come. Yeah. Quickly.
Hi, I'm Luz, and that's Lucia, and we have Nadi, the girls from Amsterdam.
And don't forget Michelle.
Michelle, the other girl from Amsterdam. 4 girls from Amsterdam. Yeah, we had the boys, but we sent them home. We had good fun. Yesterday we played with the final cutters here, and we made your car. Can we How do we get there? There we go. Ta-da! Stickers on the car. And today we're busy with embroidering.
Yes.
Yeah,
Very busy. This is a test from the embroidery machine. This is Spirograph, but I'm gonna have it made hopefully big on a shirt that I have. And then something's also running in the 3D Formlabs resin printer, but that's still going on. So we can't show it. Yep.
Do we?
Yeah.
Hi, this is Jason from Brussels with Nicholas and Quentin. Hi. We worked yesterday a little blender on designing the cow that 3D printed and now is molding. And yeah, well, we're happy to meet everyone that we actually saw in video for the whole year.
Yeah, hi, I'm Leon from France, and we are going to open a lab in Mulhouse. Hopefully, we're gonna go join Fab Academy in 2022, and then we are so happy to meet like people in real life.
Hi, I'm Miraida, and this is Fabian.
Hi.
We're the tourists from Saudi Arabia who just happen to be in Europe, and we stopped by to say hi and meet all these people in person, and it's been really nice. Hi, Adrian, and good to see you all.
Yeah, and I'm going to share my screen quickly to show more concretely what we did. So it's more cool. Slide the video, share. Yeah, I'm going to stop the screen share. Yeah, that's our great moment here. So I hope we will be able to see you all soon. And now I'm going to give the next introduce the next speaker. I think that's Mariam.
Hi, I'm Mariam from Division Fab Lab. It's a first Armenian Fab Lab. We are 3 years old Fab Lab, and we have 3 main directions. It's an education, projects, and encourage maker movement in Armenia. So I will talk about 2 projects. One project I will introduce, and the second podcast. One of our projects is prosthetics. Last year we had a war here, and we have a lot of injured soldiers. So French Doctors Without Borders of France connected with us and suggested to use digital publication in making compressive masks for faces for the burns victims. So we 3D scanned the patients, then made the mold by 3D printing. We used PLA filament. After we cast it with PETG plastic and prepared the mask. If I have, I wanted to share my screen, if it's possible, and show you how we did it. You can see we are in prosthetics clinic, and we are preparing for the scanning, and local organization helped us and gave their 3D scanner, RTX scanner. We used it for this project. This is the final mask, so he is testing, is it good or no? This mask will help skin healing. Now our challenge is to design a low-cost prosthetics foot, hand, arm, and to help our local prosthetics clinics to use digital publication. Our project is to design and create an autonomous greenhouse. Bobken will tell you more about that.
Hello, my name is Bobken. I'm the local instructor for Fab Academy, one of our the lead instructor actually. So the greenhouse project is very interesting because the majority of agricultural lands in Armenia are about 1,500 meters, and the idea was to build a fully autonomous greenhouse that will be that will need minimal maintenance. So basically, the first step was to build the frame and to make the system for monitoring and irrigation. But lately we came across a problem of ultraviolet radiation that's really high in Armenia and on these high altitudes. So one of the specialists advised us to take this cost point into consideration. So we are basically really excited with this project and wanted to share with the community and had some maybe ideas and why not suggestions about greenhouse. Small greenhouses that work autonomously in rural areas. Yeah, basically, I'm done. Thank you very much.
One of the first Fab Labs we set up was in Norway, and Kenny was there, and Jean-Michel Molinar, and they made a boat as a project. Can you make a boat in a Fab Lab? And so they made a boat in an afternoon, took it out to the fjord and sunk, swam back to shore. Ever since then, they've been making Fab Lab boats, and then now they know how to make lovely Fab Lab boats. So at the reception, they were reminiscing, and so I challenged them, what do you not know how to do?
And I joked saying a submarine, and then he said, I give you $5,000 in my CBA shop and 24 hours to make a submarine.
And then I made another mistake, which was offering them a few people to help them, and it accreted to about 24 Fab Labbers itching to make something.
I'm Nader, Fab Lab Uzbekistan, Corsica.
And I'm Mesh from Denmark.
I'm Maddie, I'm from Boston.
It's Hugh Shuett from Omaha, Nebraska.
I'm Sergio from Fab Lab Rome.
I'm Hiroya Tanaka, Fab Lab Japan.
I am Mathieu from Barcelona.
I'm Sam Bukowski in Grenoble.
Let's come together! You now have however long it takes Jean-Michel and I to get some plywood before the plywood place closes to finish your prototypes. And so what we want to see are working physical prototypes. That probably means you have a little over an hour. Raise your hand if you anticipate a specific plywood need, but we're getting the plywood now.
There's nothing in stock. No plywood in stock?
Very little. I need those sheets now.
For the last 24 hours, they haven't slept. They've made a submarine-like object, making flanges to connect the shells, water jet cutting, bending, building the motors and the control systems to make a, what they call it is a seriously unintended boat, a submarine-like object. Right now, it's going to somehow meet the water and then come back out again, and that's about as far as it goes.
And we're gonna need to flip it over.
Wait, you want it angled like that?
I think so.
You think it's okay?
Yeah, I think it's good.
Can you think it's okay?
I think it should be minimal. Yes, sir.
But wait,
Yes.
just hold on a question. Due diligence would be to just have it flat. Would the problem be the propellers are out of the water?
Yes.
Actually, I'm going to say one last thing before you do that. If the propellers are here to here to here, I don't think they'll be out of the water. But if you're happy, can you go?
Yes.
Yes.
We're going to try and get these two buckets here, like this. We're going to try and flip the whole thing around and then slide it in.
Yep. This is easier than it sounds because there's enough of us that we can just keep the whole thing in the air. Yeah. So everybody get a corner. Ready? Up. Whoa! Wrong way. Jean-Michel, you need to be lower down. Okay. Now for the grand promenade. Whoa! Oh, that's great. Oh, super.
Love this.
It's a green submarine. Kenny, what's the battery life? Okay, this is the beauty shot with the submarine assembled. Kenny, look this way.
Considering the enormity of the scale of the project, I think we have ended up doing some really important testing. On the fail hard and fail fast principle, we succeeded.
It floated and moved and was fun, and it's a nice sense of communal accomplishment.
When the project started, there were not even an idea, I think, not even a structure, there were no designs.
It worked surprisingly well. Super learning moment, lots of fun also, and actually quite surprisingly good end result. I mean, it was a nice boat. It carried 4 people quite a ways.
Yeah, very maneuverable.
Using 2 cordless drills, some 2x4s and 3 buckets.
I would say that was a success. The propulsion system was amazing. I felt like I had all the control, more control than I needed. I mean, I had all the control I could ask for.
The barrels need to be much more substantial. The next rev will be a composite skin, but the basic conception of operation is quite promising. I wasn't sure if I described ascending to the heavens versus descending to catastrophe, and it definitely had an upward slope.
Yellow submarine, yellow submarine, yellow submarine. Yellow submarine, yellow submarine, yellow submarine.
Tropical rainforests provide us countless benefits, from clean air and clean water to bringing carbon dioxide out of the air and stabilizing our climate. Without them, our climate doesn't have the resiliency that it needs for the future. We need more rapid and effective solutions in order to properly address these challenges, and that's where XPRIZE Rainforest comes in. XPRIZE Rainforest is a 5-year, $10 million competition bringing teams together from all over the world to solve the greatest challenges facing tropical rainforests today. We need faster, more effective, more comprehensive solutions to address these issues and ensure that tropical rainforests are around for the future of all humanity. For those of you who are interested in joining us and following along this journey, find out more about XPRIZE Rainforest, the competition, and the teams involved on our website, rainforest.xprize.org.
Hey, with amazing videos from FabSub and the XPRIZE video on the Rainforest Challenge. So up next, we've got more videos for you guys. So it's going to be video from Spain, from Canada, from the UAE, and from India. So let's go right away to these videos.
Cette caravane qui va partir cet été durant 3 mois va pouvoir traverser le pays pour à la rencontre des Fab Labs et d'autres lieux d'espaces collaboratifs de fabrication à travers tout le Canada. Concrètement, la caravane débute son périple aujourd'hui, 1er mai. C'était à Montréal, dans le premier Fab Lab au Canada, qui est bien sûr EcoFab, ici de Communauté, au cœur du 375e anniversaire de la ville de Montréal. Son parcours va se terminer le 21 juillet à Ottawa, au cœur du 150e anniversaire du Canada. Elle va parcourir toutes les provinces, elle va visiter des laboratoires et leurs partenaires dans une vingtaine de villes pour imaginer et prototyper une interstructure des Fab Labs au Canada et surtout pour voir comment un Fab Lab c'est plus qu'un Fab Lab. Nous souhaitons contribuer à l'émergence d'une véritable interstructure nationale à travers le Canada, adaptée aux spécificités de chaque région et de connecter en réseau au réseau mondial qui est en pleine effervescence, qui est déjà composé de plus de 1200 Fab Labs. À travers le parcours. Et je vais vous présenter rapidement les 4 participants à cette aventure qui se sont engagés à parcourir le Canada pour les prochains mois. Notman a obtenu le Fab Academy l'année dernière en Chine et elle est une des Cette caravane qui va partir cet été durant 3 mois va pouvoir traverser le pays pour à la rencontre des Fab Labs et d'autres lieux d'espaces collaboratifs de fabrication à travers tout le Canada. Concrètement, la caravane débute son périple aujourd'hui, 1er mai. C'était à Montréal, dans le premier Fab Lab au Canada, qui est bien sûr EcoFab, ici de Communauté, au cœur du 375e anniversaire de la ville de Montréal. Son parcours va se terminer le 21 juillet à Ottawa, au cœur du 150e anniversaire du Canada. Elle va parcourir toutes les provinces, elle va visiter des laboratoires et leurs partenaires dans une vingtaine de villes pour imaginer et prototyper une interstructure des Fab Labs au Canada et surtout pour voir comment un Fab Lab c'est plus qu'un Fab Lab. Nous souhaitons contribuer à l'émergence d'une véritable interstructure nationale à travers le Canada, adaptée aux spécificités de chaque région et de connecter en réseau au réseau mondial qui est en pleine effervescence, qui est déjà composé de plus de 1200 Fab Labs à travers le monde, gérés et supportés dans plusieurs centaines de villes à travers la Fab Foundation. C'est en alignant communauté, partage de connaissances, outils numériques que les Fab Labs contribuent à développer le faire ensemble. Il œuvre au développement économique, culturel et social en favorisant le transfert et le partage de connaissances et il promeut également l'émergence de pratiques en développement durable. Il crée de nouveaux espaces de fabrication permettant d'outiller l'ensemble des citoyens. Il participe à faire des communautés résilientes et apprenantes qui peuvent résoudre leurs problèmes grâce à des outils locaux. Mais une caravane, ce n'est pas seulement des lieux, des équipements, un véhicule, c'est aussi des gens à travers le parcours. Et je vais vous présenter rapidement les 4 participants à cette aventure qui se sont engagés à parcourir le Canada pour les prochains mois. Notman a obtenu le Fab Academy l'année dernière en Chine et elle est une designer maker en résidence chez EcoFab et aussi à travers Agora Lab. On a Sophie Tremblay aussi qui est en designer social et qui travaille aussi avec Agora Lab. Guillaume Coulon, qui est entrepreneur, cofondateur de Fab Lab Québec et fondateur de Procédurable. Et Marc-Olivier Duchamp, qui est le Fab Manager du musée de l'ingéniosité J.A. Bombardier.
Longue vie à cette caravane, soyez prudents, je ne sais pas qui va la conduire, soyez prudents, il y a beaucoup de caribous, en espérant que vous allez faire la même chose que vous faites ici, partout au Canada. Bravo pour ce projet.
C'est aujourd'hui que nous lançons officiellement l'aventure Fab Lab Nation.
FoodShift 2030 is an EU Horizon 2020 project which is running over 4 years and is involving 31 partners from in total 12 countries.
The objectives of FoodShift 2030 is to transform the European food system towards a low-carbon circular future, including a shift to less meat and more plant-based diets.
The cities which are involved are Athens, Avignon, Barcelona, Brasov, Berlin, Bari, Copenhagen, Ostend and Wrocław.
We will be working on strengthening the local food system and making the eaters and local producers closer and in cooperation.
We're focused on building open source technology for urban agriculture.
We're establishing a Food Life Center, which is a sort of food hub or food campus in the former Tempelhof Airport building in Berlin.
We build on the method developed by Copenhagen House of Food, try to educate the kitchens to demand more locally sourced produce.
We are expanding the agricultural park in Ostende.
Involving youth entrepreneurs to recover abandoned land.
Nous avons besoin de construire une nouvelle cuisine centrale afin de poursuivre notre mission de service public en servant une alimentation plus respectueuse de l'environnement, biologique et locale.
The goal is to reconnect youngsters with the land and make them appreciate and value their food again.
Integration of the small producers from Brasov area into short supply chains, develop the sustainability of short supply chains and the better connection with the consumers in urban areas and rural areas.
We expect to be able to use Food Shift 2030 as an example of how cities can be hubs of innovation, successful hubs of innovation where food is the driver.
As a citizen-driven project, we are very interested to have as many as possible people on board to help us forming the new food system of the future.
We want to engage the SMEs, the NGOs, the local authorities, the researchers and the citizens in each of the city regions. The citizens from the local communities will be invited to join our Food Shift Accelerator Labs, where we are working to develop the citizen-driven food system solutions.
That's why we count on them, we count on you to bring the change in our food system that Food 2030 is aiming at.
Quand nous pensons à la littérature jeunesse, il est courant d'imaginer un livre où l'image est indispensable. Par contre, cela n'implique pas que l'image joue le même rôle dans tous les livres conçus pour les enfants. L'album commence à prendre forme comme une nouvelle expression artistique à partir de la deuxième moitié du 20e siècle. Les artistes issus des arts visuels, comme le design et la publicité, ainsi que des professionnels de l'édition, ont parcouru un chemin ouvert par des illustrateurs qui avaient tenté de changer le statut traditionnellement décoratif ou interprétatif de l'image. À mi-chemin entre l'expérimentation littéraire, la vocation ludique de la littérature pour enfants et la culture populaire, l'album devient aussi possible grâce aux changements culturels qui élargissent la façon de concevoir l'enfance, la lecture et les livres. C'est-à-dire que l'album répond à une vision esthétique du livre pour les enfants, de la lecture comme expérience de construction de sens et de l'enfant lecteur comme récepteur actif. C'est à partir de ce processus que l'image trouve un rôle actif dans la littérature jeunesse, vu l'interaction dynamique et la tension constante qui s'établit avec le texte, mais aussi avec la matérialité du livre. L'album est alors un objet qui raconte avec tout ce qu'il peut. Les textes, les illustrations, le format, la mise en page, les matériels, la technique, la typographie, la couverture, les pages de garde, la sonorité de la lecture à haute voix, etc. Puisque la lecture se considère comme un acte de construction de sens, le lecteur implicite de l'album sera double. Ça veut dire qu'un adulte et un enfant peuvent inférer ensemble le non-dit. Penser à l'acte de lecture de l'album implique de le considérer comme un objet qui est conçu, fabriqué, qui supporte et fait partie de la narration et, enfin, qui se partage en deux lecteurs différents mais complémentaires. Deux expériences au Bénifab pendant le temps de fermeture à cause du coronavirus. 1. 6 à 9 ans, de l'heure du conte à l'heure du code. Un album comme point de départ pour découvrir la programmation pour enfants avec l'application Scratch Junior. La mission? Adapter des albums aux médias numériques afin de reconnaître les dynamiques de création selon le média utilisé. 2. 8 à 12 ans, ma valise aller-retour. Ressources? Une valise créative qui va chez eux et retourner 4 fois. 2 fois accompagnée d'un ensemble de 2 albums, un publié au Canada et un autre publié ailleurs, et un guide pour accompagner la lecture à distance. La valise change de contenu selon le moment de création de notre chaîne du livre papier. Et voici notre chaîne du livre papier et les résultats.
Bob.
Inspired by its old namesake in ancient Baghdad, the House of Wisdom in Sharjah stands today as a testament to modern knowledge, the pursuit of truth, the obsession with understanding, and the love of learning and culture. Within its walls, one can find a diverse collection of books, artistic works, artisanal food, daily educational workshops, and the latest technology. The Al-Jazri Lab at House of Wisdom showcases technology's place in the literary hotspots of the future. Named after the father of robotics, Ismail Al-Jazri, here one can find an array of exceptional machinery, tailored towards literary creation and imaginative design. 3D printers, laser cutting machinery, and computer numerical control tools make modern design accessible to the public, allowing the hosting of many workshops and training sessions for aspiring creatives. These tools also enable eager inventors to prototype their creations, ensuring their innovations see the light of day. With all the tools available at Al-Jazri Lab, House of Wisdom is promoting an ideology of what a modern cultural hub should be. A space where knowledge is gained and used to create innovation and ultimately change the world.
Centrino is a research project focused on historical industrial sites across 9 European cities. Centrino will transform them into sustainable and inclusive hubs for its residents by bringing urban regeneration solutions and innovative strategies.
नमस्कार, विज्ञान आश्रमामध्ये तुमचं स्वागत आहे। विज्ञान आश्रम हे पाबळ या गावी स्थित आहे। पाबळ गाव पुण्यापासून 70 किलोमीटर अंतरावर आहे। विज्ञान आश्रमामध्ये 1983 पासून काम करत आहोत आणि खास करून नवीन तंत्रज्ञान हे लोकांपर्यंत कसे पोहोचवता येईल यावर विज्ञान आश्रम काम करत आहे। नवनवीन उद्योगांवर आम्ही युवकांना प्रशिक्षण देतो आणि त्यांना त्यांचे व्यवसाय उभा करण्यासाठी मदत करतो. विज्ञान आश्रमाची ओळख करून देताना आम्ही तुम्हाला विज्ञान आश्रमातील प्रत्येक विभाग या टूरमार्फत दाखवणार आहोत. या टूरमध्ये तुम्हाला विज्ञान आश्रमाची फॅब लॅब, वर्कशॉप, शेती विभाग, पशुपालन विभाग, सॉईल लॅब, टिश्यू कल्चर लॅब, डिझाईन इनोव्हेशन सेंटरचा विभाग, ऊर्जा व पर्यावरण विभाग, गृह आणि आरोग्य विभाग या सगळ्यांची तुम्हाला या टूरमार्फत ओळख करून देणार आहोत.
नमस्कार, हे विज्ञान आश्रमाचे फॅब लॅब आहे. फॅब लॅब म्हणजे डिजिटल फॅब्रिकेशन लॅब की ज्याच्यामध्ये वेगवेगळ्या प्रकारच्या प्रोटोटायपिंग मशीन्स असतात. मग त्यामध्ये 3D प्रिंटर आहे, लेझर कटर आहे, व्हिनाईल कटर आहे, PCB बनवायचं मशीन आहे, लाकडावर साचे बनवायचं मशीन आहे. तर या सगळ्या मशीनचा या फॅब लॅबमध्ये समावेश होतो. विज्ञान आश्रमाची फॅब लॅब ही 2002 मध्ये सुरू झाली आणि ही जगातली पहिली फॅब लॅब आहे. तशी फॅब लॅब ही संकल्पना अमेरिकेमधील MIT विद्यापीठ जे आहे त्या विद्यापीठामधील नील ग्रेशनफील्ड यांची 2002 मध्ये MIT विद्यापीठ आणि विज्ञान आश्रम यांच्या संयुक्त प्रयत्नातून पाबळ येथे ही फॅब लॅब उभी राहिली. फॅब लॅबचा मोटो असा आहे की यू कॅन डू ऑलमोस्ट एनिथिंग. म्हणजे तुम्ही एखादी जर तुमच्याकडे कल्पना असेल तर ती कल्पना तुम्ही या सगळ्या मशीनचा वापर करून प्रत्यक्षात उतरवू शकता. मग याच्यामध्ये कोणकोणत्या मशीन्स आहेत तर हा आमचा 3D प्रिंटर आहे. 3D प्रिंटरसाठी तुम्हाला 3D डिझाईन सॉफ्टवेअरमध्ये 3D ऑब्जेक्ट किंवा एखादं डिझाईन बनवून घ्यावं लागतं आणि याला प्रिंट म्हणून द्यावं लागतं आणि मग हा 3D प्रिंटर तुम्हाला प्लास्टिकच्या स्वरूपात असे काही ऑब्जेक्ट्स बनवून देतो. हे व्हिनाईल कटर मशीन आहे. व्हिनाईल कटरमध्ये नॉर्मली आपल्या गाड्यांच्या नंबर प्लेट किंवा स्टिकर्स बनवले जातात. पण याच्यामध्ये जर तुम्ही कॉपरची फॉईल टाकली तर तुम्हाला फ्लेक्झिबल सर्किट्स बनवता येतात किंवा फ्लेक्स सेन्सर्स बनवता येतात. व्हिनाईल कटरसाठी तुम्हाला 2D डिझाईन सॉफ्टवेअरची गरज असते. मग फोटोशॉप असेल, कोरल ड्रॉ असेल, त्याच्यामध्ये तुम्हाला त्या गोष्टी डिझाईन करून घ्याव्या लागतात आणि याला प्रिंट म्हणून द्याव्या. हे लेझर कटर मशीन आहे. या मशीनमध्ये तुम्हाला वेगवेगळ्या प्रकारचे मटेरियल म्हणजे त्याच्यामध्ये लाकूड आलं, ॲक्रेलिक आलं, MDF मटेरियल आलं किंवा सॉफ्ट मटेरियल जे काय असतील तर ते सगळे कापून मिळतात. याच्यासाठी तुम्हाला 2D डिझाईन सॉफ्टवेअरमध्ये डिझाईन बनवून घ्यावं लागतं आणि याला प्रिंट म्हणून द्यावं लागतं. याचा उपयोग आम्ही आमच्या प्रोजेक्टमध्ये आमच्या प्रोजेक्टचे जे काही स्ट्रक्चर असतात किंवा कनेक्टर असतात किंवा गिअर्स असतात तर या सगळ्या गोष्टी बनवण्यासाठी करतो. हे वूड राउटर मशीन आहे. याच्यामध्ये लाकडावर तुम्हाला वेगवेगळ्या प्रकारचे डिझाईन करता येतात किंवा वेगवेगळ्या प्रकारचे साचे तयार करता येतात. याच्यासाठी तुम्हाला 3D डिझाईन सॉफ्टवेअरमध्ये कोणताही 3D डिझाईन सॉफ्टवेअर चालेल. त्याच्यामध्ये तुम्हाला 3D डिझाईन बनवून घ्यावं लागतं, याला प्रिंट म्हणून द्यावं लागतं. आमच्या प्रोजेक्टमध्ये आम्हाला जे काही FRPचे मोल्ड बनवायचे असतात किंवा काही कंपोजिट मोल्ड्स बनवायचे असतात तर ते सगळे मोल्ड्स आम्ही या मशीनवर बनवतो. ही CNC मिलिंग मशीन आहे. त्याच्यामध्ये आम्ही प्रामुख्याने PCBs बनवतो. जे आपले सर्किट बोर्ड्स असतात ते बनवतो. PCB बनवण्यासाठी तुम्हाला PCB डिझायनिंग सॉफ्टवेअरमध्ये PCB लेआउट बनवून घ्यावा लागतो आणि तो याला द्यावा लागतो. मग याच्यामध्ये आम्ही आमच्या प्रोजेक्टसाठी लागणारे जे काही मायक्रो कंट्रोलर असतात, सेन्सर्स असतात, हे सगळे या मशीनचा वापर करून बनवतो. त्याचबरोबर तुमच्याकडे जर वॅक्स ब्लॉक असतील किंवा सॉफ्ट मटेरियलचे ब्लॉक असतील तर त्याच्यामध्ये तुम्हाला मोल्डिंग कास्टिंगसाठी लागणारे जे काही साचे ते सुद्धा बनवता येतात. विज्ञान आश्रम हे ॲप्रोप्रिएट टेक्नॉलॉजीवर काम करतं आणि मग या टेक्नॉलॉजी बनवत असताना प्रूफ ऑफ कन्सेप्ट किंवा प्रोटोटाईप डेव्हलप करणं गरजेचं असतं. फॅब लॅबमधील हे सगळे टूल्स, प्रोटोटायपिंग मशीन्स हे प्रोटोटाईप बनवण्यासाठी किंवा प्रूफ ऑफ कन्सेप्ट करण्यासाठी वापरले जातात.
विज्ञान आश्रमामध्ये डिझाईन इनोव्हेशन सेंटर हा एज्युकेशनल प्रोग्राम चालतो की ज्याच्यामध्ये ग्रॅज्युएट मुलांसाठी फेलोशिप आणि अंडर ग्रॅज्युएट मुलांसाठी इंटर्नशिप ह्या दिल्या जातात. तसेच विज्ञान आश्रमामध्ये जी डिझाईन इनोव्हेशन सेंटरची लॅब आहे त्याच्यामध्ये 2 फॅसिलिटीज आहेत. एक डिझाईन क्लासरूम की ज्याच्यामध्ये आम्ही वेगवेगळ्या प्रोजेक्टवरती चर्चा करतो, ब्रेनस्टॉर्मिंग करतो आणि त्याची उत्तरं शोधायचा प्रयत्न करतो. आमच्याकडे व्हिडिओ कॉन्फरन्सिंगची पण फॅसिलिटी आहे की ज्याच्यामध्ये आम्ही ऑनलाईन टेक्निकल वेबिनार अटेंड करतो. आणि डिजिटल डिझाईन लॅबमध्ये आमच्याकडं डिझाईन फॅसिलिटी आहे की ज्यामध्ये आम्ही 3D CAD मॉडेलिंगसाठी सॉलिडवर्क्स, कटिया, ऑटोकॅड यासारख्या 3D मॉडेलिंग सॉफ्टवेअरचा वापर करून आमचे जे काही प्रोजेक्ट्स आहेत ते बनवतो.
विज्ञान आश्रममधील हा ऊर्जा पर्यावरण विभाग आहे. यामध्ये बेसिक इलेक्ट्रिकल शिकवले जाते. त्यामध्ये मोटर रिवाइंडिंग, फॅन दुरुस्ती, वायरिंग करणे तसेच बोर्ड भरणे ह्याबाबत DBRT विद्यार्थ्यांना प्रॅक्टिकल शिकवले जाते. तसेच बेसिक इलेक्ट्रॉनिक्स पण त्यांना ओळख करून दिली जाते. विद्यार्थ्यांना पर्यावरणामध्ये हवामान मोजणे तसेच ग्रे वॉटरची देखभाल व मेंटेनन्स तसेच डम्पिलियल सर्वे, प्लेंटेबल सर्वे हे प्रॅक्टिकल विद्यार्थ्यांना इथे शिकवले जातात. पर्यावरणामध्ये इथे विज्ञान आश्रममध्ये सोलर सिस्टीमबाबत विद्यार्थ्यांना शिकवले जाते. बॅटरी मेंटेनन्स तसेच सोलरची देखभाल हे विद्यार्थी स्वतः करतात.
हे आमचे होम अँड हेल्थ आणि फूड लॅब आहे. यामध्ये आम्हाला हेल्थ हा विषय आहे. हेल्थ या विषयामध्ये आम्हाला ब्लड प्रेशर चेक करणे तसेच रक्तगट चेक करणे आणि रक्तातील हिमोग्लोबिनचे प्रमाण चेक करणे आणि कॅलरीज काढणे हे शिकवले जातं. त्याचबरोबर आम्हाला फूड प्रोसेसमध्ये आमच्याकडे गॅस आहे, फ्रीज आहे, OTG ओव्हन आहे, मोठा ओव्हन आहे, नायट्रोजन पॅकिंग मशीन, आटा मेकर आणि फिलिंग टँक आहे, हाय स्पीड मिक्सर आहे आणि पल्पिंग मशीन आहे. यांचा आम्ही वापर करून फूड प्रोसेस करतो. फूड प्रोसेसमध्ये आम्ही बेकिंगमध्ये पाव, बटर, खारी, टोस्ट या सगळ्या गोष्टी बनवतो. त्याचबरोबर कुकीजमध्ये आम्ही नानकेट, वेगवेगळ्या प्रकारची बिस्किटे आणि क्रीम रोल बनवतो.
आता आपण शेती विभागातल्या पॉली हाऊसच्या आतमध्ये आलेलो आहे. इथं तुम्ही बघाल तर हे पॉली हाऊस क्लायमेट कंट्रोल पॉली हाऊस आहे. म्हणजे एका बाजूला फॅन लावलेले आहेत आणि दुसऱ्या बाजूला पाणी पडणारं पॅड लावले. त्यामुळे आपल्याला इथलं तापमान, इथली आर्द्रता ही ठराविक प्रमाणात ठेवून त्याच्यावर प्रयोग करता येतात आणि झाडांची वाढ जास्त मिळवता येते. त्याचबरोबर आपण इथं बघतोय की आम्ही इथं ग्रो बॅगचा प्रयोग केला आहे. म्हणजे पिशव्यांमध्ये पालक लावलेला आहे. तर ह्या प्रयोगातनं आम्ही असं बघतोय की कुठल्या खतांचा पालकावर कशा पद्धतीनं परिणाम होतो. त्याच पद्धतीनं ह्या बाजूला आम्ही पाण्यावर तरंगणारी हायड्रोपॉनिक शेती केलेली आहे की ज्यामध्ये पालक हा थर्माकोलच्या साहाय्याने पाण्यावर तरंगवलेला आहे. की ज्यात आम्ही बघतोय की ही शेती पण फायद्याची होऊ शकेल का, त्याला कुठल्या कुठल्या प्रकारची खतं द्यायला लागतील. आणि हे सगळं काम शेती विभागामध्ये DBRT आणि DISCची मुलं त्यांचे प्रयोग म्हणून, त्यांचं शिक्षण म्हणून करत असतात. हा आमचा शेती विभागातलाच एक हायड्रोपॉनिक्स म्हणजे मातीविना शेतीचा प्रयोग आहे. ह्यामध्ये आपण बघतोय की ह्या पाईपमध्ये हे पालक लावलेलं आहे आणि त्याच्यामध्ये पाण्याच्या माध्यमातून ह्याला सगळी खतं दिली जातात. तर ह्या प्रयोगातनं पण आम्ही वेगवेगळ्या गोष्टी नोंदवतोय. जसं की किती प्रमाणात आपल्याला नत्राचं प्रमाण किती ठेवायला लागेल, हे नत्र आपल्याला मानवी मूत्रातून घेता येईल का, म्हणजे त्याचं रिसायकलिंग करता येईल का, असे सगळे प्रयोग DBRT आणि DISCची मुलं ह्या प्रयोगात शेती विभागात करतायत.
विज्ञान आश्रमातील पशुपालन विभागात आम्ही दूध व्यवसाय, बंदिस्त शेळीपालन, पोल्ट्री व्यवसाय या गोष्टींचा अभ्यास करतो. या गोष्टींचा अभ्यास करत असताना पशूंना लागणारा पोषित आहार, त्याचप्रमाणे आजोल्याचे त्यांच्या आहारातील महत्त्व, या सर्व गोष्टींचा आम्ही एकत्रितपणे इथे अभ्यास करतो. तसेच याचे काही जे रिझल्ट आले असतील हे DBRT मुलांना आणि आजूबाजूच्या शेतकऱ्यांना आम्ही शिकवतो. हे आम्ही मिनी किचन गार्डन बनवले आहे. एका घरासाठी लागणारा भाजीपाला आपण केमिकल फ्री कसा उगवू शकतो याच्यावर आम्ही इथे ट्रायल्स घेण्याचा प्रयत्न करत आहोत. प्राण्यांना लागणाऱ्या हिरव्या चाऱ्याची कमतरता दूर करण्यासाठी विज्ञान आश्रमात आम्ही छोटे छोटे एकदल आणि द्विदल चाऱ्याचे प्लॉट विकसित केलेले आहेत.
ही आपली माती परीक्षण प्रयोगशाळा आहे, ज्यामध्ये आपण मातीतील 12 घटक तपासतो, की ज्यासाठी लागणारे इन्स्ट्रुमेंट जसं की फ्लेम फोटोमीटर असेल, की ज्यामधून आपण कॅल्शियम, सोडियम आणि पोटॅशियमचं एस्टिमेशन आपण त्यामधून करतो. त्याच्यानंतर नायट्रोजनसाठी लागणारे जेलडार प्रोसेस आपल्याकडे आहे. त्याच्यानंतर मातीतले इतर जे न्यूट्रिएंट्स आहेत ते काढण्यासाठी आपल्याकडे स्पेक्ट्रोफोटोमीटर इन्स्ट्रुमेंट आहे. आणि तसेच आपण या ठिकाणी पाण्याचं टेस्टिंगसुद्धा करतो, की ज्यामध्ये पाणी पिण्यास योग्य आहे की नाही त्यासाठी आपण त्या पाण्याचं टेस्टिंग करतो, की ज्यामध्ये विविध प्रकारचे टेस्ट असतील, जसं की H2S असेल, पाण्याचं pH, TDS, EC असेल, पाण्याचं COD असेल. तर त्यासाठी लागणारे इन्स्ट्रुमेंट आपल्याकडे आहेत आणि या ठिकाणी आपण पाणी आणि मातीचं टेस्टिंग करतो.
ही आपली टिश्यू कल्चर लॅब आहे. टिश्यू कल्चर म्हणजे आपण एखाद्या प्लांटच्या पार्ट्सच्या टिश्यूपासून आपण अनेक प्लांट ग्रो करतो आणि इथे आपण पोटॅटो, बनाना आणि रोज यावर टिश्यू कल्चरवर काम करत आहे. आणि इथे आपली टिश्यू कल्चर हा आपला टिश्यू कल्चर सेटअप आहे. आमच्याकडे लॅमिनार एअरफ्लो, ग्रोथ ट्रॅक आणि ऑटोक्लेव्ह आहे.
हे आमचे मायक्रोबायोलॉजी लॅबचं सेटअप आहे. इथे आम्ही मायक्रो ऑर्गॅनिझमवर अभ्यास करतो. आम्ही इथे वेगवेगळे कल्चर बनवतो. त्यापैकी एक कंपोस्टिंगसाठी लागणारं कन्सर्शिया कल्चर आम्ही इथे बनवलेलं आहे.
आपल्याकडे मायक्रोबायोलॉजी लॅबमध्ये लागणारे सर्व इन्स्ट्रुमेंट आहेत. त्यामध्ये ऑटोक्लेव्ह, त्यामध्ये आपण स्टरलायझेशन करतो. त्यानंतर आपल्याकडे इलेक्ट्रोफोरेसिस, PCR, सेंट्रीफ्यूज असे सारे इन्स्ट्रुमेंट आहेत, ज्यामध्ये आपण DNA आणि RNA यांचं सेपरेशन करतो. त्यानंतर आपल्याकडे वॉटर बाथ आहे, रोटरी शेकर आहे, मायक्रोस्कोप आहे, कॉलनी काउंटर आहे. त्यामध्ये आपण विविध प्रकारचे आयसोलेशन्स करताना जे इन्स्ट्रुमेंट्स लागतात ते आहेत ते. त्यानंतर आपल्याकडं लॅमिनार एअर फ्लो आहे. त्यामध्ये आपण असेप्टिक कंडिशन ठेवून जे काही आपल्याला मायक्रो ऑर्गॅनिझम सेपरेट करण्यासाठी वर्क करायचं आहे ते आपण त्यामध्ये असेप्टिक कंडिशन ठेवून करू शकतो. त्यानंतर आपल्याकडे इन्क्युबेटर आहे. इन्क्युबेटरमध्ये आपण जे आपण आयसोलेशन करतो प्लेट्स, त्यामध्ये आपण ते इन्क्युबेशन पिरियडसाठी त्यामध्ये ठेवून देतो. त्यानंतर आपल्याकडे ओव्हन आहे, हॉट एअर ओव्हन, ते आपण ड्रायिंग करण्यासाठी वापरतो.
Hello, Fab World. We are live from Montreal at Communautic. I'm Jason Rohde from Nomad Life TV. And today we're going to be spending the next hour and 45 minutes together discovering what we're all about, basically what Fab Labs are about in Montreal, how the movement is going in this country and this side of the world. And I think it's pretty fantastic that we're doing all of this through this kind of virtual event, because it reminds me of all these common efforts that have come together to create these great technologies that are allowing us to do this, whereas just a few years back, not so long ago, perhaps only 2 years ago, because of a certain pandemic, we might not have done this with such ease. So I'm very happy to be with you here today. I should mention that I don't know much about Fab Labs. I'm not a fabber or a fabler or whatever you call it. So I'm coming in kind of cold, and I'm going to be getting warmer throughout the next hour and a half, hour 45 minutes. we're going to start now with my new friend, Guillaume Coulombe, who's joining me, who works here at Communautique, as far as I understand. So, Guillaume, hello.
Hi.
Guillaume Coulombe.
Guillaume Coulombe, yes.
Correct? So tell me a little bit about yourself. How did you find yourself here today?
I find myself here as an entrepreneur, a friend entrepreneur, I would say, with Communautique. And when we can say that we both discovered the Fab Lab world at the same time in 2010 when a French guy named Jean-Michel Cornu came here at Communautique at their old locals without a Fab Lab and expressed to the crowd that was there what was happening, emerging in France about Fab Labs and around the world.
If you don't mind,
sure.
Tell me, what is a Fab Lab? Because that, you know, some 10 years or so ago, there wasn't much of a definition then. So how would you define it today?
A Fab Lab is a common space. It's a place to go and learn how to use different machines that are run by computers. So we call it digital fabrication. So it's a place to do things. There are objects, there are machines, transformation.
A shared space.
It's a shared space that can be run by many different means. Sometimes by a public library or a school or a non-profit like Communautique,
right.
Or even some co-ops starts Fab Labs to have members and share the tools, share the skills, and invite people to the sharing place to adopt a sharing attitude, because there is a charter that unites the Fab Labs all together.
Okay.
And when I...
A kind of manifesto.
Yeah, a kind of manifesto in 6 simple things that invite people to document what they do, because they can benefit from...
Yeah, to share the knowledge, of course.
Exactly.
Oh, that's great.
So it's not a Fab Lab, it's Fab Labs are. So it's a plural definition.
Of course, of course, of course. Not what is a Fab Lab, Fab Labs. It's kind of like one global Fab Lab in a way, with that shared knowledge. Now, I'd like to invite already a friend of yours with whom you've traveled quite a bit, Marc-Olivier Ducharme. Would you come in, please? Sure. Should we do a clap whenever we get someone here? I think that's worthwhile.
So where's the beer?
Where's the beer? We're working on the beer once you work on the poutine. How about that?
That's good.
So I mentioned the poutine because, of course, you know, we have an hour, 45 minutes, less now. And Guillaume, at the very end of this hour and 45, is going to give us a multimedia performance. I'm not going to try to describe it now, but at some point, he's going to be running away to set that up for us. And Marc-Olivier as well will be making some poutine for us. I believe this is by popular demand. I guess we're a bit of a cliche here this morning. So Marc-Olivier, before we get to that, why don't you tell us a little bit about yourself? How did you get to know the Fab Lab movement?
I'm a maker, so basically I make stuff. Like,
Okay.
not for a living, just because I like it.
You're a maker, like the way I might say I'm an artist, or the way that he said he's an entrepreneur.
Yeah, I would say, like, some people say they are woodworkers. I'm a maker. Like, I cannot play with only one thing. I want to play with everything. So that's my problem. And I really needed a place where I could play with machines, with tools that would, like, make almost anything. And I didn't know that Fab Lab existed until 2011, and I was working a government job in my office with you know, like typical computer stuff, and I'm doing research, and I found there's a Fab Lab movement, there's a maker movement, there's people around the world that organize collective workshops and they share tools and knowledge. And I was like, okay, I really need these people. I really need the knowledge, because I don't know anything about electronics. I don't know anything about 3D printing. I don't know, and I have projects. I do have some skills. I can work with wood. I can work with molding. I can do some things, but I needed these people to teach me or to show me how to do it. So in 2011, there's a post on an internet website, and then I found Fab Lab Quebec, like the original first post on their website, and they did just had an event. And there was an organization called Communautique that planned to open a Fab Lab, and I write them, and they had a job opening, and I started working at FAB. So it was the first Fab Lab in Canada.
Wow.
And that's how it happened.
That was
It
the first
yeah,
Fab Lab
yeah.
in Canada in 2011.
Yeah.
So Fab Labs have been in Canada since 2011.
Yeah.
Is that correct?
That's correct.
Wow.
Yeah.
Wow. That's, I somehow imagine it was an older movement than that. Your life was changed by the whole Fab Lab movement, as far as I understand it, because you really became quite involved. Same as you, as I understand it. This is your life. Fab Labs are your life.
It's a big part, as I do wish that it's becoming normal that these places become common.
Right.
So we did start this Fab Labs Quebec first website in 2010. After this,
you started that
with Communautic. We started that. Yes.
Okay.
And then we invited people. What are Fab Labs? Around the question, would that be a fourth industrial revolution or something like this? And we had over 50 people that came at Usine C on very short notice, and we had.
Usine C is like a great industrial theater that we have here in Montreal. It's actually it's an art space.
Yeah.
So you did the Fab Lab there, which is interesting. Brings the creative element of the Fab Labs out, I guess.
Yeah, it was for us a new way to think about the usine, the
right.
shop.
That's right. That's right. Usine in English means factory, to give you an idea, or give you guys an idea. Yeah, and so you two met just right around then.
So we met on my first week at work at EcoFab, and he was in Africa, I was in Quebec, and we were
just
trying
to make things complicated.
Yeah, we were trying to like make stuff, and it was like January 1st or something like that. It was really early in January. Like, he was sweating in Africa, and I was like freezing in Montreal because community offices were in an old building, and the window panes were not really good, and it was really cold inside. So yeah, it was this thing, and for a few weeks we exchanged like that, and I got my hands into a Fab Lab. It was basically a 3D printer in a room with computers, and we didn't really know how to do that. So it took like years of running Fab Labs and inviting people and then creating with them and like seeing all the problems and the needs that they had, so we could adjust and like bring new tools and bring techniques and stuff like that. And then because we travel, we've seen Fab Labs in other parts of the world, and we pick and choose what we like from different places and try to build a movement like that. And also, all these years, we also work on our networks or infrastructure, which is really important, because one of the reasons I think the Fab Lab
networking mean like human network.
Yeah, human network. And because we're doing great in Quebec, like we have a lot of Fab Labs compared to the rest of the country. But I think we put a lot of effort in the network first before building spaces.
Oh, wow.
We put effort in building the network of people.
And the idea of the infrastructure for us is to have the Fab Lab as a creative, extraordinary infrastructure where people go, and the infrastructure unites both the Fab Lab and the organization, the ecosystems that wants this to emerge. And we aim, and we founded the Co-op Fab Lab Quebec in 2019, after 9 years of networking, as a co-op de Solidarity co-op. And then members they can be Fab Labs, they can be entrepreneurs, they can be travailleurs autonomes, I forget in English, like self-employed people that become producer of this infrastructure, that say, okay, I will take part of that, I will help construct the network, the tools, the communication tool. We have a wiki tool that people nourish in order that we know where on the maps are the laser cutters that are accessible to Quebec.
Right.
We publish this data to Donner Québec, which is an open government initiative here in Quebec. So we publish our data to take part of this open source and open access to the knowledge community in our society and around the world.
Wow. It sounds like there's a real will for cooperation, collaboration. It's at the very basis of all this. And so as you're developing the knowledge, you're also thinking to yourself, I got to put it out there for it to exist, for it to exists to be.
Yeah, people have sometimes barriers to collaboration in their in organization,
right?
And we want to offer them just to turn themselves towards this co-op and say, oh, what I wanted this thing or this system to help me manage my Fab Lab, but then people are sharing their systems, they're sharing their knowledge, their little sheet that helps to run this 3D printer and everything. So it makes the development of the Fab Labs easier and easier along the time.
You two went on a great journey together across Canada, is that correct?
Yeah.
To meet other Fab Labs. I guess it's a good moment to bring in your travel partner. It was the three of you, right?
Yeah, it was the three of us.
With Pansavan, do we have Pansavan nearby? Pansavan! She's kind of like Batman. You gotta send in the signal. Hi, Pansavan, come near me if you don't mind scooting over, fellas. Wow. Hello, Pansavan. How are you this morning?
I'm great, thank you.
I wish we all had your stylist, but alas, we are but simple men. So you three traveled together. How was that? When was that? What was it? Can you tell us a little bit about that? It was your initiative, I understand, but I want to hear from Pansavan.
Well, we went across Canada in 3 months. And there were days where we were driving 19 hours a day and pulling out the machines in and out and making workshops across Canada. And
Workshops? What kind?
Fab Lab workshops.
Okay.
Just what do you want to talk about?
Yeah. So we would like make barbecues on the side of the street and in Saskatoon or in Powell River, BC. We went to a local makerspace and had like an evening of events, and it was very ad hoc. Like we would network. Like we didn't know what to expect and where, so we drove. It was crazy. It's really hard to be like 3 people in a van and drive like that across Canada.
You had your van painted, right? I think I saw it in front of the building.
Yeah, this van is still there. And
wow. When was this?
2017.
Okay.
In the summer. Okay. Yeah. And it was a very weird weather for all the summer. So like the eastern coast was flooded with water. We would in New Brunswick, there was so much rain. But then like it was meeting all these people because there's not many Fab Labs. There's still many maker spaces. There's many public spaces of the commons that do have infrastructure. And we were trying to network with these people and see like what does it mean for them to be in a network?
Right.
What does it mean to them to interact with each other? Do they really interact with each other? So we had all these questions for them, and it was a crazy adventure. Like 3 months across the country.
Yeah.
It's a very big country.
19,000 kilometers.
Yeah.
Wow.
Lots of change of plans, lots of motels or Airbnb.
Lots of new friends, I'm sure.
Yeah, and mechanical problems with the truck.
Microbreweries as well.
Well,
microbreweries, yeah.
To have a mechanical problem, I wouldn't mind it with you guys. I think I'd be very.
We have the transmission of the truck that bursted after the East Coast loop in Montreal. Slam. Then we had to rent a truck, go to Ottawa, go to Kitigan-Zibi, and then come back to get the truck and go now to Toronto to do the 8,000 kilometer of the west the west loop.
Insane.
And then we had a flat on the west coast.
Yeah.
Guillaume changed the wheel by himself.
I just said this road is so wonderful, and then bam, tire blow.
Yeah, you got to be careful what you say.
Yeah.
We got a whole wrench in it.
I wish I could stay here for at least another hour or so. Yeah, and then you're forced to change the wheel on the side of the road.
But I went fishing with it up north in the mountains.
Okay.
And with all the machines, and it was dangling in the truck, laser cutter, and it still cuts perfectly after that.
Wonderful. Tell me, Pansavan, what did you learn about the Fab Lab movement? Not what did you learn, because I'm sure there's so much you learned from such a journey, but what in your view is the state of the Fab Lab movement today? How is it how's it changing since the past 10 years or so that it's been going on? And where do you feel it's at? Where's the Fab Lab movement at?
Well, back in the days in 2013, when I didn't know anything about Fab Lab, I was looking for creating a co-working space. I met these two guys, and Monique Chartrand.
Monique Chartrand?
She's the director of community.
Of course, in the shadows.
I wanted to create Fab Labs in my city, which is Gatineau.
Okay.
And everybody thought I was on drugs.
Were you? Maybe because I was.
But then today, we've done a lot of work, and it has grown in Quebec mostly, and because of Fab Lab Nation tour and all the movement has grown, we now have Fab Labs in libraries and in schools. We have great partnership with the different departments, and there's new programs. So I think it still needs support financially, especially for human resource, not only for machines, but human resource. It's growing, and I think the Fab Lab needs a place that could thrive in partnership with different institutions, university, cities, and different communities. But it really needs supports for human resource, because there's a lot of effort in this, with a lot of people working really hard. And in the beginning, there was a lot of volunteering, and now it's getting better and better. I think Marco can add something to it.
Yeah, it changed a lot. We did a lot in all these years, but as Pantavan said, we need that support, because it's basically we're creating public infrastructure where people can go and can create and invent things and make art. And so all of this is a public space.
Yeah, and people transform themselves when they go in the place. We see Fab Labs in adult teaching, people that tend to do something else and then go back to school and say, oh, this is a fun way to learn. This is a fun way to hook to chemistry or physics, to work, to create stuff and to learn by doing something and doing it together instead of not doing it or not doing it alone.
Right.
Gets people change, and it's a social, it's affective for the people to come in a Fab Lab, instead of many things that could be done.
Yeah, and we're seeing like a lot of change in the Fab Lab movement, where now there's all the biohacking, bioarts, and the Fabric Academy, and all these new like trends that are being covered. So we're trying to set this up. And where else can you have access to a wet lab? Like it's impossible to have access to all of this if you're not a student in the university or a researcher. And now you tell me that I can access a bio lab and like grow stuff and check it in the microscope. Like all these things are impossible if you don't have either money or the privilege of being a student or in a higher education level.
Science as a hobby,
yeah,
learning as a hobby and a passion.
So what do we want for our citizens? Like I want to have creative and intelligent and wise citizen that can play with stuff and learn with other people.
Brilliant. I love how you all speak so eloquently about this. It's clearly a passion for each of you. I'm wondering if you would go grab this Monique Chartrand for me, please. Because I know she's a little camera shy, but I don't think anybody can speak better about where we are and what we're doing here. So thank you kindly.
You're welcome. Thank you.
To all three of you. And Monique, why don't you join us here for a moment? We'll do a little clap, of course, to welcome you out and welcome Monique. Monique, please.
Ben oui, come on. Moi, je vais parler en français.
Wait, that's a fine idea to keep Pansavan with us. Yeah, you may take your mask off. We're all vaccinated here.
We have a party 2 days ago, so we're completely vaccinated.
So Monique, tell me, where are we right now, specifically, very specifically?
Alors, je vais parler en français un peu.
If you'd like, you want me to, I'll translate a little bit. We'll do some Franglish.
Just to salute our friend from the francophonie.
As we should.
Absolument. Alors, nous sommes au cœur de Montréal, au cœur du secteur de fabrication de Montréal, qui s'appelle...
Right, it's a garment district, right?
Ouais, mais vraiment qui fabrique à peu près tout dans tous les secteurs. Donc, c'est le district central de Montréal qui est vraiment dédié au design, au manufacturier urbain et aux technologies. Donc, on est venu s'installer ici parce que pour nous, c'est le potentiel de fabriquer un prototype Fab City qui est vraiment très, très fort ici. Donc, on est arrivé en 2019, puis depuis ce temps-là, on développe les partenariats dans le secteur. Et on organise le campus Fab City au cœur du district central.
Right.
Donc, on pourrait dire qu'on est dans le campus Fab City Annex en ce moment.
That's right. That's right. And this is Communautique, right? These are your offices.
Oui, ici, c'est le bureau de Communautique, qui est une organisation québécoise, pan-québécoise, qui travaille avec différents partenaires dans différentes régions du Québec principalement. Et on a notre Fab Lab EcoFab qui est dans nos locaux.
So EcoFab is the Fab Lab.
Ouais.
And Communautique is a separate organization that kind of umbrellas these different initiatives.
Oui, on est vraiment une entreprise d'économie sociale et on a créé le premier Fab Lab au Canada, puis on a accompagné l'essor des Fab Labs.
So the first Fab Lab in Canada, right here. This is where we are.
Pour nous, c'est vraiment une vitrine, c'est un lieu de recherche et développement qui nous permet de toujours pousser plus loin les projets de Fab Lab et maintenant d'inscrire les Fab Labs dans le mouvement des Fab City.
Right.
Donc, c'est ça.
So more personally, if you don't mind, Monique, what got you into this? Are you a maker yourself? Or are you more of an entrepreneur or an artist? Or...
Moi, je viens plus du domaine de l'éducation des adultes. Donc, ce qui m'intéresse, c'est beaucoup le volet formation à travers Communautique.
Adult education, right?
Ouais.
Forming people.
Ouais, andragogie.
Andragogie, never heard that. I won't try to translate it.
C'est andragogie. Puis c'est ça, donc ce qui m'intéresse beaucoup, c'est le volet de formation. Puis tout ce qui est l'innovation, on a commencé beaucoup en innovation sociale. Donc, qu'est-ce qu'on peut faire avec les technologies qui seront intéressantes pour nous, les humains? Et on a vraiment développé au fil des années notre capacité à même participer au développement de la technologie et des usages, mais du point de vue citoyen. Donc, ce qui fait qu'on va parler de Open Innovation et de citoyens comme moteur du développement des technologies pour qu'elles répondent à nos besoins et nos désirs, et non pas qu'on continue à travailler pour la technologie. C'est pour ça qu'ici, à Communautique, on a vraiment les volets formation, puis c'est ça, innovation, Open Innovation et animation de milieu pour partager toutes ces découvertes. J'ai vraiment un très large réseau là, pour avancer ensemble.
Well, I don't know if I need to say it, but I'm quite impressed with what you've created here. You know, I came here for the first time last week and the place was buzzing. You know, there's people making things everywhere. And what I loved about the ambiance is that, and this was mentioned earlier, no one is in their bubble. It's like as soon as you're doing a little discovery or you're having a hard time with something, there's someone right there, right behind you that'll come in and take part in what you're doing or offer their, even just their gaze, you know, to what you're doing. And I found that quite unique kind of collaborative environment. And I'm quite impressed. I congratulate you for your innovative mind, really, and for putting all of this together and bringing these great people together. I'm meeting great people here.
Bien, merci beaucoup. Puis c'est drôle que tu dises ça. Merci d'apprécier. Puis on avait George ce matin qui m'a fait la même remarque qu'il y avait un besoin technique. Puis
well, we coordinated ourselves, George and I. We prepared our compliments to you.
a trouvé une solution live à EcoFab.
George, of course.
Chérie te dit que tu es très belle. Oh, chérie, I love you so much.
All right, so before we get a kind of tour of the space, I'd like to bring in Francois and Annie. I think it'd be quite timely because what do they do exactly here?
François et Annie,
Yeah.
c'est vraiment eux qui accueillent tous nos usagers au FAB, donc ce sont nos médiateurs attitrés au Fab Lab.
Right, so they're the gurus in a way, the guides, the spiritual guides of the Fab Lab universe. Yes, please do come in.
Ce sont nos makers.
Nice.
Merci,
Well,
Jason. Merci.
Hello.
Hello, come on in, Francois.
How are you?
Very good, very good. So here I have Annie Ferlat.
Yes.
Yes.
Got it right.
And Francois Hautelaire.
That's right.
And well, if you didn't understand it already, it kind of all happens thanks to these two every day because they're the ones welcoming people when they come in, even if they're people that are used to the space. Everyone I've spoken to thus far has told me that they learned everything they needed to know here from either Annie or Francois, you know? So
and we learn it from them. So
well, there you go.
It's a nice mix.
Very often I would say, well, you should ask that to Francois, you should ask that to Annie, you know? So I'm asking you, I wanted to bring you in now because I wanted to talk about some of the projects that are going on here. And you see all of the projects that are happening. So what do you have here exactly?
So this is a small project that we built a few years ago, but with the pandemic, it was well different. Delayed.
Yeah.
So it's the Canary project. So it invites people to observe the environment and be curious about the invisible. So global warming, the pollution, the air pollution, it's all invisible and we cannot see it. So this is a tool that they can build and then they can be aware of what's invisible around them. So by being curious, ask them questions, they actually can monitor if their solution for the problem is good or not. So, and it's all built with some different kind of machines. So it's a really good initiative for the machine in the Fab Lab. So you can build all, disassemble, change.
It's an incredible project. You mind if I hold it?
It's
such
also
a beautiful object in and of itself. And the concept of the canary in the coal mine is just perfect. It's really perfect. You were going to say, Francois?
Yeah, it's also under $15 to produce.
Wow. Well, so that's worth mentioning.
This was one of the challenges that we had, is that since this is a citizen sensor that we wanted to bring to the more general public,
right?
We had to keep it very, very cheap.
And
we can tackle also, it's developed by, we developed it when we have the opportunity. So it's a very living process. And right now we're actually developing the IoT. Because
what does IoT mean?
So IoT, it's Internet of Things.
Okay,
and
right.
when you connect something to internet, they have a whole subject about it, the security, the malware. You have like a lot of subject to tackle, and they have a lot of IoT in Fab Labs that you can actually build. So if you don't know, it will be in French perhaps, but Saturday we will have a workshop just to try to figure out the good practice
around IoT
devices. So we have
and whose idea was this?
It was Citizen.
Take
actually.
Take it.
No.
Yeah, I was kind of,
it's Annie.
I was giving it to you.
Yeah,
and then you just passed it right along to everybody.
She's never taken the credit for.
It's because it began with a lot of person. We were a group of 5 and we were walking into the street and they were telling us, just try to observe your environment without, like with all your sense. Try to hear it, try to taste it, try to see the world in a different way. And a few weeks after, I actually go to the Fab Academy classes, and we need to build something with an input output. So I'm saying, hey, I'm gonna do air quality something, and here Project Canary. So together we developed the 2.0, and I don't know where it's going to be the 3.0, but very soon.
It's also, I think, just to finish on this, it's
Yeah.
important to say that it's also inspired by a bunch of other projects around the Fab Lab community for sure, sensor community, Fab Citizen, Sensor Citizen.
Sensor community.
Sensor community,
Actually,
something like
Saturday we invite the Lab Fab of Rennes. They have a huge program about the air quality, but more about also all the numeric consuming, and they built the Louvre-Daten, so it's sensor community, but it's well known on the Louvre-Daten. And Saturday it will have also one of the person who do the sensor community platform. But these are actually, you built it and it's connected to the internet, and you can have data all around the world. Sadly, we don't have here in Canada. I think we have one connected.
At my house.
At your house.
But, yeah.
So it's part of the solution,
Right.
but I think everywhere you go, you will have a small pieces, and then together with all this kind of different ideas, well, it managed to do a bigger
Right.
impact.
That's the key word that came out of my time here, was together.
Together.
It just kept coming up, and I just love that. I was always an annex to everything. It's like, well, how do we make it happen together? And I love that. It's very open source, very Fab Lab. I'm starting to understand what a Fab Lab is,
Yeah.
I'll tell you that. And I wanted to talk about the visors that you guys did.
Yeah,
I mean, we're running late on time,
Sure.
so
Sure,
it's a shame, but
no,
it's just so amazing that
it's fine. It's just, I think that it's worth mentioning that.
Yes.
Yeah, when the pandemic arrived, the first confinement here in Canada, we had this issue where we had to close up the lab, and what do we do, right? Do we have a job still, or do we have to go home and do nothing, stuff like that? So we start thinking about how we could help, and like we have around 2,000 Fab Lab in the world, and we saw every Fab Lab react in some ways, right? And in some scales. So we designed based on the Prusa face shield, which was 3D printed. We took their plans and we figure out some way to make it a bit more sustainable and faster production. Thank you. So yeah, so we did this face shield here, which is entirely laser cutted. I made a mistake to tell to my boss that once I finished designing it, I made a mistake to say, well, I think we could do 1,000 per day. And suddenly,
now you know Monique a little better.
Yeah, exactly. So suddenly, in the space of a weekend, we had 30,000 face shield to do in 30 days.
Wow.
For different hospitals around Quebec, Montreal City.
And
So we actually did it. We did 35,000 in 28 days. And you keep saying like together, the Fab Lab community and stuff like that. When I said to Monique, yeah, you do too. So we all do. When we said 1,000 a day, I was thinking about like me and Annie just, going on and on.
Wow.
And it took the community of like the environment of Fab Lab. We had over 130 volunteers to help us doing this whole crazy nightmarish mess of doing 35,000 face shield. And yeah, it's making sense behind these kind of space, right? I've been co-managing the lab with Annie for around 6 years now, and it's always so fun and it's incredible space. But this project right here really kind of,
it's another level.
It makes sense. It's just, okay, now we have a real impact.
It's like now the world is ending. What can we do
Yeah.
to save the
Well,
world?
in fact, now the world is ending, and the industry cannot respond like we do.
Wow.
So yeah, we were
I think the best thing about this is that if you 3D print, you cannot completely
disinfect.
sterilize
The face shields.
the face shield. So this is completely disassembled and completely sterilized, so you can actually reuse it.
Up to 6 times. So we did 35,000. 30,000 was equivalent to like 180,000 face shields, since the hospital could wash them up to 6 times using gamma rays. So it's
During that time, the plastic and the elastic was out of control. There's no
It
on
was
the
not
market.
available, right?
So we figure with
we have an expression here in Quebec which is tuer l'ours, vendre la peau de l'ours avant de l'avoir tué, which is like kill the
bear.
Sell the bear before you kill it.
Sell the fur.
Sell the
Before
fur.
you kill
sell,
the
sell
bear.
the fur before you kill the bear. And this is exactly what we've done. we sell the face shield before we had the actual material, and there were no more material on the continent. So what we did, and we didn't have the power market. So what we did is just call up the community once again, like the artists, the artisan, every kind of people that was in our orbiting around us, and every single sheet of plastic that we could take, it's
a great adventure.
It was a great mess. That was it. But it was amazing.
But a very
amazing
useful one.
Yeah.
Well, I congratulate you on that, and I thank you on behalf of all those hospital workers that got to use these shields when they were most needed.
Yes. Jason, sorry.
No,
One
please.
second. It's very, very important to know that since we're a lot in contact with the network Fab Lab, we really saw like this movement of every single lab going through their scale to help. This is not like us, EcoFab. This is the Fab Lab community that, like I said, it just made sense at the time, and it's very cool to see. So
And in the Fab Lab, they were masks.
Respirator, mask, visor, everything.
Everybody went crazy. So I think everybody like.
Yeah, I know
had the
Chloe
change
made
of-
a bunch of masks. Incredible. Well, I'm quite impressed once again. I think that's a perfect timing for us to take a tour of the Fab Lab here. So if you would go on to the video we prepared, and we'll see you back here in about 40 minutes. Enjoy the tour.
So we are on the campus Fab City site. It's in Montreal, in Annecy-Cartierville. And my name is Anna. I'm doing production-ish for the event. Each year, the Fab Foundation organizes the FAB16 and the Fab City Summit. This year, it's in Montreal, and we are doing a campus on site versus the event online. So that's why we are here in Montreal.
And where is this exactly? I think your office is very nearby, no?
Yeah, it's 500 meters away.
Yeah, you're in that building right there.
Absolutely. So it's very easy.
You like working for this organization?
I love it.
What do you love about it?
It's a human organization, and the human is the most important for community, and I think it's priceless. We are doing so many projects. Actually we are 100% on this event, but we have a Fab Lab, EcoFab, and they are doing so many things, and it's open to everyone, to the citizen, once a week. And the other days we are making projects, we are doing creation, we think, we realize, we imagine, we do a lot of stuff.
Hey, so my name is Thomas. So right now here we're in the Fab Lab one of the first Fab Lab in Canada, in Montreal, and the organizer of the FAB16 events.
Can you go show me? You have a project here that I want
Yeah.
to
So
share with everyone. Yeah.
So basically, the project began in France with a guy named Gaël Langevin. So Gaël Langevin began with designing an arm for a person that loses his hand in an accident, and after that, the community take the project. Gaël Langevin move forward, and the arm become the total arm of the robot, and then the torso of the robot, the head of the robot. And right now, I think they are still continuing the project, and you can see a full in-move robot. So it's basically an open source project. And few years ago, we decided here in Montreal to build the robots. So in different purposes. One of the purposes is really educational. So when people come here, they can use the robots and learn robotics. But also it's a project that go end to end. So I begin the project here in Montreal, following the instruction from Gaël Langevin and his website InMove, and then people take the project and continue building some parts of the robots. We name it Echo. I think it's really cool because it's all made with a small 3D printer. So all the parts you're seeing here, except for the electronics, are all made with a 3D printer. So it's awesome because with this small 3D printer and the small parts you're printing, you can get this kind of huge robots. So yeah, this is really cool.
Is that what you really love about the project, essentially, or is it also perhaps the fact that this Frankenstein-like creature is open source, is created by so many other people?
Yeah, also, and it's really fun because when someone has an idea of improving the design, he can submit his idea. He can show them to the community, and you can take the best ideas from different people and build your own version of the robots. So yeah, and I'm an engineer by formation, so I'm tripping on this kind of thing,
Yeah. Tell me about the rest of the place, if you don't mind. Can you walk me around real quick?
Yeah, sure.
Yeah, maybe even introduce me to people. There's so many boxes here.
Yeah.
So much.
So there are a lot of things happening. I think it's all in preparation to the different events. We have a lot of different machines. Here it's for textile. So it's broderie. I'm not sure of the word in English, but
like knitting?
Knitting, yeah. Yeah. So we have this, and we have here a lot of sewing machine.
Sewing machine.
Sewing machine, yeah. So kind of a lab for textile lab.
All the boxes, so many boxes.
So I think we need to ask
someone else.
Someone else,
Oh,
yeah.
yeah? Who would you ask?
Maybe Annie or
Annie.
For the cardboard, it's furniture that we are trying to do. So it's a technique where you assemble it like a puzzle, and then you can actually make some furniture. So we will need some seats for the people who are gonna go to the main event at the Fab City campus. And
they have like some kind of a thematic, because here we have some chairs and there we have some chairs. So we go back to one of the main project, which is reusing some chairs that was giving or that was meant to trash. So we went, picked them up. We told the neighbors, so people come by and they say, okay, we got some chairs, you can come take them. And we call a bunch of artists, designer, maker, everybody who was willing to do a chair. So you can have like this kind of example where he takes some table legs and he put it on this old chair, and this was another pieces where we find, I don't know where, but well, it do like a chair of their own, and we're gonna sell them at
An auction.
an auction, exactly, to finance a chair, a bench for the neighbors.
Right.
So we have this kind of thematic, which is the Creative Commons. So common, the chair is common. And
more boxes.
More boxes. We're gonna.
More boxes coming in.
Merci.
So what's your name and what do you do here?
I'm Annie, and I'm a mediator here at the Fab Lab Fab with my colleague François. And right now we're preparing for the FAB16, the Fab City, the Fab City campus, and the Fab Fest. So the Fab City.
Can you take your mask off?
Yes. The Fab City campus and the Fab Fest will be at the fields just in front of us at the building. And the two other events, the FAB16 and the Fab City, will be online. But this is worldwide, so everybody will be connected and everybody will share their experience. So all you see, it's for the Fab City campus and the Fab Fest in front. This is why we have a lot of things going on. And in the same time, we built a textile lab and we renew the wood shop too. So we have brand new machines, semi-industrial, where you can actually do like more, a little bit more than only your sewing machine. So you can do hammock if you want, bags, you can do a lot of stuff, but at semi-industrial level.
Right. And what do you, tell me what you like about working here.
I came from the world of architecture and design, more about the object. And what I really like is that when you have an object with you, it's like a magic. You don't know how it's done. You don't know how we do it. You actually don't know where it came from, because it came from so different places around the world. And what happened is that you put so much energy, so much traveling, so much money in that object, and then you buy it, you wear it, and you put it on trash. So the system of our consuming, I think it's broken, personally. So in the Fab Lab, what is very interesting, so you can actually touch machine, you can relearn to produce an object, or you can actually think about something and then produce it. So you really have this old process that you can do during one day. You can have an idea, produce it, and then have it in your hand. And if you don't like it, you can redo again, you can modify, you can change it as well as you want. And then what we see that happen is that when somebody else is involved, then your project is going to change direction, because it will be influenced by another one and by another one. So this is a little bit the magic that happened in Fab Lab. So you can actually go further and do better things. And there's another thing also, is that every Fab Lab is connected worldwide. So we speak to each other and we try to, sometimes we have problems in common. So for example, material. Everybody use cardboards, everybody use plywoods, to build stuff. And then somebody have the idea of yes, okay, that's good, but it's not the safest material. It's not the best material that you can use. Probably for some cases, you will need a material that will biodegrade instant, like after one use of your object. So we have kind of a problem about materials. So they start recipes and they start to build their own material in their Fab Labs, and everybody get involved. So everybody around the world can build their own and then share the recipe, for example, share the result. I did that. And then slowly but surely, we put our knowledge together so we can go further. So at each year's is the same process, same thing. We go further together, and this is, I think, what is the best in the Fab Lab.
Wow, that was wonderful.
Thank you.
You're done now. You're like, drop the mic.
It's my passion.
You're gonna drop the mic.
My name is François Auclair. I've been working here at EcoFab for 6 years now. I'm the main tech here in the environment. So me and my colleague Annie host, manage, and try to keep on working on the space. So it's a very, very ongoing process, which is very, how can I say, in line with the Fab Lab philosophy.
Right.
In general.
So why don't you show me around? Like,
Sure. Yeah, we have actually a pretty amazing lab. We're very lucky to have all kinds of equipment. I can make you a quick tour about the principal machine that we have here. We have the laser cutters, which are super popular in the Fab Lab universe, and people mostly go to these machines first because they're super easy to use, super versatile, amazing machines that gives you access to all kinds of material and all kinds of work that you can do with it. So the laser cutter are huge for us. They're so useful, very, very nice machines. Then we have the world of 3D printers, starting with the SLA 3D printing, which is powder printing. So this is working. It's pretty easy to figure it. You have powder, then you have a laser that goes up and forth and back. That kind of my English is failing me, but it kind of melt the powder together.
Okay. I guess it fuses it.
Fuse, yeah, and that gives you amazing results, mostly for molding, design, and stuff like that. Then we had this challenge here at the lab that we wanted to work with materials such as foam, styrofoam and stuff like that, mostly for composite. So doing, fiberglass and carbon fiber mold and stuff like that. So we design in community this machine here, which is mostly just a hot wire that it's not there right now because I use it for another machine, but it's a hot wire machine. So you have a wire that goes hot, and then you have 3 axes on the machine that let the foam travel. Well, the wire travel. So we can do all kinds of things with that, which is very, very interesting. Think about theater, like decor and stuff like that. Also,
anything you can sculpt and fold.
Yeah, but anything that needs to be light. You know what I light? Yeah, like costume and stuff like that. Very, very, very neat machine here.
And look at this insanity here.
You
guys built this?
It's actually not that bad. I mean, you have a few components here, but it's mostly driver for the stepper motor, and
This is probably the best place for my equipment to break down.
Yeah, we're a lab that are very, very interested in electronics in general. So from rapid prototyping such as PCBs on the CNC mills, and to directly.
That is beautiful.
Yeah, this is all done, and this
looks
is
like
not.
art.
This is not good though. Maybe this one is a bit better. These are not good example at all. But anyway,
I mean,
they're butchy.
So what do they do? What do they?
So all of these are electronic systems that we need to when we have to iterate for a particular system. This one here, I think, was just a receiver for an FTDI adapter. I don't even remember. Yeah, who knows?
You do stuff like this.
Yeah. Yeah, exactly. So when we have the final results, normally what we have to do is then make them with avec un fournisseur.
Yeah,
because this is not the final.
With a supplier.
Yeah, with a supplier, because this is not the final result. The final result always looks something more like that, where you have like an actual protection on the PCB, and you know there's all kinds of stuff that we couldn't do here, but for the iteration, it's amazing here.
And what is this?
So this is a huge one. Yeah, it's a 3D printer. It's busy these days for sure. This is basically your everyday FDM 3D printer, so Prusa or anything like that. It's just big. It's literally just big. So it gives us the ability to create stuff that couldn't be made otherwise. 3D printer are super practical for organic shapes. So when you can't necessarily sculpt with your hand or stuff like that. So the ability to create organic shape, huge. It's very, very interesting for us. We're on a project of printing for the School of Polytechnic submarines right now. So all kinds of stuff. Very, very, very neat. Very neat machine. Then we have
Reno making a mess.
Yeah, we have Reno that is always making mess. Don't even look at the wood shop right now. It's a big mess. It's crazy right now. Don't worry, we're not open to the public right now, so we can kind of afford this chaos. But yeah, we have the wood shop for any.
It's beautiful chaos.
Yeah, it's beautiful chaos, but it's still, it's chaos. So metal working.
Who's this guy? Who are we looking at here?
Reno.
Rhino.
Reno.
Yeah. The man's so good they named the city.
But yeah, Reno's been amazing with us. He's hosting the whole repair your chair project for the events. So I'll let you talk to him later with him. You'll see amazing resource to have here. Then again, another mess, but this is a pretty neat space too, the biolab. So this is where we're gonna be working and prototyping and experimenting with biomaterial, growing stuff, killing stuff, all that lives, right? So we mostly have like these tray of biomaterial that we've been trying to generate. So fish leather, like agar, plastics, bioplastics. We even have, eggshells, all kinds of stuff. With growing mushrooms. Oops. The idea is not to, generate a material that is necessarily like top notch. For sure, it's a lot of experimentation, but the idea is to create alternative for the community to say, well, maybe I don't need a sheet of wood, right? Maybe I don't need a sheet of plastic. Maybe I can just use a bioplastic.
Your own material.
Absolutely, yeah. So this is very, very interesting. We have the Form Labs, which are resin 3D printers for precision. Amazing machines. The incubator, all kinds of stuff. Then, yeah, it's a mess everywhere. Oh my God. Then we have like the more traditional 3D printer stations. Here at EcoFab, we absolutely love our Prusa. Don't want to market them or anything like that, but I'm just a huge fan of these machines.
What do they do?
They 3D print. So this is just a filament that you heat up, and once just think about a hot glue gun, but that is controlled by a computer. So the plastic heats up, and then it deposits on the bed, and hop, and you have a model, a piece, right? Something like that. Amazing machines, super versatile. I don't have bunch of example here, but I'm sure that.
Well, I can tell.
Yeah,
here.
well, this is but I don't know where everything is, but it's amazing to have access to 3D printers. The big huge thing with these is that you can have an idea, right? Design it on your computer, and a few hours later, a day after, you have your whole design in your hand, right? With one single machines. So it is pretty impressive, very, very neat. Then we have the Marforge, which is the same concept, but for stronger materials. Instead of printing like something like PLA on the Prusa, which is, my English is failing me again, but corn base.
Okay.
Very, very safe for the environment and for the human, but sometimes you need more strength. So the Marforge here are gonna be able to print carbon fiber nylon.
Okay.
Strengthened with fiberglass nylon. So the pieces that comes out of this are pretty much indestructible, near metal.
Wow.
So you can really, really work some, strength supply pieces with that. Then we have the precision machine. This is for the PCB, the electronic circuit I was showing you earlier.
Mm-hmm.
This is what we do it with, and also all kinds of metal working stuff. So you see, I'm in love with this machine. It's amazing. It's super cheap.
So you're drilling into this metal?
Yeah. So you have a mill.
It's a drill.
It's a drill. It's not a drill. It's a mill, because a drill would pierce holes, and this works laterally. Okay. But the mill, just work into the metal like this. Incredible, 50 micron precision. It's amazing. Amazing machine for precision parts, copper, brass, aluminium, wood, wax, anything.
Tell me, François.
Yeah.
What do you love about this place?
Well, I've been learning for 6 years old, right? I finished school, and then in social studies, not at all technology. And then I came here for an internship, and I realized that I was a total geek, that I love just, messing stuff around and broking machine. And I'm all about I'm more the machine aspect of the lab. So when we have a problem, I love to just open the whole thing and, go inside it. The Fab Lab environment is a bit crazy for me still, to think that you're being paid to learn and to play around with stuff and to just being trained. And yeah, it's something that I wish I will be able to make a career out of, which is I'm pretty happy with what I'm doing right now. The Fab Lab, what to say with the Fab Lab? I'm actually administrator of Fab Lab Quebec, which is a cooperative here that we have in Quebec to promote and create an ease of access to this kind of space. It really, really means something for me to have an access to this kind of space and to open to the general community. I think that there is a lot of loose potential, like a lot of people that don't necessarily find themselves at schools or stuff like that. And if they know and if they have access to these kind of tools, maybe they can develop incredible potential. And this is what I really, really starve on, is the fact that I see people that are just crazy smart, that they don't know they're crazy smart, right? And it's amazing to work with kids and with older people and with blind people, and all kinds of stuff just merged together to create stuff. And most of the time it doesn't work, and it's amazing like that. If it would be working, things would be boring. So yeah.
Beautiful, François.
Good.
Yeah, I saw you show this machine off.
Yeah. This is an amazing machine.
What is this, clay?
Yeah, so this is clay. Once you print it, you can do your ceramic parts. We work a lot with artists and artisan craftsmen. So to be able to create, food safe pottery is amazing. And with this, which is interesting, is that the paste extruder like that it's a 3D printer, but it's huge, so you can pretty much fill it up with anything you like.
Really?
So
just this machine?
No, it's not just clay, right? It's just pressure that exerts on the thing. So as long as it's able to extrude, you can do whatever you like with it. I made mushroom grows with this machine. I made all kinds of stuff. It's amazing. And then we have even just we're crazy, right? We don't know what we're doing. We bought this food 3D printer, I guess, just for yeah. So this is because we have this huge dream of having a Fab cafe, so people could come in here and just cook, right? But they wouldn't be just cooking and making coffee. They would also be able to build stuff while doing their coffee and stuff like that.
So I could say like, make me a pizza.
Yeah, well,
it's like Back to the Future.
you have Noemi that I'm sure you're going to interview on the textile part. Noemi is she's working for us right now as a freelancer, but she comes from just being a user of the lab, and then she followed the Fab Academy program. So she's an amazing example of what Fab Lab are able to create. And last time she did us some cookie dough, pumpkin cookie dough, and we're like, well, we can just put it in there, right? And we made this castle and all kinds of shape. Again, it's always just falling off and it's just funny, but that's the whole thing, right? It's why am I being paid to buy equipment like that? I don't know, but it's amazing.
Don't introduce me to Noemi. And
Sure, absolutely. So yeah, like I said, Noemi has been with us for something like 3 years now, and she's just always been around. And we did this program called Fab Academy, which you guys must know of. And we had to get ourselves a bit more acquainted with the textile environment. Noemi comes from the fashion design world. And I challenged her to say, well, can we build a textile lab together? So she was pretty much responsible of this whole room here.
What do you like about this place?
I really like that it's all kind of different people meeting together and working on all kind of different projects, and I feel like I'm in the right place, and it's always stimulating. There's always something happening in here.
And what do you do? I mean, you were telling me that you designed this jacket and obviously put it all together. And
yeah.
So yeah, what's your skill set?
So I studied fashion for 3 years, and then I wasn't sure if I wanted to go in the industry. So I tried different stuff, and then I discovered the lab, and I discovered the lab by doing projects here at my last year of fashion studies.
And what do you like about the working here, about the lab?
I really like having access to all kind of different machines and learning new machines too. So.
How about the people, the knowledge?
Well, François is the one that taught me a lot about maybe all the kind of machines I didn't know. So the laser engraving, vinyl cutting machines, and 3D printers.
How is it changing the way that you work or what you're able to create?
I really feel like there's no limit, and I don't know, working with all kind of new, what's the word? It's really fun to work with new machines and like adapt your design for it to work. And that's what I really like. You know, sometimes the 3D printer has some kind of look into it, and you can work with that. You can make it shine and make it like, yeah, that's it.
Wonderful. Can you get up and show me this jacket of yours? Because it
Yeah.
really impresses me.
Yeah.
I just love it.
That's
Yeah.
Thank you.
And you design all kinds of clothes.
Yeah, I design mostly on my time as a hobby, but yeah,
For
all
what
kinds of
use?
clothes.
You were telling me. What kind of thing do you do? Costumes? And...
Yeah, I do costumes and cosplays.
Okay.
Yeah.
Wonderful. Well, you wear this jacket so well, and I
Thank you very
congratulate
much.
you again for all that you do. I mean, I have a feeling I'm not even seeing the tip of the iceberg. Yeah. So what are you doing now?
I'm preparing the aprons for all the volunteers for the event.
Okay.
The Fab size. This not this.
Are any of these done?
We have one done.
Can you show me?
They're almost ready. I'm finishing the.
And this is something that fits the. It's kind of you're creating a little uniform, I guess.
For the Fab size.
Yeah.
Yeah. And there will be the logo here.
Okay.
What's the name? Yeah, logo. Logo. Yeah.
Damn.
So that's it. It was kind of last minute.
Well, I heard you guys were looking for a supplier to do it,
Yeah.
and finally you're like, well, we can do it ourselves.
Yeah, but it was so last minute that we thought maybe if we ask a supplier, they'll be more able to do it. But in the end, I had help from everybody. I had somebody cutting the pieces for me in advance, and some of the sewings were done by an internship here at the lab. And yeah.
Nice.
So I had a lot of help.
Oh, wonderful. Well, thank you very much for showing me your lab.
Yeah, you're welcome.
This is your space in a way, right?
Yeah.
You designed it.
It's not done yet.
Is it ever done?
Well, I mean, it could be. It could be. It's a place for a lot of different things too. So yeah, I hope it will be finished someday.
My name is Rino Cote. So I'm here for repair the chair. So I try to repair a chair. So I just want to see a different vision, a different color, shape. It's more like a sculpture than to repair a chair for repair a chair. I think I like everything from for the Fab Lab. It's really nice because it's like a sandbox for me. It's like a sandbox. It's like a Toys R Us for me. Because I found a lot of different tools, technology tools like CNC machine, laser cutter, 3D printer, scanner, 3D scanner, and it's free for the imagination. So the limit, it's just your imagination. It's not the place. It's not a different idea for the people. So you have a start point for a problem, for maybe an event like Fab Summit, and we start, and just every idea it's really nice. Just sometimes it's necessary to move to right or to left or fit inside this project, but it's a cool project. It's a cool challenge for me. So and I'm from Cirque du Soleil. I worked for 18 years. Our department for props and costume.
R&D?
What?
Oh yeah.
Yeah, for research and development. So we I'm coming here. It's nice. I have an idea for the place, for the job, like the repair the chair for this project. But today I switch to a different project, a different problem, maybe 10 times, and the day is not finished. So for me, it's really cool. It's challenging because if I have a schedule for each day, for a week, for a month, it's gonna be killing me. It's not for me for that. This minding for working. So yeah. So with this project, Monique asked me just build a chair. A lot of chair. If you have a time, again a chair, and a chair, and a chair, only a chair. So now this one it's more like it's called to the free fall, because I try to find a title for my. It's not really a sculpture, but it's possible it's a sculpture. So it's free fall. So I put a lot of a part of a chair or table, just called the seat, and in the wood, and a thing in my imagination, but I think it's right. You can see the point of each legs of the table, but at the same time it's going to be too sculpted, so it's comfortable at the same time. So yeah, and the other one, because I have a lot, it's more like a mess than a shop, but yeah, it's Toys R Us for me. So here it's the other one. It's more the I 3D print the seat.
Okay, you printed the seat.
Yeah, because we have 7 the same of this chair. So we have 7 chair of that. It's the same, but I just want to make some variation of the seat. So yeah, this one is the green and 3D printed, and it's called the plastic. It's a PLA, so it's a compostable plastic.
Really, this is compostable?
Yeah, not in your home with a small.
Right.
Normally, in industrial compost place, it's around 2 to 5 years, so it disappear in the land.
Oui.
J'ai fait des événements dans le Vieux-Port de Montréal. On
Avec
avait
elle.
une cuisine extérieure et on
Ok.
invitait.
And we're back. I hope you enjoyed that. I am now joined by Raquel Peñalosa,
Bonjour.
straight from Colombia today, Bogota specifically.
Yes, of course.
Tell me, Raquel, what do you do?
Well, I'm a Montrealer now, so I'm a landscape architect, but also I'm the person of community. So I've been involved with social innovation and citizen participation. So that's part of, widening my perspective and being involved with makers and people that are so creative to transform the city.
Wow, wonderful. So I guess it's you're giving me the segue into campus Fab City, right?
Yes.
What is that?
Yes. Well, Campus Fab City is the part of the Fab City movement. When we do an event like the one we're hosting here in Montreal, there's a place that we start saying this is the territory for prototyping. So because of pandemic, it's not as big as it has been in the last Fab City event, but it is a moment where we can come together. So with this on-live event, this is the time that only Montrealers for now. I hope we can do this because usually it's everybody that comes to the event. So it's inviting the community, the local community to come, prototype, learn what we're doing. And that's, like really the moment of fusion and coming together.
Right. See, that word's coming back. Campus Fab City, there it is actually.
Yeah.
So what's a Fab City as opposed to a Fab Lab?
I think it's the step further.
Right.
It's understanding the whole culture of the Fab Labs. Fab Labs are also the space for prototyping. So the open space for prototyping. So Fab City is trying to imagine, because this is an initiative. So in 2054, we're trying to say we tend to move into a different type of economy. So we're talking about circular economy.
Right.
So try to locally produce almost everything that we need and we consume. And what needs to
That's a
travel.
Fab City.
Exactly. That's a Fab City. So in that sense, you come back to understand what locally is important and the needs locally. Because as you know, globally, we have needs that maybe we don't need. So by understanding a Fab City and locally, and each Fab City, even if it comes with the understanding of the big concept of what is a Fab City, I think it is ingrained. Each city that becomes a Fab City will develop their own way of doing the Fab City. And this is why it's so important. And the summit that we're having at the same time is the exchange of this, what everybody will be doing in their own cities. So I think it's quite interesting because it's not a formula that everybody will apply, but it's really kind of like a framework, like an umbrella cultural change that
And a way of thinking.
Absolutely. I think this is a shift from a very consuming progress was
Right.
to transform cities in a more kind of globalizing
Right.
type of cities. So now, what is a new city with a circular economy? So what I think this is what I'm also looking for, because this is experimental. And now what we're doing is, what will it be an urban plan of a city from the circular economy? Economy has always dictated what the city, the form of the
True.
city. So now, what will be the form of the city when we think about circular economy? So how citizens become active. So how do we open this urban plan that is usually done in an upper level? How do we bring that into the ground and work with the citizens, all sorts of citizens, like we all become citizens? I think that's what is really interesting.
Well, that's fascinating. And it's happening les 13 et 14 août. That's, this weekend.
Yeah, Friday and Saturday, and it's
That's
open
right.
to the public. So I think what really became, demain se fabrique avec les mains.
Yeah,
So-
tomorrow is built with the hands.
Yeah, so it's coming back to this feeling of manufacturing, hands, people talking to, and having technology to support this exchange. We're right now, if I might say, we're designing a zone, which is a figure, is a I don't know if you don't know the geodesic, the one that we have
Right.
In Montreal.
Yeah.
So it's not a geodesic, it's another form that is
Okay.
a little bit more, it's all energy is working. And so we're designing that one, and it's been done for the last 3 weeks, and we're gonna be assembling it during the campus. So we will be able, so it's really, it's not coming with finished things, it's prototyping and
Right.
bringing, so we're gonna have a workshop on how we came about with this and what could it be later on. So I think
I
it's
love
an
that.
exciting moment for
Yeah.
at least the only moment that we'll be trying to be together.
What do
following
you
the
what do you
rules.
call Fabbers or Fab Lab people? What's the term I keep hearing?
Fabbers. Is a
Fabbers,
word,
is that what it is?
Fabbers, makers, hands-on. So I think it's a, but what is interesting is that all of us are this, but we have not, come to that to say, yes, I can do this. Yes, I can repair this.
Right.
So I think this is
That's the
also
new way of
the new way
thinking.
of thinking, culture, coming back to something and being there with, to the Fab, the days that are open to the public.
Wow.
Comes people from all backgrounds, people that are retired and engineers, architects, social, and they come together and there's a citizen asking for a question. So this site, we call the third view.
Right.
The troisième, third
Yeah,
space.
third
so
space, yeah.
Troisième view, which is the what comes when you can do come together with people. So the sense of community, and I think I will bring, and this is what Community is bringing to the movement, because this is at the base of us being a Fab Lab. We are also, we have deeply the sense of active citizenship. So
Right.
we are always, we're a living lab. So the sense of community, I think, is at the base. And I think this is what the Fab City is doing too. People think that it's only technology, but it's not. It's really technology to the service of community coming together.
Well, you speak very well about it.
Thank you.
Thank you,
Thank you.
Raquel.
It's a
Now,
pleasure.
if we have some fabbers out there that want to get a little closer to us, we might have a way for you to do that this morning.
Yes.
As you might know, us Quebecers, we eat a thing called poutine, morning, day, and night.
Oh, yes. No.
Yes. Right, of course. And that's exactly what we're going to do this morning. We're going to rush through the process. Help us make a poutine for you. I'm going to leave you to them. I might come back to have a bite or two, but why don't you two join us again? Thanks so much, Raquel.
Thank you. Thank you. Welcome. I think it's.
Hi. Okay. So yeah, we're trying this out.
So we got the
This
prize.
is like we've got a prize. It's a real TV show.
Wow. Guillaume, you're very dedicated because Guillaume is actually preparing a multimedia performance from the kitchen. This may look like a kitchen, but this is not the official Communautic kitchen. But this man is cooking something up for us right now, so we'll be joining you in a matter of minutes for that.
And so what are you doing here? You're
so it's funny because like everybody knows poutine, they associate poutine with Quebec, so that's what we're going to make for you. Actually, I'm gonna post on the Discord a real recipe that you can do from scratch at home.
as
Because
opposed
it's
to
not-
what?
As opposed to
As
those,
opposed to powder?
yeah, powder
Powdered,
or canned sauce.
sauce mix?
Maybe
Yeah.
you don't want to use that normally, but anyway, I'm gonna post a recipe that I found online and it's pretty good. I use it. Do you cook poutine?
You know, I never have, but I do
No?
eat it.
Yeah, most people eat it in
With
restaurants,
passion,
right? Yeah, with
yes.
passion.
Now, before we begin, I'm thinking I should really step back and lead you guys to it. But before we begin, should we start with a sake?
I think so.
Degustation de sake.
This is my mom's sake. It's made with honey and ginger.
So she's a fabber, your mother.
Yeah, she is. She's been concocting this.
She's a
for-
mother fabber. You got to be careful how you put that out.
It's been more than 5 years now. So you want to taste it? This one has organic sugar in it, and this one.
Well, I'll have the organic sugar, please. A hint.
A hint.
A hint. That's a hint.
A hint.
Thank you.
And a glass?
Yeah, I'm going to be sipping this off camera. And if you don't see me again, then you know who's to blame.
Come on, Monique. And Raquel. Sip.
All right.
Come on.
So let's have a quick toast to Quebec, to Canada, to the whole Fab world. Thank you very much for being with us this morning.
Cheers.
Cheers at home. Bonne poutine, les amis. Cheers. Cheers.
Thank you.
All right. We got to make sure we make eye contact. Well, your mother's a fine fabber of sake. All right, why don't you guys take it away? I'll step back, and if you need help, I'll just be over here
All right.
drinking.
Okay, no, you're gonna help me.
Oh, you're gonna
Yeah,
help me.
you're
You
gonna
want me
help
to
me.
help
Yeah,
you?
for sure,
Okay.
for sure. So yeah, we have the fries. Just like get some fries. Obviously, you will not be able to get that if you're not in Canada, or I think so. Maybe in the US they have some of this mix, but it's quite rare. So what I'll do is we YOLOing this shit. So right now we're gonna put the mix into boiling water for, let's say, it's like a tutorial, right? It's basically what we're doing right now is a tutorial for poutine. So let's see, 2-3 minutes, and normally I would whisk that, but in our kitchen, because here we have a bio lab, but we don't have like a full-on kitchen. So let me do that. And Sean, will you? No, you have to use a stir. Yeah, at the lowest speed.
Here, let me get my notes back.
Are you ready? There we go. So let's do that. Okay, go on. Yeah, here we go. That must be terrible for the sound at home. So now secret ingredient of poutine is obviously the cheese, which is curds.
Just to be
And
sure it goes well.
what do you think? Yeah, we're going down. There you go. That's the lowest, which is very high actually. Go on, yeah. So cheese, it's 3 ingredients. You cannot really miss it, but you can screw up the sauce, which maybe we'll do. I don't know. We don't use that at home usually. How is it going, Juan? We should have like a close-up of this thing going on.
Il y a des motons.
Yeah, il y a des motons.
Il y a des
Il y a
motons.
des motons. Let me help you with that here. a little bit. And there we go. So fun, do you make poutine at home?
No, I just buy my poutine.
It's very steamy in the studio right now as well. Like it's gonna be, it's super hot. So that's going pretty well.
Yeah.
Yeah, I think so. Let's simmer that a little bit. There we go. And may I have more sake, please? Because, I mean, it's early, but it's not that early, right? Thank you. Okay, so we have a nice sauce going on, and I think we're almost ready. Yeah, so almost. So give us like maybe 2 or 3 minutes.
Can I sneak back in here?
Yeah,
It's starting to smell
sure.
very good.
Here you go.
Let me get this mask off. I'm starting to smell like actual, that's the Fab Lab spirit.
Yeah,
You have all these people peeking around.
And Monique always has a plan B for
That's
something,
right.
and a plan C, and a
She's a
plan
bit
D.
of a micromanager, if I may say so. But who wouldn't want to be managing the poutine?
So yeah, that's why people buy it in restaurants. So they don't
So
have
there's
to
three
manage
main
it.
ingredients, if I understand correctly. There's
Exactly.
the fries, the sauce, and the cheese,
Exactly.
but not in any order.
No, and you can add whatever you want on it, but
That's
it's
right.
just not a classic. So we're going to go classic today.
Okay, I'm gonna go see how
So-
Guillaume's performance is coming together.
This is going quite
And it
well.
looks like we're about 2-3 minutes away from a taste test.
I would say like 1
I'll be
minute.
right back for that.
Okay. So what do you think, Bon? Does that look yummy?
Another minute, maybe?
Another minute? Yeah, let's go for another minute.
You can sip sake. Refill.
So we've got brown gravy. It's inspired by the brown gravy from the UK. So you have all this culture thing, you know, the French with the cheese, and the gravy there, and the potatoes. I think we're good.
How did this room get so popular? Suddenly everyone's smelling the poutine.
So popular and very hot. Are we good? I think we're good. Okay. So, I never did a kitchen show before. It's very fun. 1, 2, 3, 4.
Don't you find my
5.
timing
Don't
impeccable?
forget your beaker. It's very important to have like bioscience stuff in your Fab Lab when you make poutine. Let's drop some fries here.
You're not going for one big poutine?
No, I think we're gonna go like.
Yeah, it's COVID, post-COVID.
Yeah, exactly.
A post-COVID poutine. Where do you get your poutine?
So I live in Sherbrooke, and I will say, I think we've got the best poutine restaurant there.
Really?
Yeah, I think so.
Really?
You should
And then-
try the one in Gatineau.
Yeah.
That's Greece poutine.
See, that's what happens when we talk about
Yes.
poutine. Everybody thinks they have the best poutine.
That's
Yeah.
poutine
What do you mean?
Iloise. No cheese.
What's the name?
Iloise.
Iloise. So in Sherbrooke, it's Le Snack.
Iloise.
Oh, you know, you don't find this cheese
Sure.
anywhere in the world, right? This is like a specifically Quebec cheese, which makes the whole difference.
It's a squishy cheese.
Yeah, it's very
It's a
squeaky.
squishy- Yeah, I don't know what to call it in English, but it's like kerneled cheese.
Curd.
Curd.
Cheese curd.
Cheese
Yeah.
curds, there you go. Now, if you're ordering poutine from an American restaurant that, you know, is very hip and cool, so they want to do the Quebec thing, as anyone hip and cool would want to do, you'll usually won't find the right cheese. They'll put some cheddar on there or something like that, but do not be fooled. All right, then, so is your sauce ready?
I think so. It's brown, so
Man,
it's ready.
It's looking good, guys.
Yeah.
I must admit, I was a little doubtful.
You were?
Well,
With
now that
very-
I'm seeing the state of it, I can
with
say that.
Very good reasons.
Damn.
Oh, this one's gonna be like, it's more like a
Super
lake,
sauce.
a lake of
Yeah,
sauce.
because you
Sauce.
want the sauce to sit, the cheese to sit in the sauce for just long enough to melt it all together, but
Here you go. So you
we'll be fine.
poutine. That's my first tutorial of cooking anything.
Really? And I'm the official taster? Is that so? All right. Well, I'm very critical of the poutines. You know? I warn you, I'm gonna have a few fries to balance out the cheese. Mm-hmm.
Pretty good?
Very good. Surprisingly good.
Thank you.
For done on the fly like that, that was great. You guys aren't going to have any? That's a little scary if you ask me.
I will have to, for
Yeah.
sure. Like, we have more plates.
So, out there,
We're waiting.
You're waiting. I'm behind. Here you go.
until you come to Quebec and join us, come visit the Communautique and the Eco Fab Lab.
And you might eat poutine.
You can make this at home yourself and taste a little piece of Quebec.
And I will post a recipe for the salsa on the Discord.
That's
so,
it.
Here you go.
So thank you very much for this fine poutine, which I'll be eating gladly off camera again. Cheers again, and thank you to your mother. Say hi to your mother for me. I think that's the way they put it.
Merci pour le saké.
And I guess we're ready to go live to Guillaume's multimedia performance. Should I run over there? Yeah, go ahead. All right, we're off we go.
Oui. Hey, l'équipe, voulez-vous un shot de saké? L'équipe?
Ouais, vous devez
essayer.
Alors, sorry, I switch in English. Welcome to Stage Lab Lab Sign. It's a demonstration of what can happen when we cross Fab Labs and traditions together, musically wise. And here we go today with Paul, with Yves. We'll hear Robin as well. And we compose something for you. Yves is the poet that composed something for us. It's talking about Fab Labs, and it starts like that.
Voyage infini.
Toujours l'accordéon, toutes les notes de l'accordéon, notes et airs de danse, les plus populaires des airs de danse. Zampo est la nature, genre masculin, zampodo, genre féminin, zampoda, zampo, tout genre existant et ressenti.
Données ouvertes sur l'univers, action de partager la vie, de donner l'énergie, de créer une œuvre. Mère, la terre, elle est la musique de tous les règnes, animal, végétal, humain et surnaturel. Tout commence entre la forêt et le lac, notre pays, et de l'eau à perte de vue, grise ou bleue. Le lac est beau, effrayant, fragile, ardent. Elle est ainsi la métaphore de notre terre, terre totale avec tout le système écologique, cette harmonie vivante, cette musique qui coule des montagnes et qui berce les vallées. toujours la danse, les airs traditionnels, 1000 danses et des airs traditionnels, arbres comme les poèmes de peinture de la vie.
Nature, panorama de la terre, panorama de la vie, espèces, écosystèmes, habitat, diversité biologique, arbres, animaux, humains, fonds marins, terre des vivants, biodiversité.
Faire ensemble. La création est aussi cette action collective qui est inspirée par le besoin de vivre. Vivre pour créer, car créer, c'est aussi célébrer la vie. Totalité et unité, car le total est cette union, cette solidarité qui est rencontre des cultures.
Humanité, intériorité, univers de la création, espace intime, rêve bleu, vers l'hymne des utopies, aile de feu.
Faire ensemble. La création est aussi cette action collective qui est inspirée par le besoin de vivre. Vivre pour créer, car créer, c'est aussi célébrer la vie. Totalité et unité, car le total est cette union, cette solidarité qui est rencontre des cultures. S'adapter pour vivre, l'art de vivre, c'est l'énergie de l'artiste, artiste créatif, artiste imaginatif. Trad, trad, trad. Mais le grand ami de l'accordéon, c'est le violon. À toutes les occasions, champion de la joie, roi du plaisir, le violon. Chanson, mélodie, numérique, tout l'accordéon est joué. Trad accessible, trad populaire, trad démocratique, trad animé, trad dansante, trad en action, comme pour le Lab Scène Fab 16 Montréal en 2021. L'accordéon est célébré au cœur de la modernité, dans le battement des projets au centre du futur, au moment où le présent a tordu le cou au passé.
Et là, créer le monde, inspiration perpétuelle sur les marches du ciel, flamme de nos aventures, astre de feu, tapis de nos imaginaires, lune sublime de nos espoirs, steppe des mots et des sons, étincelle d'éternité, musique princière, musique des violons, sons et percussions, notes de l'accordéon. Temps mémoire, nomade indigo, mélodie douce sur le bouclier des guerriers, épopée des peuples, musique des ancêtres, mélodie impériale, chante les coryphées de la lune, désordre et ordre de la révolte, fluide mémoriel, arche du voyage sur la plateforme de l'infini, pont entre passé et avenir, mémoire éternelle.
Faire ensemble. La création est aussi cette action collective qui est inspirée par le besoin de vivre. Vivre pour créer, car créer, c'est aussi célébrer la vie. Totalité et unité, car le total est cette union, cette solidarité qui est rencontre des cultures. Imagine le temps. Imagine le temps est libre. Imagine de partager espoir et bonheur. Imagine l'odeur de l'encre. Imagine la pluie au désert. Imagine l'orage tropical. Entre savanes et montagnes, encens profond au cœur des amours. Pulsion, satellite de l'esprit, auteur de la création, folle autoroute, désir éternel. fusion, éclat, choc des cultures, création de l'espace, faire ensemble. La création est aussi cette action collective qui est inspirée par le besoin de vivre. Vivre pour créer, car créer, c'est aussi célébrer la vie. Totalité et unité, car le total est cette union, cette solidarité qui est rencontre des cultures.
Cultures autochtones, cultures diverses, offrant de leur créativité, une invitation au dialogue, diversité de personnes, diversité d'œuvres, de formes diverses, de couleurs, questions sur l'accueil dans notre société. Citoyennes et citoyens, aux expressions particulières, artistes exclus, artistes bannis, artistes ignorés totalement. Tant de musées, des institutions culturelles, artistes vivants de la diversité. Oui, nous, artistes de la diversité intégrale de l'espace public, en pleine révolution logique. L'accordéon se faufile, l'accordéon évanoui se réveille. C'est quoi la force des traditions? Les traditions sont vivantes. L'accordéon respire, il revit. Il revit sur l'autel du numérique. Numérique des données ouvertes, des rencontres technologiques, numérique sorcier, numérique allié au trad.
Musique, gamme du plaisir, mélodies sorcières et suaves, baté, khalam, kora, oude des lunes, flûtes ancestrales, notes éparses et folles. Danse, rupestres et élégantes, femmes artistes, souples lianes, rumba de l'esprit, tango désertique, sensuelle messe, feu des couleurs, visage, corps, cadence totale, divine couleur sonore. Faire ensemble, la création est aussi cette action collective qui est inspirée par le besoin de vivre. Vivre pour créer, car créer, c'est aussi célébrer la vie. Totalité et unité, car le total est cette union, cette solidarité qui est rencontre des cultures.
Artistes pourtant au cœur de la diversité artistique culturelle globale. Technologie, technologie naturelle, technologie de la nature, nature de la technologie, technologie analogique et allergique à l'immobilisme.
Faire ensemble, la création est aussi cette action collective qui est inspirée par le besoin de vivre. Vivre pour créer, car créer, c'est aussi célébrer la vie. Totalité et unité, car le total est cette union, cette solidarité qui est rencontre des cultures. L'accordéon se marie au numérique, trado-numérique, pour célébrer, mais les notes des violons, toutes en couleur. Pour l'Absent FAB16 Montréal, en 2021.
artistes.
On peut prendre un plan où on voit tout le monde, j'imagine
Oui,
ça c'est notre
on va
output.
prendre un plan où on voit tout le monde. On
Voilà!
va diffuser rapidement les crédits par-dessus le plan. Je veux remercier les artistes. Yves Alavo, poète qui a composé cette œuvre. Yves did this poem for all of us fabbers in the world. Paul, read it with us. Thank you so much.
I should thank you as
I have to
well.
go fast, but thank you so much for everybody that did help us. Open source communities.
Can we show this?
Communities.
Can we show this real
I would
quick?
like to introduce, so we finish
As
this
we are,
Poutine with the dessert. We can go all in the full screen without the credits, please, Rameau. And so this is
tell me what is this? Because this whole time we're seeing the images switch in the background, and I was seeing you tap your foot here like this, and to the same beat. I figured there was someone switching to the beat of the music, but it was in fact yourself.
It was myself. It's a digital footboard, or we call it podorythmics in French or in English, because in traditional Quebec style music we.
That's right. Can you do it on there?
I can do it on there. Right now, it's a very simple program. We call it the MIDI Défilator. It's open source. The Plank is open source as well. We have a Arduino board, Teensy board, program in Arduino. Everything is available. The story of it and the codes, you can contact us. It's on trad.wiki, trad.wiki.
So here I've become the art, or at least a part of the art.
You are.
All right, everybody. Thank you so much for joining us today.
Thank you so much.
For these 2 hours discovering Communautique, the Eco Fab Lab, and basically opening up our campus Fab City as beautifully as we possibly could have. Thank you to everybody who was with us on camera, off camera. It's very appreciated, and well, stay tuned. We're going to be live all day today, not from here, but from the entire Fab world. So you don't want to miss anything. Keep the stream rolling, and thanks again. Ciao, guys. Bye.
Thank you, Marco, Fawn, Jason, for that delicious tutorial on how to cook poutine. I know what I'm having for dinner tonight. And thank you, Guillaume and team, for the super fantastic fiddle, accordion music, art, and poetry from Montreal and its traditions. It's beautiful. It really is perpetual inspiration on the threshold of heaven. So thank you very much from our hearts. Now, I have a special visitor here today who just dropped by this morning, all the way from Israel, Ohad Meyuhas. Hi, Ohad. You can take off your mask just for the moment. It's a nice mask, though, by the way.
Thank you. It's fully fabricated, made in the lab.
Ah, it's beautiful. Well, Ohad, I think the last time I saw you was a year and a half ago, right before all heck broke loose.
Yes.
How did you survive? And how are you back here? This is amazing. I'm so psyched to see you.
I must say that this year was amazing for fabbers or makers. Like feeling that you are doing good by using the tools that you have, designing, and in my role at Stratasys, I was in charge.
A little louder. Let's get a little louder.
So we actually been possible to do things and to help other people. And this is what the Fab Lab is all about. As my role at Stratasys, I was in charge of the reaction of Stratasys to the pandemic.
Wow.
And imagine that you take control of machines all over the world. Apple, Ford, Toyota, all of those companies allows you to send files from remotely and print what they need locally. So it was actually think globally, fabricate locally.
That's
we
awesome.
made that.
Ohad, just everyone, Ohad, he really lives where he believes, right? So the last time I think I talked to you, you said you were finishing renovations for your apartment. And his apartment is a Fab Lab. I mean, it's like really crazy. Are you done?
I never done. I just finished making my library. But I always fabricate new things. So I don't know. I think when I leave this apartment, I will be done.
So do you invite the public into your apartment?
So during pandemic, things changed. Just before that,
sure.
my students used to come. And during pandemic, some of my classes, I ran in this lab because the labs in the university were closed.
Oh, interesting.
And I was allowed to invite up to 10 people to my home.
Good God.
So,
that's amazing. And you could do that in social distance and everything?
yes.
Wow.
Like using the balcony area and the lab and
So,
the laser.
so I was going to say, was the laser in the kitchen or was it on the balcony, right?
The laser is by the kitchen.
Oh, God.
And I have like 4 3D printers for different ventures.
Oh my God. Oh my God. Oh God, it's so nice to see you. We're going to have dinner tonight, I think. But just to keep us going here, coming up we have a bunch of great short videos from around the world. We've all been sitting around YouTube now for a few hours, so we'll start with an old Fabersize, and then we'll go to a video from the USA about bee mask, followed by a word from our sponsors, SolidWorks. Then
we moved to Serbia to learn about precision agriculture. Then back to the US for a DIY wheelchair project called We Scroll. Or
We Stroll.
We Stroll. After that, we will visit Notman House in Montreal, then to Portugal to Calyax as Rio.
Okay, and then we'll end the session with Spain's Remix El Barrio, which is a video about designing and crafting from food waste. So, enjoy!
Da da da. Da da da.
Recording has started. Okay.
Da da da. Da da da. Da da da. Da da da. Don't love you, you don't love me.
Material move.
Uh-huh. Da da da. Da da da. Da da da. Da da da. Don't love you, you don't love me.
Molding and casting.
Uh-huh. Da da da. Da da da. Da da da. Da da da. Don't love you, you don't love me.
Extruding material.
Uh-huh. Da da da. Da da da. Da da da. Da da da. Don't love you, you don't love me.
Gantry motion.
Uh-huh. Da da da. Da da da. Da da da. Da da da. Don't love you, you don't love me.
Put out the fire.
Uh-huh. Da da da. Da da da. Da da da. Da da da. Don't love you, you don't love me.
Lass's law.
Uh-huh. Da da da. Da da da. Da da da. Da da da. Don't love you, you don't love me.
Open the laser cutter.
Uh-huh. Da da da. Da da da. Da da da. Da
me the money.
Uh-huh. Da da da. Da da da. Da da da. Da da da. Don't love you, you don't love me.
Call it tightening.
Uh-huh. Da da da. Da da da. Da da da. Da da da. Don't love you, you don't love me.
Circuit board.
Uh-huh.
I'm a battery. I'm a switch. I'm an LED.
I'm a processor.
I'm a battery. I'm a switch. I'm an LED.
I'm a processor.
I'm a battery. I'm a switch. I'm an LED.
I'm a processor.
We got it.
Hi everyone, I'm Jeremy Simon with 3D Universe, but today I'm here to speak to you as a member of the BE Mask team. BE stands for Buffalo and Enable, and the BE Mask team is a group of individuals that came together around the beginning of the COVID pandemic back in early 2020, and it's made up of a group of individuals from the Buffalo, New York area, as well as members of the Enable volunteer community. And we came together and started having regular meetings online with the goal of producing open source solutions for addressing the shortages in PPE, for protective gear. So we came up with quite a few different designs along the way, but there are 4 that we're going to be releasing to the public, one of which is a 3D printable mask. This one here, this is called the BE mask, and our latest version is version 1.6. Number of innovations that were incorporated into this. There have been other similar 3D printable masks available, but we made some improvements. Number one is the material itself. We're using a material called Color Fab VarioSure TPU, which has an active foaming agent in it, so that while it's being 3D printed, the material actually foams and expands, and the result is that you end up with a very soft and very lightweight part. So it's much more comfortable, it's lighter on the face, and more comfortable to wear. The other thing that we did is figured out a way of making it easier to breathe without sacrificing the quality of filtration. And we did that by, first of all, picking a really good high-quality filtration material, but we then put it inside of a 3D printed cartridge, which allows us to put it into sort of a corrugated format where the filter is being bent back and forth. And that corrugation allows us to provide a lot more surface area within a smaller form factor. And so that allows us to breathe a lot more easily while wearing this mask. So that was mask number one, the BE mask. It's a 3D printable mask, just a couple of other basic assembly materials needed, some elastic straps, little barrel lock for adjustability, and that's about all there is to it. We then partnered with a company called Harbeck, who was kind enough to donate the time and funds to create an injection mold for being able to scale up production on one of our mask designs. And this design, as you can see, is a clear mask design, which we started to focus more and more on as our work proceeded, because we realized that even as masks were starting to become more available as time went on, there were still some communities that were not being well served, such as the deaf and hard of hearing, who really need to be able to see faces well. Some of them rely on lip reading, and that sort of thing. And even if it's just a matter of seeing people's expressions, that's a big part of communication. And we felt that that was lacking in people, you know, being around each other while always wearing masks. And so we wanted to come up with a solution for that. So this mask is injection molded using a soft and clear material that is very comfortable to wear, again assembled with a couple of straps. And as you can see here, we used a 3D printed cartridge for the filter, but it's positioned down under the chin, so that when you're wearing this mask, the filtration is happening down here so that it doesn't block your face, so that you have a clear view of the face. So that's the Harbeck mask, and that's the second design that we came up with. We then turned our attention to vacuum forming, because as an alternative to injection molding, it's something that's much more readily available, much more cost effective. And so we came up with ways of making clear masks using that technology as well. And this is the Be Clear mask, something that can be made with a desktop vacuum forming machine. As you can see, that creates a clear shell that can be used as a kind of an adapter in combination with a standard mask. In this case, we're using a KF94 mask, so that you know that you have reliable protection there, but all that filtration is happening, again, under the chin, leaving your face free and visible, so that people can see your expression and see you as you speak. So this is the Be Clear mask. And to take even another step towards accessibility, because not everybody has access to vacuum forming machines, we also came up with a way of making the same kind of mask using recycled materials. So just find yourself a 2-liter plastic bottle, and you can cut it down and bend it in a way that you can create the same kind of clear mask, or clear mask adapter, I should say, that you can use in combination with any standard mask like you see here, just a surgical mask. So these are 4 of the mask designs that this BE mask team has come up with over the last year plus of working together. And you'll get to hear a lot more about this from the team itself if you'll join us on July 1st at 7 p.m. Central for our next episode of 3D Universe Untethered. It's going to be a great time. You'll get to learn a lot about the process we went through, which I think at the end of the day is every bit as valuable as the designs that we were able to produce. So I hope you'll join us and participate in the discussion. See you all then.
Hey, what's going on? I'm Jason Poole, and I'm an industrial designer. And the same software tools that I use to create product designs are available for makers everywhere. So this is a very unique opportunity. 3D Experience SolidWorks and all the tools that fall into it are available for makers right now. I pride myself on creating 2D concepts and my 3D modeling abilities. Growing up, I always had a passion for design. I was always the guy that was, sketching, painting, sculpting, or just building something. Anything, it didn't matter. I just always wanted to make something. So that's why I pursued a career in art and design. After I completed art school, I was a video game animator and 3D modeling artist at Incredible Technologies. While I was there, I realized that I was missing something. I wanted to make stuff with my own hands. I wanted to build more everyday items, something that you could hold, something that was tangible. So I accepted a job with Orange County Choppers. While I was at OCC in Rock Tavern, New York, I designed over 300 custom motorcycles. Most of these bikes and the whole process was covered by a hit TV show, American Chopper, which aired on the Discovery Channel in over 160 different countries. I had so much fun working there, and the insanely talented crew that I got to work alongside of, but I still wanted more. I wanted to design more than just custom motorcycles. And I just feel good when I'm actually making something. And so I want other makers that are out there that have the same passion I do. Now's your chance. Now you can have access to these very powerful 3D modeling tools. It's something that used to be only reserved for professionals like myself. People that are new to SolidWorks and the 3D experience, there's lots of resources that you can find online as far as training and seeing how other people are using it. Another great resource is the Made in 3D community. This is where you can log in, check out what other people are doing, post your projects, get feedback, and get inspired to make your next huge project. I've been a maker at heart since day one, and this is just so awesome to be able to see the power of these tools get put into other makers' hands. What everyone's going to be able to make, the creativity is endless, and the possibilities are amazing.
Nakon traganja za onim što će doneti najdugoročnije benefite preciznoj poljoprivredi u Srbiji, doneli smo odluku da najmlađim generacijama koji su budućnost poljoprivrede predstavimo alatke precizne poljoprivrede i kako one utiču na donošenje optimalnih odluka u poljoprivrednoj proizvodnji. Pa smo tako u srednje poljoprivredne škole instalirali meteo stanice koje smo povezali sa digitalnom poljoprivrednom platformom AgroSense i na osnovu same platforme AgroSense sastavili nastavni plan i program koji bismo želeli da uvrstimo u obavezno srednjoškolsko obrazovanje u poljoprivrednim školama. Ovo smo sproveli zajedno sa našim partnerima iz Ministarstva poljoprivrede i obrazovanja kroz različite događaje koje smo sproveli u okviru projekta SISCO.
The prototype has been applied successfully on a small scale, and the next step is to expand it in schools on the entire territory of Serbia and make it a mandatory element in high school education. A wide number of policymakers and school directors supported the implementation of the teaching module in the official national curriculum, helping the installation of the technical equipment needed in all associated schools. After the installation of the technical equipment, the schools are provided all the teaching material and instructions needed to implement the teaching module and use the AgroSense platform to implement it. A new generation of farmers will be based on AgroSense performances and benefits, enabling them to use the platform in their own agricultural production and benefit from precision agriculture tools still underused in Serbia. We hope to educate a lot of new professionals on how precision agriculture could benefit them in many different aspects of their everyday working environment in the future.
A group of high school students at the Bullis School in Potomac recently won 2 international awards for inventing and designing a device that enables people in wheelchairs to push a baby stroller. What makes the story even more special is that they came up with the design to help one of their own teachers.
And it's just really amazing to see, you know, my husband, Jeremy, who you guys got to meet virtually, and our son be able to enjoy these things. So we just wanted to say thank you guys so much for the amazing innovations that you guys did this year.
That is middle school teacher Chelsea King thanking the team of upper school students who helped create the Wii Stroll that's helped change her family's life.
So my husband had brain surgery 3 years ago, which left him with a lot of physical challenges.
Challenges that affected his speech and balance, which meant he would need to use a wheelchair.
And then when we found out we were expecting, we kind of immediately jumped into, okay, how is he going to do certain things for our baby that normal parents don't really have to think about? And one of the things we really couldn't find was a way for him to enjoy walks with our son.
They scoured the internet and came up short.
We really just wanted a way to have, you know, walks as a family and for him to be able to do everything that a parent without physical disabilities does.
And then Chelsea remembered the head of the school
School's Bit Lab, Matt Ziegler, taught a class that made things for social good.
It seemed like a sort of perfect challenge for this class. One, it was great to have it as a challenge, but two, it was great that it was somebody in our community that actually could benefit from it.
The class was also touched by the challenge. They interviewed the Kings virtually to get a better understanding of the family's needs.
I would want the ability to do it by myself.
Over the course of several weeks, the teams refined their ideas.
Ibanka had a group and I had a group, and we both made a design, and it turned out that both of our designs, if we combined it together, would make like a superior design.
It was difficult, but it wasn't impossible.
They tested the designs and eventually came up with 2 wheelchair stroller adaptation devices they called the Wii Stroll.
Mr. King would put in the attachment piece. Next, you get the car seat and put it into the attachment piece. And then next, you just simply buckle the baby in.
Next, it was time for Chelsea, her husband Jeremy, and their new baby boy Phoenix to try out the Wii Stroll themselves.
The first time we were able to take it out in our neighborhood, just the 3 of us, it was amazing. So it was just kind of a match made in heaven with what we needed and what Matt does with his classes.
The Wii Stroll not only helped change the Kings' lives, it also changed the students who created it.
To see the smile on his face and just to know that I was able to help give him that connection with his child that he wouldn't be able to have because of his disability.
So it definitely made me feel for them, and it made me mad because something like this should be made already, and we shouldn't be the ones, high schoolers, making these designs.
The King family is beyond grateful that those high schoolers made the designs that are helping their family enjoy what many of us take for granted, a simple family stroll.
To see that they're thinking outside the box, how passionate they were about the project, and I think, it connects that they knew me and they knew my husband, so we just want to say thank you so much to them, because without them we wouldn't be able to have this very simple thing.
I love the story. Chelsea told me when her family is out with the Wii Stroll, people often follow them or smile, and not because of her husband's disability, but because they're seeing him enjoy the simple act of taking their son for a walk, even though he's in that wheelchair. Again, that talented team of 10 high school students who came up with the Wii Stroll have won several awards, including international awards for their design. And I know there's a lot of people out there who could use this. So if you know someone who could use a Wii Stroll, you can visit the Bullis School's website or even call the school for more information. I mean, Erica, just to see the looks on their faces, it was just amazing.
No, it's fantastic. And to hear the students say, yes, we did it, but it shouldn't have taken us. This should already be something that's out there. But good for them for seeing the need and doing it themselves.
Absolutely.
This is fantastic. Great story, Sean.
Thank you.
Very nice to meet you. Thank you for having me today.
Glad to have you here, Sherry. Welcome to Notman House.
Thank you.
This is our little entrepreneurial campus in the heart of Montreal. It's a house from the late 1870s, 1890s. Famous photographer who was also an entrepreneur, and he shot most of the history, the Canadian history that was in the making at that time. This was his main house. And in the back we have what we call the campus, which used to be a hospital for end-of-life care. So, and now we have companies that are being born here, so it's like circle of life.
I like that a lot. So he was an entrepreneur, and now this is an entrepreneurial birthplace, so to speak.
It is. It is. And that's one thing that was missing in our ecosystem, right? How do you get started? And sort of our thesis is that hackers, scientists, maker wants to become entrepreneur, but they don't really know how to start, where to go, and they need some resources to get started. So that's what we're trying to provide.
That's pretty awesome. Oh wow! Look at this.
So we ask donators to pick some of William Notman famous pieces, and then come up with a quote about entrepreneurship, inventing, innovation.
Oh my gosh, look at that.
This is a nice one.
It's
and they've been
beautiful.
colorized This is my definition of entrepreneurship. Jump in the river, ride the stream, avoid rocks.
That's a very good advice, I'd say. Very good.
McGill band, fanfare. Where our music is welcome, we will play it loud. Where our music is challenged, we will play it louder. That's kind of the spirit of Montreal.
This is a beautiful picture, and it's a Mahatma Gandhi quote. The future depends on what you do today.
You have it in your hands.
Yes. This is amazing. What is the space?
You wouldn't guess that from the street.
No, you would not.
So we run events, meetups here. There's thousands of people that come in this every year. And so the hackers, the makers were looking for a place where they could meet and they would call their own. And when we found this place, we were like, okay, we'll just try it for a year. We rented it for a year before buying it. And we just said, anyone who wants to host an event, if it's free and open to the community, we'll host you.
Good for you.
And we got hundreds of events in the first year. And we're like, okay, this could work. Let's buy the house. People were working out of their basements, but they didn't have a place to meet and for serendipity to happen. So that's what we're doing here.
That's kind of neat. That's kind of like a Fab Lab, right?
Similar.
Bringing like-minded spirits together, right?
Totally. That a lot of these hackers, makers, scientists, researchers, they don't fully realize how they are entrepreneurial forces themselves. So they have to meet other people. They have to, I guess, be put in a context where they say, I can be like you, right? And then this is what I like in the lab. Like you work alongside someone and you're like, oh, what are you doing? Can I learn this?
Right.
And I think this is how you learn entrepreneurship too. You learn by looking at other people, by saying like, oh, this is how you do it. Yeah, knowledge sharing, learning from others.
Right.
Peer-to-peer, sort of like peer mentoring is something we do a lot.
The vibe here is very nice that way, right? Yeah.
It's an open house.
Yeah. We just get you a Fab Lab here.
Well, we tried. Well, actually, the thing with Montreal is that we do have a few labs around, but the challenge is it's a patchwork city, right? So we have, if you go down southwest, there's a bunch of great places to have labs, and that's where the makers are.
We really want to be able to talk about this continuum, right, in Fab City, right? And you're doing it. You're kind of living it, and it kind of relates to this idea of, what are the foundations, the infrastructural foundations, what's the educational path, how do you get entrepreneurs and support them, et cetera, and it just kind of builds from there.
I always say the best entrepreneurs are humble and ambitious, and to be ambitious, you have to meet other people. You have to be able to say, wow, what's happening at McGill is as awesome as what's happening at MIT, and you know what, this university in Okinawa or in Paris is also doing something amazing, and this community is already connected on the network.
Entrepreneurship and the skills that you learn, say, in digital fabrication or in a Fab Lab or makerspace, that's the education of the future. We can't train people to do automation. We can't train people to do the old manufacturing jobs, and they're not going to be the same jobs anymore,
yeah,
right?
That's for sure.
It really does point towards a more innovative, independent, problem-solving kind of
yes,
person,
a continuous learning process, right? Learning how to learn, and it's not you're going to school for a few years and then you're done. Actually, you don't know what's coming up in 5 to 10 years, even 3 years.
Yeah.
So this capacity, this ability to support people, support society as it changes, it evolves, is crucial, and we're not there yet.
Can I say thank you for what you're doing?
Well, thanks for being here.
And you're like a fabulous ambassador.
Thank you. I'm having fun. I mean,
that's what counts, right?
Yes, indeed.
Olá, sou o Gonçalo Praça da Ciência Viva e o desafio que escolhemos é este. Está aqui um rio tão grande, tão bonito, quase sem ninguém. É um desperdício de oportunidades. Nós procuramos pessoas que sentem o mesmo problema que nós, desde governantes locais à comunidade escolar, investigadores, associações e clubes náuticos e pessoas comuns do bairro.
Sou o João Marques. Desenhámos um festival anual com atividades para mostrar como o teste poderia ser um local seguro, interessante, acessível e onde os próprios participantes alimentassem a programação do festival através da cocriação e que construíssem caiaques que pudessem ser navegados por todos nos vários rios.
Why only kayaks to the river? What we want is people on the river, and a river for the people. Do you want to build boats? Great! What about planning, organising games, tours in the river, scientific expeditions, new sports? We will invite schools and all those who dream of a river for people, neighbourhood and city officials, Sea Scouts, makers, clubs, associations, public. We hope to populate the river little by little, proving its creative, educational and fun potential, and sharing this to policymakers, leading to a festival open to the craziest ideas. The Future Festival, the river to the people.
So that was an amazing vision from Serbia for how to scale fab and precision agriculture and digital fabrication. And the high school students at Bullis, boy, creating a DIY wheelchair and a stroller combination, that's a super cool project team. Very inspiring. And I do remember visiting Notman House. It was a hub for innovation. It was a really interesting space, you know, a combination of historical and modern, full of entrepreneurs. But before we go to our next session, I wanted to talk to you, Ohad, just a little bit more about the distributed PPE project. It was amazing. I mean, you basically took over all of the 3D printers across the world and were making PPE, you know, and it was extraordinary.
So imagine that you have a cloud manufacturer and you can actually distribute those things. So the vision, when I studied at IAC, before joining the Fab Lab Academy, like Fab Academy, the idea of local manufacturing and having only raw material to the cities instead of shipment. Imagine, like when you buy at Amazon, how many foam and air do you actually ship in order to get your products? And then you can make those products with the Fab Lab or the micro factories that you have in your area. So that time was amazing. We showed the world that it's possible.
That's right. That idea of distributed manufacturing, which has been kind of like a holy grail, but you know we've never really proved it. Yeah.
And everyone started to believe in that. And the day everyone started to get vaccinated, it seems like the world came back. To
you mean like
the old habits?
The old habits, yeah. I mean, it's sort of centralized manufacturing is, you know, it kind of it tears away at our resilience, right? Our local resilience. You know?
Like, why do I buy fruits, or why in the U.S. you buy fruits from South America? why can't you make it over like locally? We have enough rooftops, we have enough space maybe within the cities to make it locally. Maybe we need to make it, I don't know, there are lots of things need to be debated.
Yeah, it's like we have to change the mindset from central to local, right?
Yes.
And it feels like we need, it feels like we need governance and policy as part of the solution, which is really interesting because
But we showed the world that it's possible.
Yeah, we did. We did show the world that it was possible. So thank you, Ohad. It was so nice to see you. Thanks for visiting us today. Now we're going to go visit the Nordic Network. Coming to us live from the Copenhagen Fab Lab, we have Rasmus Fangel. Rasmus, hello from Boston. What's
Hey, from Copenhagen. Hello from Copenhagen. Yes, I'm Rasmus Fangel Vestergaard, and welcome to Copenhagen Fab Lab. I just heard the last of your chat before, and we also went into the PPE market here. We shipped around 130,000 visors from this facility here, and that was quite the effort. But it was really worth doing, and it was really a big community effort here. So that was what we're doing at the start of this world event that has created some difficulties in doing things as we normally do, and that's also why we are hosting the Nordic Fab Lab Boot Camp in Copenhagen this summer. Normally we do the boot camp in a Nordic country in the dark, cold winter in January, so we are available to go to the Fab conference as well. But this year we decided to do it in the summer, and we tried to team up and align with you so we can show and tell you a little bit about what we're doing here. So from the chairperson of the Nordic Fab Lab Network, I would like to welcome you and take you on a little tour of our facilities. So come on and walk with me, and I'll show you what these people are doing. And mind the mess. We start by going to our teaching facility where we have several workshops set up. So, hey guys. Hello. So hi to well, it's both the Danish and the Swedish crew that are here. And what are you guys working on in there? You're working on something special, I know.
It's something that's close to my heart. Actually, a brew that's every person that life loves. It's beer. When we come here on Monday, we got a lovely tour of the facilities, the old lab and the new lab. And when we came here, we were surprised by actually that we are going to make beer. And this workshop was beautiful. And after the workshop, we got to taste the finished result. It was not finished. It was made 1 week before, but you know the thing. So it was really lovely to actually sit here and drink it.
Oh, it's
yeah.
good.
Oh, you know it.
Could you show us the brewing facility as well? What you've been working on?
Yeah. Except for the thing, like the tap, we also have our workshop beer that we made on Monday. So we have 4 different batches, and from the different groups, they all did a different hop style. 2 of those are a bit lighter beer, and 2 of those a bit heavier beer. Personally, I was in the group with a bit heavier beer, and maybe a bit too citrus hop style. But we have some of those that should be a bit lighter. Like we have 1, 2, 3, 4. Our beer version 3.0 had Citra, Centennial, and Wahiti, something. I'm not a good at reading actually. But here, hopefully in a week, we get beer to tap. Cheers.
Well, it's not all fun and games here. We also work hard and not just play hard. And Tim here has been on Fab Lab that has been working on giving an introduction to what kind of drones are they?
So me and Joachim just recently had a small workshop on building your own trash drone, let's say. So all the scrap materials you can find in laser cutter or 3D printer, we combined those into building small, fun, interactive drones that you can play with, just an adult or small kid. So this is more or less the results that's still alive, let's say, because a lot of them were trashed and in pieces and so forth. So we have a couple of functional drones here. So these are that we're flying both indoors and outdoors. Hopefully it's not that windy in Denmark.
I'd like to emphasize this drone actually is flying. So
it's a brick of styrofoam.
Look how cute and scrappy this is. So everyone can do this. It's great.
Yeah. Want to pass me the cream and sugar? Yeah, well, I said work hard. Maybe that's not quite the word, but actually, we actually had a sports complex available for you to fly, but the weather is almost nice in Copenhagen, so we're going to fly outside a little bit later. But let's see what they also are doing. Maria? This is Nacha from one of the newest Fab Lab in our organization. Well, could you present yourself and what you're working on?
I'm officer of Fab Lab manager in Greenland, Sicily.
Sicily, yes,
Yeah.
in Greenland.
It's pretty new, so I'm new too. But right now I am 3D printing using Multimedia.
Yeah.
And I am, how do you call it? I designed, right now, it's like this one.
Yeah.
I designed it myself.
Very nice. Good work. And we have our French team over here. And what are you guys working on?
Hi guys, my name is Alex. I'm from France, and I'm currently working on SketchUp, trying to modelize the makerspace we have in France. So yeah, this is what I'm doing now.
Yeah, and you managed to print some of it, not running
Yes,
out of
exactly.
filament.
I would like to make a different piece of this Fab Lab, so people can just come by the place and just use like a Lego, the different piece of them, and to make the makerspace, but looking like a Lego, you know.
Yeah, careful one, not quite Lego.
Yeah.
In Denmark, you know, could be dangerous. Well, as we said, we work hard, but we also rest hard. So we set up our break room for having a nap in here. A little bit of flex. Oh, it's empty. That's brilliant. That means no one is napping. But when you work hard, you also have to rest hard. So we set it up so everyone can go here and relax once in a while. Have something to eat. We'll walk further down the halls and see what else is going on. See? Hi, Sam. Sam, also Fab Lab Hamstad. What are you working on?
I'm trying to protection for our sisters. So I took some cardboard, made some holes, and hopefully it's gonna fit. Yeah.
Is it you working on the embroidery machine as well?
No, that's me.
Ah, that's Australia.
Yes. I'm trying to make this logo first time. This one in our embroidery machine. So that would be the project, and I also want to teach Sam and the other attendants how to use the embroidery machine at the lab.
Yeah, I'll have to take a refreshment course as well, I think.
Yes, everyone.
Everyone has to take a refreshment course. This is a sort of a mixed room, so we have both our sewing corner, soft cover corner, and we mix it up so we have the electronics on the other sides, which works really well for us for wearables and stuff like that. So it's a really nice mix of things in here. I think Yanni is over here. Yeah. Hey. Would you like to introduce yourself and tell us what you're working on?
Hey, I'm Yanni from Fab Lab. So I'm working on this, repurposing this old LCD display. So I thought I would make it the way that I'll add this potentiometer and connector and just few cables, and you can use it temporarily in different projects. Say you want to get settings done in rural conditions, you don't necessarily want to get your computer there. You just want to see what are the values. So you can move it from project to project.
Oh, so your own little field kit.
Yeah.
Oh, that's nice. Very neat. All right. Let's see what's going on in the laser room. I hear something inspiring at least. Hi. Would you like to introduce yourself and what you're working on?
Yeah. My name is Johan. I'm from the southern part of Denmark, Fab Lab Dynamo. And here I'm trying to make new frames for the drones as fast as it's breaking in the field. So it's a kind of competition. We try to make a new one as fast as they break it.
And who's winning the battle?
They are.
They are breaking or making, I guess.
Yeah. All right, so this is a breaker cam.
It's a breaker cam. Very nice.
And are yours? Hey, I'm Jonas. Fish cutting.
Fish cutting.
Yes. I'm from the Faroe Islands, and it's the Faroe team behind me here. Based in Copenhagen. Hello. Hello. I'm from Faroe Islands.
That's the whole team from the Faroe Islands.
Yes, it is.
Faroe team.
And two different labs.
Yes. Well, Faroe and Barbo.
Yes, exactly.
You're well covered in the Faroe Islands when you look at population. Pretty good rate.
In fact, actually, a third one is on the way.
Really? Wow.
So in
In
Notman,
Jordan.
capital.
The capital finally gets to that.
Yes. And I actually heard that when the third lab is coming in the Faroe, we probably will be one of the country in the world that has most labs per
capita. Per capita. And fish per capita, obviously, I can tell. Sure. Nice mackerels.
Yeah. So
One is for you. Oh, thanks. I'll try this. Try not to break it. Let's have a look at the wood section as well. What's going on in that? I know Johannes has been working as well. And there's no one here. Fantastic. One of the things with the Nordic Boot Camp is that it's not only to work on projects and new things and develop things, it's also a way for us to do maintenance and help each other set up facilities. For instance, we've been working on our shopbot for a few weeks now. We had to move it from our old lab, Copenhagen Fab Lab 1, and now we're now at Copenhagen Fab Lab 2. And so everyone has pulled together and used the expertise to help us set up an indexer and redo all the wiring and set up it as a test facility. So that's the way it works here at the Nordic Boot Camp. You don't have to have the perfect facilities as long as you are willing to work with others and help others when we arrive. It's a great way of doing things, and you learn a lot. I learn a lot every time, and I hope it's the same for everyone else here. But seeing the weather is so nice, I think we should go for a walk outside as well. Right. Oh, they're playing with drones, obviously. So I think these are the leftover drones that I can play now. It's like a bee swarm here. Nice. Like, ah! I won't survive until we get to dinner. I'll take you to our final room to say goodbye. We're getting ready for dinner and we'll have a walk out there. Here in Copenhagen Fab Lab, we have great facilities in the sense that we are housed in an old sporting facility. So we have a lot of green around. And when COVID struck here, we made the effort to build like a rather large meeting room outside where we can host both like conferences like this and meetings. So we built it with Wi-Fi and power, but in reality also build it as a living test lab. So the whole facility is going to be covered in hubs that we use for our brewing lab. And as you can tell here, some of it's been a very hard summer in Denmark for growing things, but some of our test stuff has gone up. It's the experiment with another volunteer organization doing different sorts of hubs that we test. And they actually run quite a few experience with it, with metrics and stuff like that. It's very interesting, the project. So the idea is actually that this should all come up to a height of 8 meters, and then we take it down and harvest everything, and then we put it back up again. But let's see who's inside. So I think this is the goodbye party for us here in Copenhagen. I see the fire is starting and the beer is coming out, so it's dinner time soon. So we just want to say hi to all of you, and I guess it's well, goodbye from Copenhagen. Bye. Bye. Bye.
I was going to fill it for you.
And back to you, Sherry.
So thank you, Rasmus and the Nordic Labs. You know, I love your labs. Thank you for the tour and such great work that you're doing. Now, coming to you live from MIT, we have Professor Neil Gershenfeld and the amazing researchers and graduate students from the Center for Bits and Atoms right here. So this research facility served as, I would say, the model for the Global Fab Lab Network. And this is where the CBA team continues to explore the boundary between the digital and the physical world. So they're going to take you on a tour through this original facility across length scales from nano to micro to meso to macro. Enjoy. Neil and team, the air is yours.
Are audio and video good?
I think we're good.
Okay, so I'm Neil Gershenfeld. This is Center for Bits and Atoms. We're starting from an atrium. If you look up there, this is a 10 million euro that's worth as much as the rest of the building. It'll live on beyond the rest of the building. And then we're going to go through CBA labs, and as we go, I'll introduce you to a range of people. To understand the tour we're going to do, think of it in powers of 10. There's a $100,000 Fab Lab that was the model of Fab Labs. That's nested in a workshop for manufacturing that has machines that are each $100,000 to develop what goes into Fab Labs. And then that's nested in a research lab where the machines in the research lab cost as much as 10 of the workshop machines to do the research even further upstream. So we're going to walk through each of those scales now. So if you come here. And I should mention behind the camera is Zach, we'll meet in a little bit. This is where we do molecular biology. This lab has done projects like we collaborated on gene transplantation for making minimal synthetic organisms and developed ways to hybridize biological materials with electronic materials to make mixed functions. So a range of functions at this boundary between bits and molecular biology. And so I'm going to introduce Liao, who's going to tell you about work related to how to grow almost anything in class.
Yeah, so we have a class which is based on how to make almost anything, but the goal is to teach synthetic biology abilities and skills from changing bacteria to express certain pigments and to store information in DNA. And this year, because of COVID, we had to teach the class remotely, and we had to use, and we came up with some creative solutions, such as using robots that students can control remotely using code. So students can execute the protocol in digital code and convert it to a biological experiment and eventually express certain bacteria that express certain pigments and even plate them at a very accurate precision, better than you can do with your own hand. So myself, I'm actually working on purely DNA research using DNA as a nanofabrication platform to try to assemble DNA into precise shapes. And my colleagues here also work on CRISPR technologies, trying to optimize CRISPR to have better gene editing, more precise, more accurate, and with less error. And we're also working on machine learning-based solutions to optimize for protein design and have a high throughput screening of different kinds of peptides, small molecules, big proteins, all using a machine learning-based pipeline.
Great. Okay, thank you, Ayal. So this is all rapid prototyping at molecular scale, the smallest size we're working. This is a BL1 space, and then in here is a BL2 space, which looks like a confocal microscope for imaging. Then this is a lab for nanostructure rapid prototyping. So this is an atomic force microscope, a scanning probe microscope that can image down to atom scale. This is a probe station for chips. This is one of our favorite tools. It's a micro CT. So it does X-ray tomography to do 3D reconstruction down to micron resolution. And this is one of these tools that's like a 10 Fab Lab tool to buy one of these. Traditionally, they have to justify themselves industrially. This is an environment where you can really play with it. And then I'm going to introduce Cameron to describe that tool and what she's doing with it.
Yeah, so this is a scanning electron microscope right here. It's basically using a beam of electrons to be able to image materials at much smaller sizes than you would be able to with an optical microscope. What I have in the machine right now is this bumblebee that I found at the beach a couple weeks ago. And over here, you can see this is a live image of what's sitting inside the chamber here. And as we zoom in, this is the eye of the bumblebee. You see some of its fur overlapping like the eyeball right here, and you can see some of the texture. As we zoom in and kind of adjust the contrast and slow down the scanning speed, you can see at 500 microns, this is the texture of the bee's eyeball.
How far in can you go?
You can go down to hundreds of nanometers. Right now, the machine's only focused down to about tens of microns, but with better alignment and kind of messing with the focus of the beam through all of these magnetic coils, you can get down to about 100 nanometer to 10 nanometer resolution.
And then we developed a number of these tools for with vendors. This is an interesting one because it replaced a room-sized machine with more functionality in smaller space. So along with imaging, this does element mapping and it does photography for patterning all of these nanoscale. And so this is part of what Cameron is using in the work to describe yesterday.
Yeah.
Time live in a global pattern. Okay, thank you, Cameron. And then over here is where she does
a little louder.
And then as we come in here, before we get to it, not you yet. So we have a couple print farms. This is one of the print farms. Back here is another favorite tool. It's a pick and place, but it's a very high resolution one, and it can pick parts from trays without being on reels. And it's pretty easy to do quick turn rapid electronics production. This is a superset of Fab electronics tools. So this is things like 20 gigahertz oscilloscopes, very high frequency network analyzers.
Nano ohm meter.
Nano ohm meter. So again, these are tools that cost as much as Fab Labs for the research. As we pass by, here's Rebecca and Sherry. And then a common theme across research here is the idea of digitizing the materials by coding their construction. And a few years back, a student, Kenny Chung, set the world record for the highest modulus ultralight material by linking loops of carbon fiber. And then a student, Ben Jeanette, showed you can robotically assemble them with robots connected to the structure, and you can make mechanical metamaterials to design properties. And so Alfonso came to us from Fab Labs and Airbus. There was a funny moment where Airbus realized an Airbus employee didn't have access to the tools a kid in a Fab Lab did. So they started Fab Labs internally, and then Alfonso is now a student here. So what are you working on?
So as Neil was saying, CBA has a huge heritage on digital materials. Think as a monolithic materials, but the last developments of generating this material kit enables us think about it like a huge microscopic bowl in which we can control the mechanical anisotropes. As a result, we can generate continuum morphing structures rather than thinking about rigid joints and mechanisms. We can generate areas which we control the shape and the deformation of the host. So we are able to generate very large scale soft robotics as this 1.5 meters thing we have here, or other morphing
processes, more between here. Uh, so we can control like structures rather than classical mechanical joints by controlling morphing patterns. Also, this lab has a lot of heritage on studying folding processes. 3D processes are very interesting processes. Here we're filling the gaps that the digital materials enable, because like most of the structures we are studying here are very high shape dependent. We just fill the gaps and also.
Great. So we'll see more of Alfonso on other machines, but if milling machines or 3D printers can't produce structures with these extreme properties, we're finding you can make them by not printing and cutting, but assembling and disassembling. And we'll see more of Alfonso and other machines. So next up is, we have a couple micro machining lasers. So these are laser cutters, but for smaller scale. So Zach, can you turn this on yourself and explain what this is and what you're doing?
Yeah, sure. Hi, I'm Zach. Sorry about the audio. That's my fault. Yeah, so this is a laser micro machining system, and look in here, and this is where the actual workpiece is. So there's a tiny little piece of foil that we're going to machine something into using a bright green laser, actually. So I'll go ahead and open the shutter, and then we'll give it a try. And you can see over here, there's an inline camera that runs in real time and shows you exactly what the laser is cutting at any given time. I'll let this run for just a second. It shouldn't take too long. And over here, it's hard to even see where it's cutting. There's just like a tiny little spark right at the end of that fume extractor where it's actually cutting the piece out. And we do a few passes to control the thermals to make sure that we don't overheat the sample. And then we can pull it out. And that's what we just machined, which is very hard to see. So I did the cooking show trick. And this is what it looks like. So I did a little Fab Lab logo, and it's just right next to the head of a penny. So we can do down to about 10 or 15 micron features with this instrument.
Great, thanks, Zach. So again, this goes down to, actually the limit we've done is maybe 5 micron features. A former student, Prashant, was a master of that. It's a very high resolution machine. And then just a fun detail, the microscope you're looking at is an interesting one. It's a projection microscope that projects 3D images. One of the interesting projects on here Zach is working on is making micro machining diamond to make bearings that turn at 10 million RPM to do molecular structural studies. It's called magic angle stitch. So as we go by, this is a custom machine for electronics assembly, part of a project Zach mentioned yesterday again. And so again, Zach, tell us about this.
Yeah, so these are a pair of robotic arms that we've set up to be able to pick up and place these little computational building blocks. So we have this custom end effector that we've developed that picks up the struts and the nodes and then moves them into place onto a build plate. So we just tell the robot to drop them. Go ahead and drop that, and I'll have you drop that as well. And then those end up being assembled onto this build plate right here to form complex computational structures. And I think we're gonna we're having some audio challenges, so I think we're gonna try a different setting. If everybody can just bear with us for a second, does it seem reasonable? Stop the video for a second, and it will.
So I think we need to see Benno jumping, yeah? You all give us a few minutes of patience here. We're trying to work out the audio issues because it's so cool what they're doing. We really want you to hear it. And as you can see, Ohad and his team are here to work with us later today. That's one of the most wonderful things about working with the team at CBA, right? It's just you know, they keep you thinking and learning, and it's quite the privilege to quite the privilege to work with this team. So anyway, you're just getting a little glimpse of it. So should we do a Fabersize? No, there we go. There's Zach.
Okay, I'm back. Can you hear me?
Okay, cool.
So we're going to carry on.
We are abandoning this piece of technology for now.
Okay, but this was a peek at the future of electronics in labs, where instead of milling circuit boards and soldering components, we'll do micro assembly. In here, we do a lot of machine building. Many of you know Jake, who developed the Clank, and then this is a really interesting machine Zach is developing to do assembly of electronics 2 scales below what he showed you here, with again micron scale parts to go all the way from chip scale to PCB scale to finished electronic scale as a micro assembly machine. And just as we go by, this is Chris, who's using the same sort of flexural parts Alfonso showed you, but he's using to make it things that swim and walk and fly, flexural robots. So continuing along, this you won't be able to see much in here if you aim down there. But what's in here over there is a femtosecond laser. So it makes pulses of light that are just a few cycles long. And then this is a nanometer positioning stage. And then this is filling in the gap between the nanostructure tools and the laser micromachining to do ultra fast micromachining. So in here is a lab where we heat and squish materials and process them. This is a small instron, and then this is our 30-ton instron. And so this is for these high-performance aero structures and record-setting material structures, how we characterize the medical products.
We have the small instrument which we play more about with generating tooling. For example, this one, Dave and I know there is implemented a vision system in which you can have targets pointing towards the structure you are squishing and have a control with the formation and simulation and loads. And then we have the 250 kilograms big instrument.
Yeah, and then one of the interesting projects with this is machines like this, again, cost as much as a Fab Lab. We're working, questions in the chat. Sherry, is there a question? Okay. One of the projects we're doing with a collaboration with the National Institute of, again, it's a question about the audio level is too low. Unfortunately, we can't change the technology midstream. Just look at the pictures.
External microphones, FAB17.
Yeah. External microphones for the future. For now, look at the pictures. A collaboration with NIST and Department of Energy to develop open designs for machines like this, so that to help democratize material science, we're working on developing and validating open versions of these kinds of material science machines. So now we're going to go down this way. So this lab in here doesn't look like much, but it's interesting for 2 reasons. One is this is where the equivalent of the shop we used to teach the How to Make Almost Anything class. That was the seed of really inspiring Fab Labs, and that led to spinning off Fab Academy. And then in the back is the space that's currently empty, where we're getting a really interesting tool. Zach, can you describe that?
Yeah, so we're getting a wire EDM. So we'll show you our big wire EDM later on, that uses like 100 or 150 micron wire to cut metal parts. But back here, that cabinet, the black cabinet, is filled with 10 micron wire. So we're getting a wire EDM that can use 10 micron wire. So your hair is about 100 microns in diameter. So it's a tenth the diameter of a human hair.
And then Zach will be using that to produce what we've been calling glitter, because it's about the size of glitter sparkles. But the glitter will be little tiny electronic components that then gets assembled into three-dimensional electronic structures.
Yep.
Okay, so far we've seen nanostructure tools, microstructure tools, and mesostructure tools. Now we're going to go up to macrostructure tools.
And the Wi-Fi might cut out in the stairwell.
So as we go by, we won't go in, but down the hall there is our data center. That had is now a piece of technological history. The MCU. Before there was a Zoom, we ran our own video head end. And so in collaboration with Cisco, we set up a multi-point control unit, which is roughly about a 5 Fab Lab cost machine. That's the head end for video. And this was one of the first times that was made freely available. And so we used that to run a global video conference that grew into the very early days of Fab Lab, so I could see OHAD and people all around the world. That's now moved to the cloud, but in there we run servers for the Fab projects you see coming from here, and we run a GPU compute cluster for not quite petaflops, but like hundreds of teraflops of computing supporting the research. So then here we had to build a new building. We had many other people for the bigger tools. So this is the workshop I mentioned. This is the tools where each tool here costs roughly as much as a Fab Lab. And one level up is used to develop the parts of what goes into the Fab Lab machines. And these are the kinds of tools that we're working on setting up in super Fab Labs around the world. The first one was in Kerala in India. The second one is in Bhutan. And there's a number being planned. And so to start, here's a little shop bot and a slightly bigger than normal shop bot, a 5 foot by 10 foot shop bot. This is a 5-axis machining center. And to give a sense of a machine like this, all of this is the casting behind it. That's the backbone. We talk about the force loop. That's the backbone for the force loop for the stiffness. And so this is designed not to have 3 + 2 axes, but 5 very closely coupled axes to make parts like these. And then unexpectedly, this is one of our real workforce tools. This is the EDM. So Zach, talk about this.
Yeah, so this is what's called a wire EDM. So it actually does the cutting using this very fine wire. And that wire passes between this electrode, and then you attach your work surface to this base plate, and it cuts it in whatever pattern you program it. And it goes very slowly. It's on the order of a tenth of an inch per minute, give or take. And you get a 30-kilometer spool of wire for around $100. And you can cut all sorts of very interesting things. So these are some dog bone negatives from a load cell that we built. these are just like some scrap bits of aluminum that kind of show you the kind of precision that we can expect from the machine. We can get down to micron precision.
We have time. Explain this.
Oh yeah, so these are the previous generation of electronic digital materials. These are like the excess slugs that come out. So a neat technique for using wire EDM is to actually create. Let me see if I can find one. So you take like 50 sheets of fine sheet stock and you sandwich them all together, and then you can cut bulk pieces out simultaneously. So that little part that Neil was showing is one of the slugs that falls out at the end after one of those cutting operations. But it allows us to like mass produce parts like we were stamping them.
And then the other interesting things are depth of cut is that resolution feature that thick.
Yeah.
And then everything comes out with this gorgeous surface finish from it. And just zoom in on the wire.
It's hard to see. You can see the mark that it's making in my finger, but it's brass wire.
Yeah. So this one we use down to 4 thousandths of an inch wire, and then we're graduating down to the 10 micron. Yeah. So that's the EDM, and then one of the real workhorse tools that's a little hard to describe is the Zund. The Zund is a large format moving bed with interchangeable end effectors. And it lives in niches. These are used to make luxury leather goods, parts of Formula One race cars, high-end advertising displays. And so Zund is, Alfonso is one of the masters of the Zund. We have time.
Yeah, so as Neil was says, the main value we find over the Zund is that it's an incredibly fast and precise gantry system with very much modular end effectors, very easy to implement custom end effectors to, like Sam, a previous alumni from CBA, developed a beautiful process to make wire plotting. And on the other hand, it goes really, really fast.
Let me sneak behind you.
We can go at the order of like for folding processes to crease process about like 1 meter per second fast speed.
What I wanted to mention, so it's a Kevlar belt moving bed laser trim. There's a milling head. We have a 50,000 RPM, 3 kilowatt milling head. What's amusing about it is this whole machine is, everything is so accurate that this is the underlay. That
yeah,
the sacrificial layer is this little bit of rubber.
It's a 2 millimeter.
Because it just mills down and exactly stops there. But what's so much fun about the machine is you can make heads that punch and slice and roll and shear and do these all sorts of operations.
And we've been using, for example, as we were showing previously over the product response, to make concrete elements. And one of the end effectors, because it's a 2.5 million process, but you can control the seed axis as well of your tool, meaning that you can crease with curves, arbitrary curves, and you can generate like folding elements all the time. Or here, what the material I have here is a highlight materials that I use to make the folding structures. The Zoom has also like a visual registration, and that's allow us to make 2 phases filling processes, which is very convenient when you want to fold as you want to carve pieces in different part of the phase of the material.
We're okay for time. Can you run anything?
We're gonna do it live. We're gonna cut a job.
Wasn't this?
We have time, and this machine is like amazing to watch.
for people that are used to machining, once you get a router of 50K RPMs, you can never go back to a 20K RPM.
While we're here, each of these are cartridges that have different degrees of freedom, like rolling or tilting.
We have different ways for everything. But the soon can, like, the main use of Neil was saying was to cut patterns of any source of material. So they have a really nice technology. They own blades, so they're very interesting. But we have different modules that can be implemented in the gantry. This is a punching module.
And then, sorry, before we go, first, these are the cartridges. So you go from the blades to these holders to these cartridges to these end effectors, and then that's where you get all these different degrees of freedom, like punching and shearing and rolling and slicing. Good. So then this is our water jet machine ballistically with the garnet abrasive, and so you can cut.
This is what I did this morning.
One of our favorite things is on this is this picture, and this picture is quite literal. That it'll do that if you happen to be there. Do we have time? We're okay for time.
Yeah, sure. We can cut it up. So we're going to cut a quick job. It'll take about 3.5 minutes. But the first thing I do is I fill the tank up with water. So we use that water just to shield us from the kind of noise and debris. And then there's a high pressure pump. So there's a 50,000 PSI pump that we turn on. Let me let it rip. So you can follow where the cutter is going as it's cutting out the Fab Lab logo. Then it's going to move on to the second lobe. This is the garnet abrasive that it uses. So it's like a 40 grit, very sharp abrasive stone that you just buy by the pallet full. I'm sorry, 80 grit. So that was the second lobe. And you can see these two axes right here. This is actually a 5-axis machine. So you have 2 additional axes that are used to adjust the tilt of the jet, and that compensates for the kerf angle that you get from water jet cutting. So it gives you a very, very parallel cut, as you'll see. All right, and now we'll just cut the outline. It is a water jet cutter, so occasionally you get sprayed with water. right, so then we'll just drop the water down in the tank.
So the only disappointing thing about water jet cutters is watching them. They just burble.
Yeah.
And that's so we don't get splashed. Other than that, it's real workhorse. There are cheaper ones emerging, $10,000 water jet cutters. The main compromise they make is it's much lower pressure, which means you can do this, but you end up needing more garnet. One like this that has a fire engine pump backing it is a much higher exit velocity.
Yeah. Having said that, unfortunately, this was about $10 with garnet. So you spend about as much on garnet as you do on aluminum.
And then as much on somebody to shovel out the garnet.
Right. No, those people are free.
No, they're not.
No, it's great.
The poster.
Oh yeah, I'm on my selfie cam, so it's going to be backwards. Let me see if I can fix that. I'm not very good with Zoom.
So just as we go along, these are, yes, this is NC lathe, a little car scientific NC lathe, some roller tools. This is a little tabletop injection molder for quick turn, short run injection molding. So as we go on, these are all the larger manufacturing tools. And broadly, you can think about these as Fab Lab can make almost anything, but you need the supply chain for the parts that go into it. These are the tools one level up that let you make those parts. The nano tools are what you go into the things that make the parts. These let you make the parts, and then the Fab Lab lets you make something. So this maybe humble, maybe messy space is one great resource. This is a high bay work area, and it goes right out to a loading dock. And so this was a long needed just space to do big projects. So we started with bio-controlled spaces and clean nanoscience space. This now is messy space. This is where we do welding, we do foundry work, kilns for cooking things, and then ventilated hoods. And this is a space for things like laying up composites, doing molding and casting. So this is hot, messy, dangerous stuff. Casting in both low temperature and high temperature alloys, polymers, composite layup, all those sort of processes we do in here. And then in here are precision tools. So we collaborate very closely with Protec, PCC, Epilogue on laser cutters. This is a tool spun off by former students. This is a Fab Light. So this is a 3 kilowatt fiber laser. A fiber laser is about 1 micron. It does nice metal cutting. And so this is for high res. It's like a laser cutter, but in metal at very high resolution. Then we'll end with 3D printers, but let's first go over to. This is Alex, and this is Alex's baby. Hello. And you can ask Alex anything about anything to do with any fiber process.
Yes. So this is a Knitterate machine. It's a 3D knitting machine. It's digitally controlled. And this is the worst one that we have in the world, but it's with Neil because it's one of our first prototypes. And so we donated it. Now we're kind of upgrading it to our normal standard, and it doesn't work yet, but you can knit stuff with it, including cool things like this. This is clip art. If anyone remembers clip art,
I remember that clip art.
it's a great clip art, and it can also do shaping and things. So you can have things come off of this with a three-dimensional form to them. Even certain garments that are more or less ready.
So Alex, let's fill in. Commercially, these are $100,000 machines. How much will this cost, and how did you do that?
So it costs about $15,000, and the commercial one started around, I'd say, 60. They're cheaper in China, the ones that are made for the Chinese market, but the ones you can buy in the Western world are that much. And the way that we made it cheaper was we stripped it down and we took out all the industrial controls and we put in like the kind of microprocessor that you learned to program in Fab Academy. And we removed a lot of really fancy stuff and kind of just simplified it. We're also making our own software.
So talk about like both specifications and applications. I think we're heading towards this becoming a common thing in any Fab Lab. Talk about specs and once you get one, what you can do with it.
Yeah, totally. So you can knit all kinds of things. Obviously, clothing is a really exciting one. You can do medical applications. You can do preforms for casting concrete. There are people who want to do things with carbon fiber here, which I'm worried about because it's going to hurt the machine. This is like a medium gauge machine. So if you, maybe we can zoom in here a little bit. These are the little needles, and they come out. They're joined by these guys from the back, and they actually do the knitting. So this is like a medium gauge, but there are machines that do finer, and maybe we'll do a finer one eventually.
And then what's in your future after knitting?
After knitting, I'm also interested in weaving and more recently work knitting, which is these are also cool processes.
Coming attractions.
Coming attractions.
Okay, thank you, Alex. So now, Jack. Yeah, so this is Jack.
Hello, my name is Jack.
And he's going to show you fun with FDM.
Yes, so FDM printing, it's one of the most common forms of 3D printing. 3D printed, this is probably the first. Okay.
That's why we're in forward mode.
Okay, yeah. So this is a printer that can print, it has two separate nozzles. And so what this allows you to do is print with multiple materials. Well, because there's two separate nozzles, you can print with two very different materials as opposed to just two different colors. And so this is a project I helped out with, but was led by June Gong, Olivia Siu, and Cedric Kane, and also Professor Stephanie Mueller on these deformable metamaterial sensors. So you see here, this is a conductive 3D printing material, and then these are flexible hinges. So you can add, just by adding a wire to it, now have a capacitive sensor that can do deformation sensing. And so this is just a primitive, but we also look at creating higher level things like 3D printing a joystick where you can move it and then the distance from the walls change. A music controller. So this is nice because now you can start programming deformable objects and prototyping them much quicker than if you had to make each one by hand, so you can refine the ergonomics.
And one of my favorites is an accelerometer.
Yes, so that's this guy. So as you shake it, the distance from this cell to this cell changes and this cell to this cell changes. So you can get kind of start 3D printing something that previously you would use a chip for. And this is just interesting because now we can embed electronic sensing and functionality directly into the material and into the form that we're printing.
So that was work led by Cedric, who's in the jungle in France.
Yes.
And then what's all of this stuff?
All of this stuff is a project that I started in how to make almost anything on 3D printing fabric. So what you see here, or maybe I'll start with a more simple one, is just a swatch of a thin translucent material that's made out of PLA, which is the most common 3D printing material. And so previously, like this is a one wall thick material printed with an extrusion multiplier of 1. And what I found in this research is that by lowering the extrusion multiplier, like starving the printer almost, I can make much more flexible materials that can bend and stretch. And so there's a few different interesting variations you can do. This one's a lace with like varying kind of opacity. This one actually just that's still warm, but it prints it upright. And yeah, this is nice. You can see my face through it. And it's very flexible, thin laces.
You did that really quick. Just go back and explain the orientation.
Yeah, so it prints upright. And so there's a lot of really interesting work in 3D printing fabric But most of it involves printing flat on the print bed, and so that limits you to flat geometries. This allows you to do, because you can print upright and because you do overhangs, things like this dress, which I can very quickly remove. So now, like, costume designers can actually print out pre-forms of their design before they spend hours making it. Or if you want to see what a dress looks like physically before you buy it, you could very quickly print out a miniature version of it. This is a lampshade that has like the solid components for support, and then also the flexible and opaque material for nice light properties. This next one, I think Neil really like, is a roll of fabric. This is the result of 12 hours of printing. And if I have a spatula, I'm going to rush this so it won't be perfect. But essentially what I did is I printed an upright roll of the fabric at the maximum print speed of the printer. And so what you hit the tip of the from the inside.
Okay, what I wanted to do was the reveal. So, so if you start holding,
it's a little gentle because it's just so thin. But yeah, this is almost a 70-meter roll of textile. I've gotten it before to all be in one beautiful print. This one I kind of rushed the printer a little bit.
So yeah, so okay, yeah, we're rushing it a little bit, but you see this sheet is this continuous strip of fabric. And what's the longest one you made?
So that was 70 meters rolled out across the baseball field.
And how long did the print take?
It took a month. This one is a lot faster. Now this is a 2-day print to get the same thing, just making some refinements in the print speed and different geometries. But yeah, it was printed actually on that printer on the top of the shelf. So it's a pretty robust.
And again, all of this started as sort of a glitch in a 1-week how to make project. And once again, what Jack's doing is so interesting is he's making the extruder burp. He's under extruding, and so it periodically is burping, and it's turning out into this whole remarkable expressive space. Okay, so now let's introduce, who are you all?
Jesse Martinberg with Stratasys. Matt Campbell, AET Labs. And Johan from Catalogue and Insta.
And so this is a C260. And back there is the J55. And these are, again, machines that cost as much roughly as a Fab Lab. But what's interesting about them is this is output from the J55. So all of these, there's no post-processing. It just comes out of the printer like that. And one of my favorite ones is with our laser scanner. Tom, shop technician, isn't here right now, but he laser scanned his shoe and then printed his shoe from the laser scan. And this is a nice example of the multi-material printing that it can do. So talk a bit about these two machines and the materials.
Yeah, absolutely. So what we got here is it's the J55. This is actually taking 5 materials and actually mixing them together. We can actually do clear. Now we've got an upgrade where you can do rubber and actually contact, so biomedical. But the revolutionary part about that, you hear that? It actually, this is a 3D printer doing a turntable style. The head is stationary. It's just going back and forth to actually drop the droplets and cure with the UV light. So it's a resin-based material curing with the UV light, mixing those colors. 18.5 micron layers allows us to do anything from the medical field to the chemistry field, doing microfluidics, printing of color. So we're bringing this to not only the engineers, but also the designers. It has that capability, that workflow, and the ease to get full color parts. It is definitely a game-changing piece because we see it as a true, Swiss Army knife rather than a scalpel.
So then, just some of the other things we do with it. There's soluble support, so we use it to make microfluidics with complex internal cavities. We use it for data visualization to make objects that have data rendered on them. Use it to make anisotropic properties. I don't know if this will come across, but objects that look different from different directions because of the microstructure. And again, just gorgeous visualization, just objects that come out looking like that. Oha, do you want to say anything about GrabCAD and the software?
So GrabCAD community is part of our community, and we are using GrabCAD to print to slice and use that. What is nice that you can have native CAD as part of that. And we recently introduced the research package for PolyJet, which allows you to print air, allows you to print liquid, and control the print on the voxel level. Now you can have pose and presume, so you can put your electronics PCB boards inside. And I'm looking.
So this is an artist conception, but without a real PCB.
So now you can do that.
The timing on that is very good. Yeah.
So we will look forward for you to use that and Thingiverse as well.
So that's nano, meso, micro, macro. We have just a couple minutes left. If there's any, if we can do a little questions if there are any now, but let's do them back in the lab. So we're going to make our way back down to the lab and wrap up. I can talk as I walk if there's questions, but we're going to end up sharing. And we're back.
Wonderful, wonderful.
So any questions?
Sure, can you turn your
Adrian, you wanted to?
So yeah, any questions? You wanted to see the pick and place? Talk about the pick and place? Yeah. There we go.
Files of the shape material. On YouTube, it says super interesting examples of shape material. Have you shared the files?
Shape materials.
Yeah. They're asking about Jack's work, and so the.
Sorry.
Come back here.
Thank you.
Let's see. I think a question from YouTube was about that beautiful work Jack is doing. So to learn more about that, that's Jack Foreman, and his project is called Defextile. DEFEXTILE. If you search for that, he has a lot of documentation about the project.
Any other questions from the group?
How do you keep safety in the lab?
How do you keep safety in the lab? Okay, let's go back to Zach. So for safety in the lab, each of the lab has one of these screens. These screens are connected to, of course, GitLab. There's GitLab projects for each space that includes the training and the dangers, and there's projects for each machine that includes the training. We make a lot of use of Raspberry Pis using Motion Eye that are part of then, let's see, we're looking for where the nearest one is, that you give up privacy for safety in these controlled spaces. We use those to track what's happening where, what's good, what's bad. And so somebody goes through our labs training. MIT has training for things like chemicals or X-rays or lasers. And then there's just a lot of process in managing with this infrastructure to track the space. And all of that lets us run a space 24 hours a day with non-traditional users and keep it safe. It's a good question. A lot of our work goes into that.
Oh. How can people study with you?
You could almost answer.
Get in touch. If there's interesting things you see, get in touch with people doing the research and talk to them about it.
So, yeah, I'll say two or three things. So first thing I'll say is 99 out of 100 students tell me they find this work fascinating and would like to study here. And then 1 out of 100, like Zach or Alfonso, tell me what we're doing wrong. And they don't tell me that they find it fascinating. They tell me how they'll change us. And so that's one observation. But a second observation is, MIT is only a few thousand people, and this building is a few hundred people. And at any one time, CBA labs, there's hundreds of people using these facilities and tens of people in the frontier research projects, and the world's much bigger than that. And so part of what we're trying to do in Fab Academy becoming Academeni is not rate limited by the few people we can fit in here, but reproduce and collaborate on this kind of learning on a global scale. So the more interesting question, much as I'm interested in who's the next Cameron or Zach or Alfonso, it's how do we scale this process globally? And that's what we're trying to do through the growth of Academy, so that you don't have to pick either or. And maybe that's a nice thought to aim on, that the vision for the future is, in here technologically, is how Fab Labs can make from PCBs all the way to eventually integrated circuits in the research roadmap, and certainly make their own machines. But more also intellectually, how anybody can learn almost anything as the meta project coming from here. So maybe that's a nice thought to end on. Thank you all. Okay, and here's what I'd like to do.
So that was an inspiring and whirlwind tour de force. As the physicist John Wheeler might say, CBA is where we are turning bits into its and its into bits, and exploring some of the next frontiers in digital fabrication. So again, just let me say one more time how terrific it is to work here with the CBA team at MIT. The students and faculty, they really do. They always inspire, and they keep us all learning and thinking. So thank you, Neil. Thank you, Zach, Eyal, Alfonso, Cameron, Jack, Alex, all of you from CBA, as well as, thanks, Neil, as well as Jesse and Ohad from Stratasys, and a special shout out to Kara Pendlebury for helping us get set up here at MIT at 6 a.m. Thank you, Kara. Thank you, CBA and team. And I think now we're going to take a quick break for like about 10 minutes, and we'll come back with more research from around the world. Thanks so much. Welcome back to Fab TV Day. We're going to take a turn now from the MIT Research Lab to the Global Research Labs. Peter Troxler, back in 2008, I guess it was, Peter, in New Zealand, during Fab 8, he started to pull together the Fab community to really document the research that was happening around the network. And then a few years later, Cindy Kotala joined him, and together they've provided the community with a peer-reviewed platform and process for research papers coming out of the network. This is an incredibly valuable service to Fab Labs. Thank you, Peter. Thank you, Cindy. And in this next session, they're going to discuss with the... Anyway, we'll be back. Over to you, Peter. Bye.
Not sure what's going on there at MIT, but it appears to be an emergency, and we're here for research emergencies. My name is Peter Troxler. I'm based in Rotterdam, the Netherlands, and I've got the pleasure to welcome you to the research paper session here on Fab TV. I've been with Fab Lab since 2007, and in this hour we're going to talk about some of the interesting research that has been carried out around the globe on and with Fab Labs, with panelists from Canada, the US, from Brazil, Chile and Peru, from the United Kingdom and Germany, and from Turkey. And as Sherry said, we have come a long way with the Fab Lab research papers since our first session at Fab 8 in Wellington in 2012. I was then joining remotely through the Polycom, which we've just seen the relics of in Neil's show, glued to my laptop, emulated user end, and trying to discuss with people in Wellington. It was bloody early in the morning, and I had to present on a high-level IT project on that day in Switzerland. So we've come a long way. We're here at Fab TV. I'm presenting this session with my long-term partner in crime in terms of research, Cindy Kotala. And Cindy has the overview over this hour. Cindy, over to you.
Hello, everyone. Thank you, Peter. Yes, I'm Cindy Kotala, and I am based in Helsinki, Finland. I'm really glad to also join Peter for reviewing these research papers. We've been having the research paper sessions on Monday and Tuesday, and we will have another session tomorrow. So we have had basically 3 clusters of themes, and we want to bring a little bit of a selection, a taste of that for you, for the general audience today. It's going to be quite fast-paced, so bear with us. Get your running shoes on. We will have 3 mini panels, but then in between each mini panel, we're going to award Best Paper Awards. So let's just jump right into it. Peter is going to have the first panel on learning.
Thank you, Cindy. And with me, I need to read out the names to get the tech running in a good way. With me are today Melvin, Thomas, Evelina, and Naldi. I'm going to briefly introduce the 4 panelists and the results of their studies. And then I have a few questions which I'm going to pose to the panel. So let me start with welcoming Melvin Laparada from the National Urban Research Center in Cleveland, Ohio. He wrote a paper on Constructionism 3.0 together with Sherry Lassiter of Fab Foundation, obviously. They retraced the development of constructionism over the past 40, 50 years, starting with Logo and the famous turtle, and then linked the development of the Fab Lab pedagogy values, which are, again, themselves related to critical pedagogy developed by Paulo Freire. And here are those 5 values. Learning is personal, engaging, and motivating. Learning is meaningful and relevant. Learning is interdisciplinary, just like the world. Learning is not singularly focused on curricular content or technical knowledge, and learning should be assessed on the final product, obviously, but also on the process that led to it. Welcome, Melvin. Glad to have you with me. Next up is Thomas Poulin de l'Université de Montréal, and together with colleagues Marine Martel and Christine Dufour, he wrote a paper on littératie numérique, culture maker et bibliothèque, which is digital literacy, maker culture, and libraries. And they discuss three crucial ingredients or mechanisms at play in library makerspaces. First, knowledge creation by librarians and members of staff. And this is quite an ongoing process because professional librarians are not professional makers, so they need to learn making as they go along. Like in the second process, knowledge creation by the public, which links to the constructivist and constructionist ideas that Melvin was talking about in his paper. And they use in their text the word apprentissage, which translates as learning, but also translates as apprenticeship. And I quite like this double notion of the word apprentissage. And this comes back in the third mechanism at play in learning in libraries, which they call communauté d'apprentissage, learning or knowledge creating communities. Bonjour Thomas.
Bonjour, merci beaucoup.
Next, I've got Evelina Dineva, working at the Jacobs Universität in Bremen in Germany, and together with Christian Faubel and Katja von Roth, she reports from a classroom project which is called I Can Robot, which they carried out in an out-of-school setting at a community center in the Hamburg neighborhood Heimfeld. These are the learning activities in a global urban context, another layer of the Fab City full stack. And the activities they carried out with kids aged between 6 and 14 years consisted really of two things. One was building a robot, and for the nerds, to be precise, this robot was a Breitenberg vehicle. And yes, the connoisseurs know that the Breitenberg vehicle is a not-so-distant cousin to Pepper's turtle. And the second activity they carried out with the kids is kids acting as robots. And that's really Evelyn's specialty, learning as an embodied cognitive process. Welcome, Evelina. Last, I've got Naldi Carrion from Fab Lab Esan in Peru. And together with Cesar Jonathan Norna, Claudia Lovera, and Victor Pimentel, the three from Fab Lab Universiteit Esan, they developed a tool for learning, particularly a tool for chemistry learning for visually impaired students. Collaboratively, they developed, together with chemistry teachers at high school level, university level, both normal vision and BLV, which stands for blind or low vision, a tool for blind or visually impaired students to learn chemistry, to learn about chemical elements. So they printed little balls with 3D printers that represent the chemical elements, and the balls carry on their surface tactile information on these elements, the information that we normally visually abled people would read from the periodical table of elements, which we might remember from our school times. So they tested various types of 3D printers, and you know, in the printing process, these printers create different tactile features just by the way the printing process works. And those features, unintended features, make the balls easier or harder to read, quote unquote. Welcome, Naldi.
Thank you, Peter.
Welcome all. Great panel on the topic of learning in the Fab context. And we've got a variety of perspectives. We've got, as I just laid out, fabrication for learning in the case of Naldi. We have fabrication as learning in the case of Evelina. And we have fabrication in learning in the case of Melvin and Thomas. We're not going to discuss all the findings in the details. If we find time, we will put the link to all the papers into the YouTube chat. What I'd like to discuss now is what these studies have in common. And one thing I noticed when I look at those 4 studies, certainly over the last decade or so, fabrication has achieved a position in learning and education. It's a fact. The future is here. But, as in the quote attributed to William Gibson, it's just not widely distributed. So my question to the panelists, and maybe Melvin, you would want to kick off with your thoughts on that. What can we do to distribute this future more evenly?
Yeah, one of the things that we talked about, and when we did this paper, we were thinking about the fact that high quality constructionist environments for all children, regardless of their zip code, learning styles, and ethnic backgrounds has been elusive, right? So there is this divide in digital fabrication. So our attempt was to look at the history and try to understand what we can learn from this history as we begin to implement digital fabrication in other spaces. And so I think that what we can do is that we can think about all the lessons learned through this history as we begin to adopt digital fabrications in other spaces.
Thank you. Thomas, what would you do?
I think public library and libraries in general are an excellent space to democratize and make sure that this kind of learning, this kind of technologies, this kind of, like Melvin said, environment that are taught in a way to foster learning. It's a public good, and it's really in line with the mission of the library to create knowledge in a way that benefits society. And it's really a broader way we need to view our job and reinvent it. And in the paper, I talk about frontier work, and it's a really important concept because it's a job we invent on the go, and by its nature will never be fixed in time because we'll always have to keep learning. And the same need exists in the population. So we need to give the infrastructure, the spaces, not only to learn in school, but to have the infrastructure for lifelong learning and be proficient in the technologies that structure the world.
Thank you, Thomas. Evelina.
I'd like to give two answers to that. So one is really reaching out to community centers, reaching out to the professionals who have contact to communities, who know how to reach out to the communities, who are professional in bringing whatever it is, activity, knowledge, workshops to the people where they live in their daily lives, so distribute it like on the broad scale. And the other one is, it goes back maybe to Boyer, the scholarship of teaching and learning. So basically the same way we approach research, to do the same way to approach education, to really think what are the mediating processes, do what we do right now, exchange about these mediating processes, why a lot of great teaching happens in Fab Labs, but what exactly and how can we exchange and peer review that? That would be the second answer to that question. Thank you.
Thank you. Naldi.
Well, I think that what we're trying to do is to identify the barriers that we have, because locally, within regions, we know that there is a gap, right? But we need to understand which are our local barriers. So when we try to do a project, it helps us to understand which are those things that we need to change. That could be, fostered by government entities, or could be fostered by any private sector or any organization that could help. But we need to work in a local level.
Thank you. That brings me to my second and probably last question in this short panel. I need to give some background there, and Evelina, you just referred to educational scholarship, and I'd like to refer to one particular educational scholar, a Dutch-born professor of educational theorist, now working at the University of Edinburgh in Scotland and at Maynooth University in Ireland, Geert Bista. And he warns about the learnification of education, which is a theme that resonates from Freire, of course. And he postulates that there are three dimensions to education, and we sort of heard of that in the Fab Lab pedagogy values. There are 3 dimensions. One is qualification, one is socialization, and the third is subjectification. So qualification is, you know, what we normally call learning, what we call the curricular content or the technical knowledge. Socialization is the presentation and representation of cultures, traditions and practices, which has become a very relevant topic in the discussions and questions about diversity, about inclusion, and what recently a book that just came out the other day at MIT called the Techno-Vernacular Creativity. But what I really would like to home in on is subjectification. Subjectification is becoming of a self. So this is not the same as like being an individual or developing an identity. It's more about being and becoming a subject, a grown-up, a development from the infantile pursuit of one's own desires, which we might see in the technology of a market of one, to a development of being at home in the world and being confronted with responsibility, and also the informed but free choice to take that responsibility or walk away from it. So in our theory, my question is as follows. We have shown that fabrication is a contribution to qualification. In your example, Naldi, in your example, Evelina, learning about robots or printing, learning tools. We've also shown that fabrication is a contribution to socialization, a part of Evelina's work, certainly what Thomas is doing in the libraries. Now, the difficult question really is, how can fabrication add to the dimension of subjectification of, how can it contribute to becoming a self, becoming a grown-up, becoming at home in the world? Naldi, you want to try?
Yeah. Well, I think technology itself helps us to, take responsibility for what we do, what we share with the people. So I think digital fabrication make us also responsible, to create things that could help people to include and become, it's like changing the term of citizenship, right? Because we're trying to transform the way not only we are responsible as what we share locally, but also as we share globally, because we are contributing to the world. Now it's a different approach to possess things, to create things, and to share things. I think that is the main contribution of digital fabrication.
Thank you. Evelina, what would be your take on this question?
My take would be, I think, empowerment. That's a big theme in our research. So we take fabrication, so letting the children or participants in the workshop really do things with their hands or be robots, make costumes, like this whole experience of producing, fabricating something is basically the first step. But what we also work with is share this with your immediate neighbors, such that you're really aware of what you achieved during your fabrication process. Give immediate feedback from your peers that this achievement is really valuable, and then also share in a broader audience. So we finish with a presentation in front of invited guests, which is like a welcoming environment, but the kids can really be proud of the work they do. So they really become very conscious of the work they do and of what this work does to others. So this communication is really a big part of that as well. So that's my take.
And really let them make this very experience. Thank you, Evelina. Thomas.
Yeah, I'll go in the same direction. I mean, giving back control on what you learn is basically having control on what kind of person who you become, because you're choosing what to learn to foster which interest. So by giving those kind of learning space in the maker space and libraries and schools, that's the way we can help people become who they want to become and be in control of the tool they use, the kind of content they consume, the kind of object they make. And in terms of skill, it's a subject that come back a lot in professional practice and discussion we have. How can we use, how can we make sure that the skill, the learning that occur in lab is recognized either in a professional setting for employers or in school? And how do we create a space for the people who learn differently, who have different need or have different contexts, and they have a right to learn too? So the kind of space we offer, I think, is the key infrastructure for the society we want to build with knowledge.
Thank you, Thomas. And Melvin, to you, the last statement in this round.
Yes, this is where it's personal for me, right? And this is where we can go back to the notion of we have a unique window of opportunity here to reimagine Fab learning with both fidelity and equity. And I work in urban spaces, in spaces where there are no Fab labs, there's no Fab equipment, there are no technical assistance around Fab learning. And so after the pandemic that has had disastrous effect on Black, Latino, and Indigenous communities, plus the tension around the Black Lives Matters movement, this is a moment where we can begin to think about how to bring the digital fabrication tools into these communities. And one of the approaches that I am really looking at is the notion of leapfrogging, right? The same way that we took, they went from smartphones without going through landlines. I'm trying to find ways that we can bring all the constructionism thinking, digital fabrication tools to these urban spaces and begin to think that process. And for me, it's just a wonderful opportunity working with Scopes and working through the Fab Lab to bring all the expertise of MIT and all that knowledge back to these urban centers and back to these spaces where that knowledge wouldn't be. And then in that way, we can create spaces where the cognitive, non-cognitive, and Fab specific skills can be nurtured in an environment, right? So to get to our theme of to provide access to the tools, knowledge, and financial means to educate, innovate, so that anyone can make almost anything. And it's a unique opportunity for me in that regard. That's where I'm trying to put my energy into those spaces and begin to think about how we begin to do that.
Thank you, Melvin, for your very personal remarks there. Thank you to all my panelists. Thank you, Naldi, Evelina, Thomas, Melvin. You were a great panel. Thank you very much. And apart from discussing research panels, research papers, we have also the Best Paper Awards in this session. And I'll hand over to Cindy to kick off with that.
Excellent. Thank you, Peter. So I'm very pleased to announce the second runner-up in the Best Paper Awards. Hey, that's my Muppet yell. Second runner-up, we're very pleased to have one of the paper authors with us, Antonia Valencia Talhook, who the paper is called Sustainable Design, a Tool for the Valorization of Natural Heritage Value Areas in the Southernmost Town in Austral Patagonia, Chile, with the authors Antonia, Roy McKenzie, Miguel Troncoso, and Tomas Espinosa from Fab Lab Austral. So congratulations, Antonia. I am going to share my screen now, and she's going to tell us a little bit more about the paper. I think we're okay now with full screen, I hope.
I think that's full screen. Okay, thank you so much. Good afternoon, and thanks you for the recognition for our work. My name is Antonia Valencia, coordinator of Fab Lab Austral, located in Puerto Williams, Chile, the southernmost Fab Lab in the world. First of all, Puerto Williams is located in the latitude 54-55 south, in the southernmost city of the world. It's the capital of Cabo de Hornos, commune of the Chilean Antarctic province, and it's inhabited by more than 7,000 years by the present Yagan community, and now has over 2,100 inhabitants till this year. In 2005, the Cape Horn was declared by the World Biosphere UNESCO. It's characterized by hosting one of the most pristine subantarctic template forests that have been identified as one of the most pristine ecoregions in the world. And with that uniqueness of the biodiversity in the extreme south of South America, this is where it all began. The supply chain is very far. It's very hard to have supplies in this territory. So this is why, with all this said, with the multidisciplinary team of investigators from this area of biology, design and education, we took the challenge to embark in this transdisciplinary work with the local networks in Puerto Williams, including the University of Magallanes, Universidad Católica, and Fab Lab Austral, with specialists in the flora and fauna. We realized that we had to do something, and this is why are in the research in the digital manufacturing and sustainable design, the biology and the cultivation of the native mosses, and also education of the topic of the collaboration within the community. So with all that said, we did this investigation of sustainable design, a tool for the valorization of natural heritage, the valued areas of the southernmost town in the Austral Patagonia, Chile. And if you could go now to the second slide.
That would be really good if I could.
I think now I see it. Thank you. And with all this premise, we of generating a contribution in the field of a local material and the environment sustainability, the research focused on how to search for a future preparation of the urban structure and installation. So it was an informative and sustainable nature. Oh, sorry, I think it was, okay. With all this cycle, we did a full experimental methodology consisted of landing local conditions in the native Mayaning moss. So if you see here, there's different types of natural mosses within this territory. And with all this material shape and the invoice of the inclusion and the maintenance of the urban spaces. So in this way, we worked through the digital fabrication, a functional aesthetic form made with local soils and local mosses, and the investigation of the distributed design fabrication, biomaterials, and native moss cultivation. So we focused primarily on the social innovation and how the Fab Labs work to articulate with social actors, and this multidisciplinary work communities, the local universities, and open to the community impact of the green areas within the public use. So finally, the objective is to generate an environmental education and training in this digital manufacturing, in addition to the results obtained from this research focused on the further impacts and the proposals of the intervention in the public green areas in this southernmost city of the world. So as you can see, these are some initial approximations of the research, and the final areas of this renders can be seen for the intervention of the public areas of Puerto Williams in the future of the research. So thank you very much for this nomination, and we look forward to continue this research in the future. Thank you so much.
Thank you, Antonia. Fantastic paper. I'm going to stop sharing my screen now. Excellent. Very good. And now we would like to move on to the next panel, which the theme is materiality. And Antonia has presented such a fantastic example of other papers in this theme. So we are going to have other guests now joining us. We will have Nina Hormazabel, Pamela Sofia Zoria, Juliana Barros, and Jacqueline Vale. Let me then tell you a little bit about some of these papers, and they will all be presented tomorrow in tomorrow's research papers session. It's interesting also that all of the 5 materiality and environmentalism papers come from South America. I think that's an interesting lesson for the rest of us and the rest of the world, as well as to what Fab Labs are doing with regard to really investigating environmental and socio-environmental sustainability. So in these papers, I could summarize it that digital fabrication and prototyping in Fab Labs played important roles in local and appropriate production, and very often oriented to environmental sustainability. So whether the topic is creating traditional carpentry joints for wooden houses in Chile, or innovating mycelium-based bioproducts in Brazil through biomimicry design methods, or experimenting with urban space regeneration using rammed earth urban furniture in Brazil, or exploring fabric structures for clothing patterns that elongate and deform in the spirit of sustainable and slow fashion in Peru. Or finally, as we have just seen, using the Fab Lab to explore locally appropriate and ecosystem literate methods and forms for dwellings in Chile. So I would like to welcome the panelists to join me, please. And the papers represented are titles Design and Robot-Assisted Carpentry Joints for Wooden Houses, Digital Biofabrication, Sound Architecture and Mycelium, Garments Elongation Improvement, the use of digital fabrication technology to develop rotational and re-entering auxetic designs on fabrics. And as we saw, sustainable design, a tool for the valorization of natural heritage value areas. So please, Nina, Pamela, Juliana, Jacqueline, please say hello to us.
Hi, everyone.
Hello, everybody.
Hello.
Thank you, Cindy. Hi.
Really nice to see you all. I include Antonia also in this panel, but I'm not sure if her face will be visible. But I would just like to ask you, and you can refer then, think of how you conducted the research that you were doing. You were all working with, I mean, the whole point also is to work with materials that are non-standard. And when we work with digital fabrication, not only that, but when we work with external stakeholders, that can really present different kinds of challenges, not only technical challenges, but maybe aesthetic, communication, acceptance, legitimacy, all kinds of things. So could you tell us about the main challenge that working with non-standard materials or maybe non-standard processes or both presented for you? So maybe Nina, could you start?
Okay, yeah. For us, the main challenge is the reduced technologies within Chile in regard to digital fabrication. So that put us a lot of problems. As a matter of fact, we did all the digital fabrication in the southern part of Chile, and the house was built in the central part of Chile. So, and this was also an experimental and experiential learning process for architecture students. So it was a one-to-one scale digital fabrication for a solar social home for reconstruction in the city of Valparaiso. So we did all the prefabrication in the southern part of Chile. I'm talking about 800 kilometers south. And then we had to build it in Valparaiso that has another topography, and the majority of the problems we found it there when we have to assembly the home because of the different topographies and all that. So it ended up being more expensive. And, but it was really precise in other issues. And I would say that the most important thing is that we were able to prove that it's faster, but it's not cheapest because of technology, not because it's not cheap. And because of the economic gaps that is not currently favorable. And especially for Chile, that most of it is done in rainforest concrete, that made us face all these problems. On the other hand, it is new, and Chile is trying to do the timber construction and mid-high timber structures done with prefabrication. So we are on the right pace, but it will take time.
Yes, yeah, I understand. Thank you. Pamela, I would like to hear your answer to that question.
I think that the first thing we found really difficult was to find the correct materials to use, because it had to be reachable for every kind of people that wanted to make garments. So when we were trying to find these correct combinations of materials, we found out that there are several materials in the stores right now that can be used for this experiment. We had to do combinations with another ones, but yeah, I think that was the most difficult part, because this project wants to make everyone able to make this their own garments, also being usable for everyone. So yeah, we had to make this really reachable. And the other thing was the labs, because here in Peru, investigation it's in development, so we don't have like as many labs as we want to experiment, and also because of pandemic. So we were trying to find the correct textile labs. So luckily we had some contacts because of university, so we were able to enter to Fab Lab Barcelona and also to the University of Lima to make all these experiments. But yes, we want to also, in another investigation, to try to make this kind of techniques virtual, maybe, because it's now, as we see, making all with the material, like you having it in your hand, it's quite difficult if we are in this kind of context. So yeah, those were the two ones.
Okay, thank you. And yeah, of course, in your case now, it's a little bit the opposite, that you were using very novel techniques for fabrics and pattern making and so on, that is definitely not standard.
Yes, and
we're trying to find materials that other Fab Labs would be able to use, so people would be able to do their own garments. It's really, really super interesting research.
Thank you.
How about Ju? Could you tell us?
I think we are using natural materials. So I think it's important to find the species and the feedstock which work together to produce.
Tell us about the materials that you're using.
We are using Mycelium, right?
Yeah.
So we are trying to find material, composite material, to produce acoustic material with a great performance to use in architecture and engineering for producing products to applications in architecture and engineering. So I think it's important to find the species, the right species, and here we are trying to use the biofabrication. So I think it's important
to find this. And it's important that the products now in the market are based with fibers and petroleum derivatives. So we are trying to find a natural material with a biofabrication to substitute these products.
Thank you. And Jacqueline, what would you add to this conversation?
Well, in our case, when we were invited to create a sustainable furniture to an open public space, I think when we thought about Remit Earth, I think the biggest challenge was how to reconcile a nation technique with biofabrication. And then we thought about the formwork of the Remit Earth that we created and designed it to be cut in the CNC. And we did an innovation design that has no metal locking, and all the fittings were through cutouts in the plywood. So I think we innovated in the design of the formwork. And I think the challenge is that how to reconcile this Asian technique, earth techniques, to the digital fabrication.
Yes, yeah, thank you so much. I'm not sure if I said the name of your paper, but it's Ecozona 30, Rammed Earth and Digital Fabrication for Urban Regeneration. Thank you so much, panelists. Really appreciate your contributions, and I'm really looking forward to hearing the longer presentations tomorrow. So thank you. Now let us move on. I would like to announce the first runner-up in the Best Paper Awards, and I know that we have Alessandra Crotti, who is with us, and I am going to share my screen now. Sorry. There it is. Okay, so Alessandra was writing with Paula Janneke, Adriana Cabrera, Niels Lickenthaler, Karsten Nieb, and Mark Cohen from Kamp-Lintfort in Germany. And their paper, as you can see, is called Development of an Open Source Digital Fabricated Diabetic Foot Monitoring System. All right, Alessandra, please tell us a little bit about your paper and the research.
Hello, everyone. My name is Alessandra Crotti. Thank you very much for the nomination. First of all, this research was carried out as part of the MakerPadix project, motivated by the lack of professional digitally manufactured orthopedic devices available as open source hardware, and with the aim to drive change in the care system. The MakerPadix project was launched by the Matrix and the Rheinwald University of Applied Science. Sacral foot is a chronic disease that can lead to progressive destruction of the foot, skeleton, disability, and even amputation. It occurs among people who have peripheral neuropathy. Since overloads and infection are often not noticed by the patient and are therefore often recognized and treated too late, therapy is a challenge for the patient, doctor, and orthopedic technician. In collaboration with the Fab Lab Kamp-Lintfort and the medical supply store Hodai, an open source diabetic foot monitoring and feedback system integrated into an orthosis was developed. In this process, the orthopedic technicians were the expert when it came to providing feedback and input, while the Fab Lab was responsible for the implementation. The Fab Lab was used as an environment to combine modern digital fabrication techniques with traditional orthopedic craftsmanship and its expertise. A sprint challenge was developed to facilitate the process from ideation to prototyping using agile innovation methods. An interdisciplinary team designs a manufacturing process that can be easily implemented by the medical supply store. The prototype consists of embedded temperature and pressure sensors that monitor disease progression, as well as a pressure sensor on the top of the foot to verify that the orthosis is fitting properly. The temperature sensors are needed to monitor development of infections, while the pressure sensors detect force distributions and pressure peaks. This can help reduce the occurrence of foot ulcers. Various digital fabrication techniques have been used to develop different prototypes and are discussed in this paper. Please, the next slide. As you can see here in this paper, in this presentation. Digital manufacturing enables individual placement and design of the sensors. In the future, measurements of disease progression will also be shared with orthopedic technicians, healthcare companies, and doctors. Since the high number of diabetics and the long duration of the disease have a significant impact on the healthcare system, the development of this prototype could reduce the cost of treating diabetics. Thank you very much for your attention.
Thank you, Alessandra. Fantastic. This is now where we all do the first runner-up, Kermit the Frog cheer. Yay! Well done. I'm going to stop sharing now. Great. Thank you, everyone. Now over to Peter with the next panel on ecosystems.
Thank you, Cindy, and thanks you to your panelists. Congratulations to Antonia Valencia and Alessandra. This is the last panel already in this short session. It's on Fab Lab ecosystems and self-evaluation for impact. My colleagues on the panel are Adriana, Aaron, and Canberk, joining us from Germany, the UK, and Turkey. Adriana Cabrera of Matrix GmbH in Düsseldorf, Germany, worked on the position of women in Fab Academy, the Textile and Clothing Business Lab, and the She Makes project, together with colleagues Anastasia Pisciforu and Marion Real from Fab Lab Barcelona in Spain, Shannon Sykes from Onfer Genève, Switzerland, and Anne Czesiek, also from Matrix GmbH, and Jesche Marsch, CDCS TCBL from Palermo, Italy. Welcome, Adriana, and we're going to talk about the recommendations you developed in this paper very shortly. But first, let me introduce my other two guests. Canberk Jörg of İzmir Yüksek Teknoloji Enstitüsü, the Izmir Institute of Technology in Turkey. Together with Melike Mühür, he is interested in virtual collaboration that has become so crucial in those very recent past. So they came up with guiding principles for online platforms. Welcome, Canberk. And we'll talk about these principles and what this means for Fab Labs in a moment. But first, my last not least panelists, Aaron Moore of CNC Craft in Cornwall, UK. In partnership with Andrew James Williams and Emma Bland of the University of Exeter, he carried out a study on the role of digital fabrication or digital craft for the well-being of participants, with a particular interest for those from disadvantaged groups. And he found that participants felt happier, more hopeful, more skillful, more confident, more included, and healthier. Welcome, Aaron. So I have two very simple questions for you, Aaron, but they might be hard to answer. First, why do you think CNC Craft makes people happy and healthy? And second, what does that imply for makerspaces or Fab Labs?
I think coming to a makerspace and fabricating an object satisfies a very basic instinct. To make something that is physically or emotionally useful to the person. And digital tools, digital fabrication allow you to do that quickly, easily, and you can walk away with something in your hands that is real quality. And that's why I think that's why people are happier when they leave. And in a way, they're kind of controlling their environment. And for me, what the study means is that hopefully I can get some funding to carry on what I do from local health services for treating people who have mental health difficulties or whatever. And perhaps on a bigger scale, surely there's possibilities that Fab Labs or makerspaces can bring in extra income sources for their own organizations. This would benefit the health services, and that would free up valuable resources. and it would also benefit the community. So, I mean, I think that's basically what I'm trying to say here.
Very interesting approach there. Thank you very much, Aaron. Now, Canberg, over to you. As I mentioned, you came up with 7 guiding principles for those online platforms. Now, looking at my watch here, I think we're not having time to discuss all those 7 principles, but please choose 1 or 2 that you think are most crucial for online collaboration.
Of course, thank you, Peter. Especially we generated our 7 principles hierarchically, so I will go through the order. First one is pronesis. It's one of the Aristotelian virtues, like techne and episteme, but if your techne and episteme stand alone, it is not applying the real life. So we have to apply to the real life conditions through practical wisdom. And Fab Labs are the best representatives for doing that, because we are experimenting, doing things without relying on standards, rules, or conventional production cultures. So Pronesis is providing that. Then when we come to the commons, as far as we are all aware that fabricating the commons is the issue of this conference. Fab Labs are the commoning agencies that promote the community-based peer production activities. Without commons, Fab Labs could be aimless. Then I can say a little bit about distribution. As far as we are all aware of the movements like the open source design forking, rep kind of movements or practices, distribution of all intangible and tangible assets, and also the outcomes are creating the spirit of the Fab Lab. So these 3 can give a sense about our research. Thank you.
Thank you, Canberg. Very interesting. And for everybody who is interested in the other 4 principles, of course, you can find the link to all the papers in the YouTube chat. I put it there a while ago, so I need to scroll up maybe. Thank you, Canberg. Adriana, last not least, you've seen it coming. You came up with this list of absolute do's and absolute don'ts for more gender balance in the world of Fab Labs. Can you please take us through that list again, sort of highlighting the most important elements in there, and tell us where we stand as Fab Lab?
Yeah, first of all, thank you for the panel, and through the project she makes, we are exploring several phases and the lens on gender equality through the labs, and especially the topic of textiles. But facing in the workshops and through the learning paths and the innovation services that we are exploring in these innovation ecosystems, we want to promote diversity in all the forms through the practices that we have in the Fab Labs. Starting from language, how we can communicate and embrace a new idea of leadership. In a sense, leadership is a concept that it has many phases of authority, but we want to embrace this as a diversity, as encouraging more women in these spaces, and promote not only in the spheres of Fab Labs, but also that Fab Labs can also grow and open this as in another spheres. So through the STEAM education and STEAM entrepreneurship. So another value that is very important to reflect is that how the role of women in sustainability and how it's approached now in all aspects in Fab Labs. But it is important also to understand that that how also women have the sensitivity also of carrying those roles. And so as the same as is aligned with the open access and open knowledge, we want to promote these actions also, for example, with participating in co-creation of ideas, and also how we could create a manifesto. So in a sense, my last idea through this paper is that and about the research agenda of Fab Labs is that we have not only sustainability and, for example, a care of technology, but also a lens of diversity. And this level of diversity should extend in all initiatives that that our Fab community has. And I think that this is a momentum in which we can embrace this in a new sphere of inclusivity.
Thank you, Adriana. I think we need to leave it there. Thank you very much for this call to action, really, to embrace sustainability and diversity. Quite complex tasks coming up for Fab Labs around the globe. When we listen to Adriana, thank you. Chamberg, thank you. Aaron, thank you. You were a great panel. Thank you very much. And it's now time to hand over to Cindy again for the Best Paper Award. Cindy.
Thank you, Peter, and thank you, panel. And now it's time for the Best Paper Award. And the Best Paper Award goes to Vanessa Caicho. Yay! I will be sharing my screen now when Vanessa joins us.
Thank you, Cindy. Hello, everyone. Thank you very much for the nomination. So I will present that paper, Women in the Fab Lab Ecosystem between 2008 and 2021 by Pablo Herrera, Macarena Valenzuela, and Vanessa Caicho. The research reveals an important presence of women in the STEM context that is projected as a sustainable model for girls and women in the history of the Fab Academy program and in the Fab Lab research conferences. The next, please. In this analysis of the Fab Lab ecosystem is a valid methodology to research every year the presence of women. From 1191 records in 13 years with presence of women, we analyzed the distribution of 329 women graduates with respect to the total of graduates in the 104 Fab Academy nodes. The 44% of presence of female researchers between 2012 and 2019 is much higher than in the Fab Academy. In the next slide, we reveal that the learning models present women participation percentage higher than 20% above other STEAM contexts. However, this percentage is minimal when we review the number of women graduate for each Fab Academy nodes. In 13 years, 2000 Fab Academy nodes graduated women, but only 64% had at least one graduate with a single case of 9 female graduates in 2015 from Fab Lab Barcelona. For example, in this map, we can see two important countries with more women graduating in the history of the Fab Academy. Based in this analysis, the Fab Lab ecosystem is expected to further promote the presence of women as key actors, promoting their vision, analysis, and dedication in instances of doing for practical experimentation and writing what is done from writing production. In the next slide, we want to thank so many thanks to all the Fab women for their curiosity, exploration, and love for science and technology. You are making the Fab Lab ecosystem an important daily partner in your processes, promoting sustainable lifelong learning and reinforcing their love for science. Thank you very much.
I'm going to stop sharing my screen now. Thank you, Vanessa, and your co-authors, Pablo and Macarena, who hail from Santiago de Chile and from Lima, Peru. Fantastic work. And you can see that questions of women and people who identify as women, inclusion, equity, and equality, and so on, are of increasing importance in the Fab Lab network. Well done. Now over to you, Peter.
Thank you, Cindy. Thank you to all the panelists. Thank you once again, Melvin, Thomas, Evelina, Naldi. Thank you also, Jacqueline, Juliana, Nina, and Pamela Sofia. Thank you, Adriana, Chamberg, and Aaron. Congratulations to the best paper winners, Antonia, Valencia, Alessandra, and Vanessa. Thank you, Cindy, for co-hosting this session with me and all your efforts you put into these research papers also this year, and keeping this crazy professional hobby of ours alive over the years. Really appreciate it. And thank you to the Fab TV team, particularly behind the scenes, Francisco, Adrian, Rebecca, Norella. It was a pleasure working with you. A special shout out to Marc Olivier, for whom I'll buy a beer shortly, and to Monique Chartrand. Merci beaucoup, Monique. And finally, thank you to you, Sherry Lasseter, for your support for the research papers since Fab 8 in Wellington in 2012. And with this big applause, I'm handing over back to you, Sherry. That was the Fab TV research papers session. Thank you all.
Well, thank you. Thank you to all of you authors and researchers who contributed papers this year, and especially Vanessa, Alessandra, and Antonia. Our hearty congratulations. And Peter and Cindy, you are so amazing for supporting and organizing this incredible session and this work. So now, and I just want to show this off. See, isn't this cool? This is what Zach made for us today on the giant wire EDM. Anyhow, this afternoon I have the great honor and pleasure to invite Benno Juarez to be my co-host today. He's a colleague and a mentor. You know, Benno and Victor, just for those of you who haven't been around, you know, much too long, they started, Victor Front and Benno started the first Fab Lab in Peru in 2011, and I don't know how many labs there are now, Benno, but and you all hosted Fab 7, and you know, you both continue to innovate in incredible ways since that time. So, Super Benno, welcome. How are you, and where are you today?
Thank you, Cherry. Thank you, family. I am in Peru, in Lima right now, but switching from Lima and the Amazon rainforest. I'm very, very happy and honored to be here to share about the flavors of Latin America.
All right. Well, I believe you are going to be our host for this afternoon. Just a quick catch up. You know, how are you in Fab Lat? What are you all up to this week?
Oh yeah, well, yeah, as you say, we started 10 years ago in the Fab 7 in Lima. Look at this, Cherry. Maybe you and some friends will remember this. This is the famous banana.
Oh my God, those are amazing. You used to have bananas on them, yes? It was an ambulante.
Yeah, I put some bananas here. And this was a project that won the Fab 7 competition. We started in Lima in 2011, the Fab Lab network. And then we organized it also in Santiago, the Fab 16, do you remember, and friends, during the 2017. And it's coming, the Fab Lab Puebla in Mexico in 2 more years. So we are very, very excited to be part of these great events to share what we are doing. For Latin America, I could say the opportunity to join to the global Fab Lab network is not only about to get access to technology, it's also to change mindset, traditional mindset in Latin America that usually people don't expect to find the future computers or satellites in Latin America, because usually Latin America looks like the periphery of the science and technology development in the world. But thanks to Fab Lab Network, this mindset started to change. People start not only to consume technology, but to produce technology, to create new approach to how to connect this amazing network with local communities, with our biodiversity, etc., and start to contribute with new approach about technologies and culture and nature, etc. As the most recent book of our friend Walters and the Fab community of digital handicraft community. So this is part of Latin America and part of what we are going to see in the coming videos. Yeah, okay, so for the coming videos, today we have different blocks, and we are going to start with a very mixture of different approaches about how Latin America is putting the best of our creativity and technologies to the service of people, of inclusion, of nature. We are going to see in this first block, Fabricating for a Better World from Colombia, ADA, Algorithmic Design and Cell Waving Machine from Argentina, Citizen Science from Aruba, Fab Labs de la Ville from Montreal, Techniques and Materials from Bolivia, iFurniture, a platform for customized furniture from Peru, Body Sounds from Spain, Making Bioplastics and Avocado Dye and Agar, Remix El Barrio from Spain. Go to the videos.
Un saludo para toda la gente acá desde América del Sur, en la Tierra del Sol, en la Tierra del Inca, donde se juntan los caminos de luz, donde los bits y los átomos nos dan una esperanza para seguir adelante en el fondo del túnel. Aquí desde América del Sur, en la Tierra del Inca y del Sol, desde el este al oeste, el sur al norte, unidos por una causa común. Un saludo para toda la red Fab Lab. El Océano Pacífico, un buen lugar para dar inicio al nuevo evento FAB16 para toda la gente de Canadá y del mundo, así unidos por las redes invisibles de la network. ¡Saludos! ¡Yeah!
We are the Fab Lab Cali, located at the Universidad Autónoma de Occidente in Cali, Colombia, and we would like to share with you 5 important things we've been working on. First, global engineering for local impact. Starting in 2018, we started a series of projects that have an important social impact with the collaboration of the Rochester Institute of Technology, which we have called Global Engineering for Local Impact. During the process, we developed a system to recycle plastics and transform them into the supplies for 3D printing. In addition, we integrated a 3D printer to work with solar energy. This project aimed to support the makerspace of Funda Autónoma, an NGO located in the district of Agua Blanca, one of the most depressed areas of the city, and in this process bring digital manufacturing technologies closer to the community, as well as the importance of recycling, sustainability, and renewable energies. Finally, we've had several cycles of these projects where the systems have been improved. The interaction between the two institutions has continued over the years, and two groups of students from the Rochester Institute of Technology have visited us to deliver the systems to the community with the support of alumni and the program 100K Strong in the Americas, which has allowed us to grow and work in similar initiatives. Second, the development and creation of 3D printers. As part of the activities we carried out in the Additive Manufacturing Research Seeding Group, we've been developing 3D printing systems in different configurations with an open and replicable design. We started with a Cartesian system in a Core XY configuration that served us as a platform for experimentation. Then we developed a printer with a Delta configuration, and finally several printers in a configuration similar to the Prusa for different purposes and materials, from food such as cookie dough to plastic in filaments and pellets up to clay and ceramics. This process has allowed us to learn from the particularities of 3D printing systems and to explore different uses, materials, and applications. Third, teaching aids. A few years ago, we started working with the Asociación de Discapacitados del Valle, ASODIS Valle, an association that works in pro of disabilities in our region, where we define the importance of the development of didactic materials and teaching aids to support the learning process during the school cycle. In this sense, the Maker Research Seeding Group, along with teachers and students from the university, developed at Fab Lab Cali 5 teaching aids for subjects such as mathematics and natural sciences. The first one is a game based on the dynamics of buying and selling in a supermarket, meant to strengthen mathematical skills. The second is a map of Colombia with the divisions of the regions and the activities that are carried out in each department. The third tool is a pixel art board where fractions are represented, and the fourth and fifth tools refer to the human body systems and their functions. This material was characterized by being low-cost solutions, easy to manufacture, versatile for its didactic use according to the academic level of the students, and for being inclusive since it adapts to the conditions of the students. Fourth, community makerspaces. We have supported the structuring of makerspaces in different communities in Cali, especially in depressed areas of the city. We've carried out courses and workshops in the use of CAD and CAM tools, basics of electricity and electronics, product design, and the use of machines and digital manufacturing such as laser cutters, 3D printers, among others. With these tools, we seek to reduce the digital gap and to support to strengthen the skills associated with the digital manufacturing. To this date, training has been achieved in the use of technologies available at the makerspace of Funda Autónoma, the makerspace of Public Library, Community Center of Brisas de Mayo in Siloé, and the State Library Jorge Garcés Borrell, among others. Fifth, engineering for a better world. Students of the university's biomedical engineering program have developed projects focused on improving the quality of life of different people with special needs through the use of digital manufacturing and Fab Lab's Cali technological platform. One of these projects was the production of a macro-didactic keyboard for visually and hearing impaired children of the Institute for the Blind and Deaf Children in Cali. which, thanks to its functions, texture, color, sounds, and so on, contributes to the development of gross motor skills of children. On the other hand, a group of 4 students led to the development of a device which allow a patient with arthrogryposis multiplex congenita to carry out her school activities independently and to have a better quality of life in school. Thanks to the device, the students can move, write in a better position, and interact in class by herself. Lastly, an outstanding project was the development of a series of biomedical devices made to support the daily activities of a patient with amyotrophic lateral sclerosis, ALS, who thanks to these inventions was able to walk, eat, write, brush his teeth, among other daily tasks all by himself.
Ada, autotejedora de diseños algorítmicos, es una obra robótica que vincula el tejido ancestral de Latinoamérica con los inicios de las ciencias de la computación. Es un homenaje a Ada Lovelace, que fue una inglesa de principios de 1800, poetisa y analista, que dejó escrito el primer algoritmo capaz de ser procesado por una precomputadora. Además, es una obra que hace un recorrido a través del tejido de los pueblos originarios de América Latina, encontrando la chacana como un símbolo importante en su cultura y donde tratamos a través de los algoritmos generar nuevas representaciones de esa cruz chacana. Entre las notas que nos inspiraron para desarrollar la obra hay una referente de Ada Lovelace que dice: la máquina analítica teje patrones algebraicos, al igual que el telar de Jacquard teje flores y hojas.
Bombini! Welcome to Branches Lab, a community makerspace on the Caribbean island of Aruba, where makers of all ages work on cool stuff, which we think can have real impact for our community. Some of the projects we're proudest of include our mobile makerspace that introduced more than 6,000 kids to digital fabrication, our plastic recycling factory, which is the only plastic recycling service on the island and has processed nearly 10,000 kilograms of plastic. Of course, we have to mention our emergency manufacturing of PPE in 2020. And last but not least, the project we're presenting today, our environmental monitoring program that collects and shares public data on air quality, vegetative cover, and ocean acidification as the only source of this data for our island.
So we need hardware before we can measure anything. Let's start with that. We need 3 main bits: a dust sensor, a temp and humidity sensor, and something to process and send the data to us. We played around a bit and found some goodies that seem to work well. The first sensor is the Sensorion SHT31. The second is the Planetara PMS5003, used all over the world to measure the concentration of different sizes of particulates floating around in the air. And we found a cheap chip with Wi-Fi that's easy to use and works great, the D1 Mini. We'll need a few wires and things too. Before we get too far, we're going to program our board. There's a bunch of precursor steps here that I'm going to skip. Our website has details and links. GitHub has the code. Adafruit has great guides for setting up your Adafruit IO account, your feeds, and your dashboard. But once all that's figured out, you can just upload your code using Arduino. Okay, let's plug everything in. It's pretty easy. Just make sure to check the circuit diagram, double check it, then double check it again, then quadruple check it, and you should be good. Plug it in. Let's see if it works. Check your dashboard, make sure the data's uploading. So now we can put everything in a box. Depending where you live, you might need to take extra care to make sure that the rainwater or salty air from the ocean doesn't get into the box. Ideally, install your station in a place away from structures.
Thank you for watching our video. For more of our science monitoring projects, check out our site, science.branches.com.
1 second, minuta. Okay, are we doing it? Yeah.
Hola amigos, mi nombre es Juan Brici. Nosotros somos Cubo Lab. Cubo Lab es un laboratorio de fabricación digital especializado en el dominio de materiales, la forma y las técnicas en manufactura, tanto en serie como artesanales. Cubo Lab nace en Santa Cruz de la Sierra, Bolivia. Bolivia está ubicado en el centro o el corazón de Sudamérica. Nuestro hermoso país está rodeado por grandes bosques, montañas, ríos, los cuales hacen de nuestro país un lugar muy rico y diverso en culturas y recursos naturales. Cubo Lab es incentivado por la necesidad de crear nuevas cosas, de incentivar a los emprendedores a desarrollar sus ideas.
Hola, soy Cristian Handal, soy el encargado de diseño de Cubo Lab. En mi área estamos constantemente experimentando y aprendiendo nuevas técnicas de diseño, siempre manteniéndonos en la vanguardia del diseño mundial. Cuando entiendes el funcionamiento de cada máquina, te das cuenta que los límites que tenían los materiales ahora ya no existen. Ahora podemos manipular, doblar, perforar, cortar cualquier material como si fuera barro. En Cubo Lab podemos hacer desde un llavero hasta el revestimiento completo de un edificio, y la sensación que queremos dar en cada proyecto es que el resultado se vea tan complejo, siendo que no lo es.
Nuestro proceso de trabajo comienza con una idea que es convertida en diseño, la cual se transforma en piezas para ser trabajadas de manera artesanal, utilizando las antiguas técnicas de fabricación nativas, como ser el tejido, el tallado, el modelado y las diferentes técnicas de ensamblaje.
iFurniture es una plataforma que vincula una red de diseñadores, carpinteros y centros de fabricación local distribuidos en varias ciudades de nuestra región. Ofrecemos a los usuarios productos inmobiliarios personalizados. Desarrollamos I+D en el Fab Lab iFurniture, aplicando diseño computacional, manufactura avanzada y carpintería digital. Nuestros productos son de características armables, desarmables, flexibles, transformables, modulares y ahorradores de espacio. Utilizamos software de modelamiento 3D, diseño paramétrico y aplicamos herramientas de fabricación análoga y digital. Somos parte de la cuarta revolución industrial.
Body Sound è uno dei 10 progetti pilota che sono stati sviluppati all'interno del progetto Horizon 2020 SysCode.
Il processo che ci ha portato allo sviluppo di questo sistema ha visto coinvolti i bambini e famiglie dell'associazione Pay the Stroke.
Circa 17 milioni di bambini in tutto il mondo hanno avuto una diagnosi di paralisi cerebrale infantile, una problematica che è intervenuta con una lesione importante al loro sistema nervoso centrale e che può dar loro delle disabilità di tipo motorio, cognitivo o comportamentale.
L'innovazione di Body Sound sta nel meccanismo hardware e software che consente il body tracking. Body Sound dà una soluzione a tutto ciò integrandolo con la riflessione e l'uso della musica, quindi trasformando tutti gli esercizi in un'esperienza di danza e interazione appunto con la musica.
Body Sound will be used in different places, such as schools and sports centres, but the main recipients will be rehabilitation centres. In order to improve its efficacy, every child will be able to log into their dashboard, also from home, so that they can keep playing and training. Body Sound is designated for therapists and sports medicine physicians who will be able to develop custom training programs based on every single child's ability and goals. Body Sound will automatically convert these exercises in a level-based game. The main target are children, but different kind of users and patients could be included. Body sound supports the development of gross motor skills, the acquirement of the body plan, and the development of coordination and balance. It can also help the child to acquire specialized motor gestures of a specific sport. It can support the motor strengthening and the ability to interpret rhythm.
Wonderful experience, wonderful projects. Thank you, Fab Chairman, for always inspire us to get in contact, to join the points. As Nuria says in these amazing videos a few hours ago, reconnect with the network. We are a network, but maybe we don't know exactly where the others are. As the Fab Chairman says, as Nuria says, this event is also a huge opportunity to reconnect and also to start to see who else we could reconnect. Thank you also to Colombia, Argentina, Uruguay, Canada, Bolivia, Peru, Spain, to show us with your creativity, with your job, with all this passion that you put in the project, how could we also reconnect our region? Right now, continues with this amazing flying through the Latin America and friends country. We are going to jump to INDG Fab, an introduction of this amazing project from US, the red Chilena of Fab Labs, and the red Ecuatoriana, the Ecuadorian Fab, I'm sorry, I am mixing English and Spanish, sorry. The Fab Labs network of Chile and Ecuador also in the coming videos. Go to the videos.
Heni hotu, ima Jean-Luc Perite tisa, ima Tayaronica Haraeke tisa. My name is Jean-Luc Perite. I am originally from New Orleans. I'm a member of the Tunica Biloxi tribe of Louisiana, formerly working with the Fab Foundation, now a recent graduate at EAC and the Master in Design for Emergent Futures, also recent graduate of Fab Academy 2021. I am here today, and I'm actually very grateful for this opportunity from the Fab Lab Network to share some of the information about my my new project, IndigiFab. So. who I am in the course of my studies, in the course of my activism, understanding that there's not just the International Fab Lab Network centered around digital fabrication educational programming, but there's also language documentation international networks. There's also life sciences international networks, all centering this need for community-based research. And what I find is that there is a need for people where I am at the intersection, being passionate about all of these fields, but then also really being passionate about the needs and priorities of the community that I represent. So that's why I'm here.
La red chilena de Fab Lab se compone de casi 20 laboratorios de fabricación digital a lo largo de todo Chile, representando 6 ciudades de nuestro país. Cada laboratorio con diversas líneas estratégicas, pero siempre vinculándose con su territorio y su comunidad. Hoy nos queremos mostrar como laboratorios compuestos de personas, más que de máquinas, donde tenemos experiencias, conocimientos y muchas ganas de colaborar. Los invitamos a participar de la red chilena de Fab Labs, sus laboratorios y sus proyectos.
Hola, soy Ricardo Román, director del Fab Lab del Colegio Alberto Lesgana, y quería invitarlos a venir a conocer nuestra experiencia.
Nuestro laboratorio se enmarca en el trabajo con estudiantes de educación primaria y secundaria, desarrollando en ellos las habilidades creativas por medio del uso de tecnologías digitales y médicas, utilizando impresoras 3D, cortadoras láser, robótica, electrónica y lenguajes de programación.
Nos especializamos en el desarrollo de proyectos escolares que solucionen problemáticas, fomenten la creatividad y se articulen con las distintas asignaturas de nuestro currículum.
Por último, nos encanta trabajar colaborativamente con equipos de colegios y universidades, abriendo posibilidades a nuestros estudiantes. Por ello, lo invitamos a seguirnos en todas nuestras redes sociales y a colaborar juntos. ¡Los esperamos!
Vivimos una revolución industrial en donde tenemos el desafío de soñar para construir un futuro mejor. Somos Fab Lab Atacama Sinda, el laboratorio de fabricación digital ubicado en el desierto más árido del mundo. Detonamos procesos de transformación para ecosistemas y territorios locales utilizando tecnologías 4.0.
diseño, reciclaje, emprendimiento e innovación. Acompañamos a comunidades en espacios de prototipaje, desafío y formación, entregando habilidades y competencias a pymes, docentes, emprendedores y estudiantes de Antofagasta. Trabajamos para que todos puedan conocer las infinitas posibilidades de la sociedad digital, la sociedad del futuro.
Hola, mi nombre es Javier Padrón, manager del Fab Lab UA, parte importante e integral del Design Lab en la Universidad Adolfo Ibáñez en su sede Peñalolén. Bienvenidos a nuestro laboratorio.
Mi nombre es Willy Milla y soy Fab Lab Manager del Fab Lab de la Universidad Adolfo Ibáñez en el campus de Viña del Mar. Nuestros laboratorios prestan un servicio transversal a todas las áreas del Design Lab, lo que permite a alumnos, profesores e investigadores realizar sus proyectos de principio a fin con acabados profesionales a través de la fabricación.
Estamos sumamente orgullosos de pertenecer a la red chilena de Fab Lab y ahora, a su vez, a la red Latam, ya que en ella encontramos a gente súper talentosa y con muchas ganas de dejar muy en alto a todos nuestros países de Latinoamérica. Así que siempre bienvenidos a nuestras instalaciones y esperamos verlos pronto. Muchas gracias.
¿Podemos agregar valor a nuestra agricultura transformando residuos en recursos creativos? ¿Es posible volver a conectar la manufactura con los ciclos naturales y los territorios? ¿Podemos desarrollar productos locales a partir de materiales endémicos y regenerativos? Estas preguntas guían el proyecto Nodo Biofabricación Digital, que consiste en el diseño y documentación de un laboratorio creativo capaz de fabricar materiales y productos biodegradables a partir de residuos de la agricultura local. El nodo es proyectado para ser ubicado cerca de los residuos, incorporándose a las redes agroindustriales de cada territorio y compartiendo información a través del uso de las tecnologías con otros nodos. Cada laboratorio integra un set de herramientas y tecnologías de bajo costo y formato escritorio para abordar diferentes procesos de biofabricación, tales como impresión 3D, rotomoldeado y termoformado de biomateriales, y la biomixer, una máquina inteligente que genera mezclas precisas y fabrica láminas a partir de propiedades que solicita el usuario. Para desarrollar este proyecto hemos estudiado y experimentado con residuos orgánicos de la agricultura chilena para comprender las oportunidades que presenta cada recurso para el desarrollo de bioproductos de alto rendimiento que puedan integrarse en los ciclos naturales y los ciclos sociales. El proyecto busca generar una red de diseño y manufactura distribuida donde nodos territoriales y conectados materialicen bioproductos a pequeña escala con infraestructura y materiales locales, y así poder transitar hacia modelos alternativos de producción. Mi nombre es Danisa Perich y soy parte del equipo del Fab Lab de la Universidad de Chile, comunidad creativa que impulsa proyectos orientados a generar bienestar social y ambiental a través del desarrollo y aplicación de tecnologías emergentes de fabricación. Un gran abrazo y un saludo a toda la red Fab Lab.
Hola, mi nombre es José Aldunate, yo soy el jefe del Fab Lab de la Universidad de Aysén. Nosotros estamos ubicados en el Museo Regional de Aysén, acá en Coyhaique, y trabajamos en conjunto con el Museo de Aysén en una serie de actividades. Nosotros tenemos hoy un enfoque de proyecto de rescate patrimonial con recursos tecnológicos y de manufactura local. Nosotros en el último tiempo nos hemos dedicado a la fabricación de escudos faciales para todo el personal de salud de la región de Aysén. Y tenemos mucho por desarrollar. Somos un Fab Lab naciente que partimos en marzo de este año y los quiero dejar invitados a toda la red latinoamericana de Fab Labs a que se vinculen con nosotros encantados de recibirlos y de trabajar juntos.
Carolina Valenzuela y soy coordinadora del Protein Lab UTEM, el Fab Lab de la Universidad Tecnológica Metropolitana de Chile. Nuestro trabajo se basa en la transferencia tecnológica y proyectos de vinculación con el medio, con emprendedores, empresas y comunidades locales. Nuestro equipo se conforma de diseñadores, ingenieros electrónicos e informáticos, todos trabajando colaborativamente para el desarrollo de proyectos multidisciplinarios. Les quiero hacer una invitación a la red de Fab Labs a participar de distintas iniciativas que estamos desarrollando desde el Protein Lab UTEM. Una de ellas es la implementación de distintos laboratorios de fabricación digital en diversos puntos de nuestra región, como es el que acabamos de instalar en la comuna de Renca. La idea es dar acceso a la comunidad a estas nuevas tecnologías para el desarrollo de nuevos emprendimientos locales.
El Fab Lab es un laboratorio taller de prototipado y de manufactura tanto como de artefactos y productos que con herramientas de fabricación digital principalmente, complementado con algunos métodos tradicionales, ayuda a acelerar proyectos. Está abierto a estudiantes, a académicos, a empresas y a emprendedores.
Al vincularse con el Fab Lab del Centro de Innovación UC, las empresas pasan de la manufactura clásica a la 4.0, adquiriendo conocimientos en fabricación digital, accediendo a maquinaria avanzada y formando parte de todo el ecosistema Fab Lab de Chile.
Algunos de los servicios que ofrecemos son Fab Inspiración, que es un workshop donde revisamos las proyecciones y los alcances de la fabricación digital. Fab Tech es un workshop más intensivo que se enfoca en los aspectos técnicos de la fabricación digital. Fab Prototipo es una jornada donde reunimos a expertos y prototipamos in situ. Y por último, Fab Desarrollo, que es la manera en la cual nosotros podemos abarcar un proyecto completo de desarrollo de producto.
Fab Lab es una iniciativa estudiantil que lleva más de 6 años de existencia. Nuestra idea es facilitar las herramientas para que cualquier persona pueda venir a crear y fabricar y llevar algo material sus ideas. Por eso contamos con máquinas de fabricación digital que lo que hacen es llevar un diseño desde un diseño en computador digital a un objeto físico. Esto te permite probar ideas, ir iterando procesos para llevar tu idea a un prototipo, a una prueba de concepto, y con eso eventualmente podrías escalarlo a algo mayor o transformarlo en un emprendimiento, por ejemplo, o seguir desarrollando.
We, the individuals, are always needed to do our best for our personal and our colony's benefit and well-being. The colony, on the other hand, works for our security as a whole, guides our way expanding horizons, and provides abundant resources. This is how the future, our future, is built. This colony is made up of many people creative businessmen and women, designers and engineers, scientific researchers and makers, youngsters and adults, experimented wise men and women, and those who are constantly learning with simple and high-end technologies. All this together allows us to live in harmony with other species colonies in the same planet, everyone's planet.
It's Ecuador right now, or still chilling? Wonderful message from all these three amazing videos. Thank you, Super Jean-Luc, to inspire us to connect spirituality with technology. Thank you, Maca, and the amazing Chilean Fab Lab Network. And thank you, Ecuador, for inspiring us also to connect technology with people. Right now, we are going to jump in this digital flight to the biggest Fab Lab network in Latin America. It's Brazil. And I am more than happy to present to our friends from this amazing country with about 130 Fab Labs. Go to the videos.
A rede Fab Lab Brasil é uma rede independente que se conecta a outras duas, a rede Fab Lat, da América Latina, e a rede mundial. Estar conectado, porém ao mesmo tempo independente, é importante para participarmos de forma colaborativa, mas também propositiva. Um dos aspectos importantes da rede Fab Labs é ser horizontal. Isso significa que as pessoas colaboram e compartilham seus conhecimentos, sendo proativas e se voluntariando no desenvolvimento de ações e projetos. Ao invés de pedir permissão, as pessoas interagem de forma orgânica e sem muitas barreiras. Os projetos ganham velocidade e as soluções se tornam mais robustas. O que significa a palavra Fab Lab? Laboratório fabuloso? Laboratório de fabricação digital? Quase isso. Fab Lab significam duas coisas. 1. A própria rede global de laboratórios locais que possibilitam a invenção ao fornecer acesso a ferramentas de fabricação digital e os próprios espaços físicos individuais e independentes que possuem ferramentas manuais, ferramentas elétricas com foco em software de modelagem 3D, máquina de controle CNC, insumos eletrônicos, open source e conexão em rede. No Fab Lab, as pessoas podem desenvolver elas mesmas suas ideias e protótipos. Isso vai desde a educação infantil até a implementação de grandes projetos em indústrias de ponta. Nestes espaços, as pessoas têm acesso ao conhecimento, equipamento de fabricação digital e materiais para desenvolver suas ideias, sejam elas pessoais ou protótipos de produto.
Fab Lab Brasil!
Hola a todos, mi nombre es Vanessa Caicho, soy parte del equipo iFurniture Carpintería Digital y vamos a presentarles dentro del Fab TV nuestro nuevo proyecto iHub, red de carpinterías digitales en la región latinoamericana con la metodología de fabricación local distribuida. La red de carpinterías digitales ha sido pensada y creada desde hace muchos años con el objetivo de poder integrar carpinteros, diseñadores a nuestro nuevo ciclo de producción industrial de la carpintería digital. Esta es una de las primeras experiencias y acercamientos con una empresa carpintera que tuvimos en el año 2015, vinculando una empresa tradicional al mundo de los Fab Labs. Aquí pudimos integrar procesos tradicionales y convertir los Fab Labs. Aquí pudimos integrar procesos tradicionales y convertirlos en procesos digitales. iFurniture comenzó hace 7 años en el Fab Lab de la Uni, asistiendo al Fab Academy 2014. A partir de allí hemos investigado y aplicado procesos de transformación digital en madera, diseño y muebles. Este año 2021 estamos desarrollando el modelo de distribución acorde a la fabricación en red mediante el empoderamiento de carpinteros. La tecnología contribuye a la transformación digital de muchas industrias. La empodera, la potencia y la evoluciona. Los carpinteros tienen la posibilidad de aprender nuevas técnicas con el uso de herramientas digitales, una mejora productiva y un crecimiento económico que contribuye al fortalecimiento y la revaloración de la cultura de madera en nuestra región. Los hubs contarán con las siguientes características: aplicación de tecnologías de manufactura digital para la producción local de mobiliarios personalizados, distribuidos en diferentes ciudades y países, vinculados a la plataforma iFurniture a través de contrataciones de fabricación, potenciando la industria de la manufactura local con impacto en la región, diversificando el comercio online de muebles. ¿Cómo está compuesto un hub? El iHub está compuesto por personas, máquinas y espacios. Las personas que son los carpinteros, makers, productores, artesanos y fabricantes. Las máquinas que por otro lado son el corte por control numérico computarizado y los espacios que son ambientes semi-industriales o industriales donde se permiten realizar las actividades para fabricar los productos. Nuestra segunda experiencia de integración la hemos realizado en una carpintería dentro del Colegio Melitón Carvajal, en Lima. Allí se encuentra un taller de carpintería enfocado a la educación. En este espacio estamos proponiendo integrar herramientas con carpintería digital, realizando capacitaciones y talleres actualmente en formato online. ¿Cuál es la potencialidad de los hubs? Un hub permitirá adecuar los espacios con tecnología para automatizar y fabricar muebles. Estos serán muebles personalizados que pueden realizarse en menor y en mayor escala. Tenemos 5 importantes áreas: el área de diseño computacional, prototipado rápido, automatización de procesos, transferencia tecnológica e infraestructura de máquinas. Además, este modelo está pensado en incluir la participación de la mujer como diseñadores, makers y ellas realizando prototipos juntos con los carpinteros. El valor de esta integración se fortalece con el conocimiento compartido. Este es un nuevo modelo de transformación industrial donde integramos estos hubs de carpintería junto con proveedores, ya sean de materiales o de servicios, y también con diseñadores de muebles, makers, arquitectos, formando así un nuevo ecosistema de producción para la industria de la madera y del mueble. La cadena de valor. Estos procesos industriales los hemos desarrollado en iFurniture, generando una cadena de valor en diseño, prototipado, logística de producción, asesoría técnica, fabricación distribuida y servicios de postventa. Para poder hacer que los hub fabriquen los productos, hemos establecido protocolos que permitirán que los carpinteros reciban los diseños de los muebles listos y ellos los pasen a fabricar a las máquinas. Hemos considerado dos importantes máquinas del mundo de los Fab Labs, la máquina de corte router CNC y la máquina de corte láser CNC. Estas dos máquinas trabajan con diseños asistidos por computadora transferidos a software de postprocesados que permiten luego el corte digital de los productos en distintos materiales. Desde hace varios años hemos venido trabajando en un portafolio de productos en distintas líneas de diseño. Estos productos podrán ser distribuidos a todas las carpinterías de la región, llamados iHubs, y estos serán fabricados con materiales locales. La proyección que tenemos con los iHubs es validar el modelo de manera local en el Perú, de manera regional en Chile, Brasil, Colombia y de manera global Estados Unidos, Europa y otras partes del mundo. Para esto nos apoyamos de la red Fab Lab, que cuenta con más de 2.000 laboratorios. Buscamos integrarnos con otros países, ciudades, culturas e idiomas. Otra experiencia que realizamos sobre fabricación local distribuida fue en el año 2017, en China, donde a través de una alianza con el Fab Lab Shenzhen, realizamos una instalación de muebles en una exposición internacional. Con esta experiencia validamos el formato iHub, diseño digital, transferencia de archivos, protocolos de fabricación y fabricación in situ. El valor más importante que tiene este proyecto es la revalorización del carpintero local, integrado a la cadena de valor del nuevo modelo industrial, empoderarlo y potenciar su crecimiento económico y productivo. ¿Cuáles son los beneficios de los hubs? iHub te da como beneficio capacitación constante, posicionamiento en el mercado, eventos, charlas, webinars, workshops, acceso a contacto a proveedores, acceso a nuevos diseños de productos, interacción entre productores locales y acceso a la comunidad iHub con actualizaciones e innovaciones. Estas son algunas de las entidades e instituciones que respaldan nuestro proyecto y que están constantemente vinculándose con el mundo de la innovación tecnológica y el emprendimiento. Estamos seguros que los hubs de carpintería digital se integrarán a toda la comunidad de Fab City para poder generar dentro de nuestra región una mejora productiva y económica. Muchas gracias por la oportunidad para explicar nuestro proyecto. Si quieres ser un iHub, contáctate con nosotros. Gracias nuevamente.
Go. Thank you, Brazil. Thank you for this amazing trip, for a lot of Fab Labs and a lot of passion. Thank you, Kenzo, Master Kenzo, to organize these videos and this also this session in Fab Lab. It's a special thank you for you, because thanks to you, we have these different sections for the Latin American, Brazilian, and Caribbean networks. And continuing with the fly for this LAT region, we are going to visit one of my favorite communities. It's a 3D fashion community with amazing examples of creativity in fashion in different parts of Latin America and outside the region. And then we are going to test a bit about the FAB18. Puebla, Mexico is going to show us what they are doing right now. Go to the videos.
Hola. Bueno, les damos la bienvenida a este video sobre el 3D Fashion Week, un video que hemos hecho con mucho cariño para todos ustedes, participantes del evento mundial de los Fab Labs, el FAB16. ¿Cómo nace 3D Fashion Week? Bueno, es una experiencia que nace desde que yo era niña. Tenía 12 años, además había crecido entre telas y hilos. Mi madre aceptó que llevara el curso que ella dictaba de corte y confección. A los 14 ya reciclaba mi ropa y diseñaba mi indumentaria. Y esto se fue perdiendo con el tiempo a la medida que ingresaba a la universidad a estudiar Derecho y Economía y trabajaba en mis horas libres. Hace 11 años mi vida dio un quiebre al conocer Fab Lab por mi hija Durcha. En lo personal me reencontré con el diseño, primero como diseñadora y luego a través del 3D Fashion Week Lab. Ahora Motivo e impulso a jóvenes diseñadores y diseñadoras a usar tecnologías de fabricación digital y biomateriales para crear una moda sostenible. Y en este andar encontré muchos colaboradores, principalmente al equipo organizador que hoy me acompaña, y sin el cual no hubiera sido posible crecer. Roxana Zabaleta del Águila, diseñadora, mi brazo derecho e izquierdo que me acompaña desde el primer 3D Fashion Week en el 2017. A Ángela Barbour desde Brasil, científica y artista, compañera de viajes y aventuras con Fab Lab, embajadora de FABTV para Latinoamérica. A Eliana Guzmán desde Argentina, un talentazo del diseño y las tecnologías disruptivas, instructora internacional, invitada de FABTV. Sin ellas, no hubiera sido posible el escalamiento a toda nuestra región latinoamericana. Ahora voy a dar el pase a Ángela Barbour, que nos va a hacer una reflexión de cómo también sirve este proyecto del 3D Fashion Week. Adelante, Ángela.
Gracias, Delia. Un gusto enorme estar aquí con ustedes en esta participación de 3D Fashion Week y en FAB16, nuestro evento, la Conferencia Internacional de los Fab Labs en 2021. Y aquí traigo la siguiente reflexión. La humanidad se enfrenta a las amenazas gemelas del cambio climático y la pérdida de la biodiversidad, la diversidad biológica, que juntas están socavando la capacidad para mantener una vida sana, dietas nutritivas y economías nacionales. Los dos están íntimamente relacionados y deben abordarse juntos con urgencia y con la misma ambición. Dentro de estas amenazas se encuentra la industria textil y de la moda. Después de la industria del petróleo, la industria textil es la segunda más contaminante del planeta, según la Agencia de Protección Ambiental de Estados Unidos, Business Empresarial. Cada vez consumimos más cantidad de ropa que dura menos tiempo en nuestro closet. Una pesquisa aquí que hicimos decía que si tenemos como 20 piezas de ropas, 20 piezas contando todo, desde zapatos, calzados, blusas, vestidos, podríamos pasar 1 año y medio haciendo looks distintos día após día sin nunca repetir. Entonces, realmente tenemos mucha ropa.
Gracias por esa reflexión, Ángela. Ahora le damos pase a Eliana Guzmán, que nos va a hacer una reseña del 3D Fashion Week.
Muchas gracias, Delia. Feliz de estar compartiendo este evento y acá con mis amigas Ángela y Delia para todos ustedes. Bueno, voy a continuar con esta reseña de lo que nos motiva a llevar este evento adelante. En el mundo, los 3D Fashion Week están alcanzando notoriedad, no solo por la versatilidad de los diseños, desde la alta costura hasta las vanguardias, sino porque su propuesta trae consigo una moda sostenible, ética, con uso de las tecnologías como el corte láser, la impresión 3D, los biomateriales. Sin duda la moda a nivel global tiene mucha visibilidad. ¿Cómo aprovechar esa visibilidad para atraer al diseñador junior, para que se convierta en ese agente de cambio que tanto necesitamos y que tanto necesita la industria? Ofrecer una alternativa de moda sostenible con tecnología en laboratorios abiertos e inclusivos, donde este diseñador junior pueda explorar diferentes soluciones, fue nuestra propuesta y nuestra motivación para llevar el 3D Fashion Week adelante. En Latinoamérica, los Fab Labs constituyen una de las principales plataformas que promueven y practican estos conceptos, encaminando al país a la innovación tecnológica.
En este contexto, los 3D Fashion Week visibilizan el talento del diseñador inmerso en la transformación tecnológica y difunde la presencia del diseño de moda latinoamericana. El crecimiento del evento ha escalado significativamente, lo que hizo posible la presencia en 2 años consecutivos de diseñadoras latinoamericanas en el evento internacional Fashion Digital Night, realizado en Roma los años 2019 y 2020, y en este año, el 2021, en el POW realizado en Milán. Gracias a la alianza con Fundación Mundo Digital. 3D Fashion Week Labs integra, además de la pasarela, talleres y paneles donde compartimos conocimientos a nivel global de este mundo textil y de la moda. Hemos tenido 4 ediciones. Aquí ustedes están viendo nuestra primera edición el año 2017 en el Parque de la Muralla de Lima. Nuestra segunda edición, el año 2018, ya tuvo participación internacional y nos permitió en enero del 2019 poder participar en el Fashion Digital Night de Alta Roma. Fueron seleccionadas 3 de nuestras diseñadoras que a ustedes pueden ahí apreciar los diseños. En el 2019, en noviembre, se realiza nuestra tercera edición del 3D Fashion Week. Tuvimos invitadas a nuestras coorganizadoras ahora, Eliana y Ángela, que pudieron también presentar sus colecciones. Ese mismo año también fueron seleccionadas nuestras diseñadoras para participar en el Fashion Digital Night en enero del 2020. Tanto las diseñadoras peruanas como latinoamericanas estuvieron presentes y en realidad fue un orgullo increíble el poder verlas en pasarela. El año 2020, además, en una rueda de prensa que se realizó en las instalaciones de Facebook, nos permitieron presentar el 3D Fashion Week. Y esto ocasionó mucho interés, por lo mismo que le estamos contando, por este fondo que tenemos de poder cambiar una industria contaminante a una industria limpia, ¿no? En el fondo. Y esto lo expusimos y hubo mucho interés de las diseñadoras europeas que estaban muy animadas en participar en la siguiente edición del 3D Fashion Week. Lanzamos el 3D Fashion Week en el año 2020, todo virtual, y aquí tenemos las imágenes. Nuestro primer video de las diseñadoras latinoamericanas invitadas al 3D Fashion Week Latinoamérica.
Bienvenidos al 3D Fashion Week, cuarta edición. Este evento lo que busca es visibilizar el talento joven, el talento innovador, el talento de la investigación, de la ciencia, ya aterrizada en la tecnología. Lo que buscamos es brindar soluciones para una tecnología limpia en las áreas de textil y moda.
Un segundo momento de diseñadoras junior de todos los países donde el 3D Fashion Week tiene representación que previamente han sido seleccionadas por un jurado iberoamericano. Veamos ahora.
Y tuvimos también un tercer momento con invitadas máster europeas y del resto del mundo.
3D Fashion Week.
Este año, el 3D Fashion Week lanza la temática Ethic and Ethnic Fashion Tech. Los diseñadores tendrán el gran reto de usar tecnologías disruptivas como herramientas para diseñar indumentaria y accesorios que revaloren la cultura de cada país. Al mismo tiempo, pongan en valor la ética, tanto en el diseño como en los procesos. Con esto, buscamos dar respuesta inmediata para reducir los efectos de la contaminación causados por la industria textil y la moda. Pues invitamos a diseñadores junior y toda persona interesada en el mundo textil y de la moda a participar de esta quinta edición del 3D Fashion Week. Esta convocatoria admite dos tipos de propuesta. La primera, la presentación de un video y fotos de una mini colección o pieza única ya desarrollados y que estén vinculados con la temática propuesta. La segunda opción, la presentación de bocetos de un book virtual, de una mini colección o pieza única para ser desarrollada y que estén vinculadas con la temática propuesta. Los diseñadores que participen en el desfile serán parte de la selección de postulantes del Fashion Digital Night en Roma para el año 2022. Para ello serán evaluados por un jurado internacional especializado. Podrán encontrar nuestras bases visitando nuestras páginas de Facebook e Instagram o escríbenos al correo contacto@3dfashionweek.com. Recuerda que cerramos las inscripciones el 31 de agosto.
Muchas gracias a todas y a todos por participar de este encuentro y esperamos muchas personas que puedan participar de esta nueva convocatoria.
Muchas gracias a todos por estar aquí con nosotros en esta divulgación de 3D Fashion Week y esperamos que ustedes puedan traer sus ideas, sus proyectos y belísimos diseños para esta edición y las próximas. Hasta pronto.
Espero hayan disfrutado del camino recorrido del 3D Fashion Week. Estamos aquí para seguir colaborando, seguir trayendo nuevas ideas y como dice Ángela y Eliana, estamos entusiasmados con ver esta participación masiva de toda la red de Fab Labs. Hasta pronto.
Hi, welcome to Fab Lab Puebla. We are happy to show you a little bit about what we do here. We are located in Puebla City, just 2 hours away from Mexico City, with 2 million inhabitants and an important manufacturing and service industry.
we are the fourth most important city in the country. Fab Lab Puebla is part of Iberoamericana University, one of the most important universities in Mexico. Here, we have the Institute of Design, Innovation and Technology, where interdisciplinary teams work every day developing amazing projects with social impact. We have developed machines for local industry, new products for regional businesses, and we have coached entrepreneurs in innovation processes and on democratization of technology. Hey, and you know what? We have a wonderful team full of ideas and energy. Say hi! Finding solutions locally make communities stronger. That's why Fab Labs are important assets. During the COVID-19 pandemic, we have seen a lot of work around finding solutions through the Fab Labs. The Fab Lab network has worked day and night developing solutions, developing new products that will help during this terrible situation. In our case, we designed a frugal mask shield, which we produced over 60,000 of them. And we are very happy because most of those mask shields were given to hospitals in the region.
What makes me passionate about Fab Labs are essentially three things. The first is diversity. There are people all over the world working on the same objective and being in contact with everybody. The second thing is that the Fab Lab is a very safe place for imagination. You can build, you can do things, you can imagine things, and then you can make them happen in the real world. And the third thing is connection. we are all the same tribe. You can find very similar people. Even though we are diverse, we are very similar in our objectives and our ways to see the life. Well, the impact that Fab Labs have had in Mexico, mainly it's a growing community of people that are starting to make great projects. We can see all these projects in Tijuana in the north, or in Fab Lab Maya in the south, with Trini working with the communities, or Alejandra in very poor parts of Nuevo León in the north, the northern state of Nuevo León, or Fab Lab Nuevo León, that they are working in this beautiful building. We also in Puebla are working with the communities at the rainforest in Chiapas, or in the mountain. We are even translating some courses to Nahuatl, to Mayan, to Totonaca languages. You can see people in Mexico City working with entrepreneurs. There's a new Fab Lab in the National Library of Mexico that is very, very beautiful. I mean, it's a very exciting movement that is growing here in Mexico. I think that there's this need for evolution of the movement. Not only as Fab Labs per se, but how these Fab Labs can impact different industries in small scale for local production. We are working at Fab Lab Puebla a lot with ceramics. And how do you use vinyl cutter for ceramics? How do you use laser cutting for ceramics, or the router CNC? We have seen many impacts in this case, because we are working with artisans, we are working with small companies that are already using these digital fabrication techniques to improve basically design and repetitivity in their industries. So I think the Fab Labs have to evolve to places where people can locally produce things, produce goods for their cities and for their environments, looking for local solutions for production.
In 2023, Puebla will host the FAB18, and we're very happy and very excited about that. And we want you to have a fantastic experience here with us. We are working on that. For now, let's have a sneak peek of what this wonderful city has to offer.
Viatja per Puebla perquè és infinita.
Travel through Puebla because it hands in its tradition. Voyage à Puebla parce que sa musique se transmet et ne s'oublie jamais.
Ich reise durch Puebla, weil Kunst alles erfüllt.
一起来 Puebla， 人除了要吃饭，也需要精神粮食。
Viaja por Puebla porque es aventura.
Thank you for watching. I hope you enjoyed. Bye.
Thank you so much for this amazing trip. Thank you, Super Delia, Super Angela, and Eliana, and all this amazing 3D Fashion Week team for your creativity. It's awesome. Thank you so much. And thank you so much, Maestros Aristarco, Luis from Puebla. This is amazing Fab Lab, the biggest Fab Lab in Latin America. Congratulations for all your job for inspire us. So we are arriving to the end, or the end station of this lab trip, and we are going to jump from different places. We are going to visit 3D experiences, SolidWorks, MDEF, making paper from coffee hubs, Canary project, understanding digital skill with a humanoid robot, partners of experience, Fab Lab makers narrative, master narrative, sorry, and finally, lab kids exercise from lab people. So enjoy these coming videos.
What's up guys, my name is Brad and I run a YouTube channel called Impact Props where I make awesome things, helmets, replica costumes from your favorite movies, video games, whatever, and then we go do crazy stuff with those characters. But first and foremost, I am a maker, which is why I am so absolutely amped to be talking in front of you today. So I've been using SolidWorks for the past probably 6 years professionally to create and design. SolidWorks is an incredible design software that I love. I wouldn't pick a different one. SolidWorks is my go-to software when designing and creating. But as a maker, the price tag has notoriously been way out of my price range. And I've been asking and asking and begging and begging and begging for SolidWorks to make a version of SolidWorks for makers that is more affordable and would allow people like me to create incredible things using this software. And I'm so excited to be telling you this today because as a maker, SolidWorks has answered our prayers. SolidWorks is the industry standard for 3D modeling, and today, if you're a maker, you can get it for $9.99 a month. Woo!
Escogí MDEF porque es un programa que está tratando temas de actualidad. Quería saber más sobre estos temas emergentes y quería también diseñar un poco mi propio futuro.
One of the things that you learn in this master is how to design a future. We realize that the futures are created with little iterations in which you go building a new future little by little, step by step.
You definitely have to be a curious person, somebody who really wants to explore multiple aspects of design and understand that design can be anything and it can have impact anywhere.
You find people from so many different places with so many different backgrounds, but then again it's this one clique where everyone's interested in the same future, everyone's working towards making this change.
If you feel like a misfit, or if you feel lost, I believe this might be the place for you.
My participation in the Partners of Experience project was especially rewarding because it provided direct contact with young professionals from various fields. This project was different from other projects in that it took us out of the classroom and into our community to see what resources are available that we were not aware of, or as in my case, I was aware of the resources, but with the input of the leaders, I saw a different approach, and I appreciate that. For any future projects that I hope I would participate in, I would like to see more direct support from the leaders to help us approach people in power to implement changes that affect us in our everyday common problems that we face in our immediate surroundings.
The Thessaloniki Active and Healthy Aging Living Lab, Thessa Hall, aims to tackle ageism and the risk of social discrimination and the cultural stigma experienced by older adults due to their loss of physical, mental and social abilities as they age. To do so, the Thessa Hall has introduced a lifelong learning program, the so-called Partners of Experience, addressing early-stage researchers over 65 years old. The program exploits co-creation and citizen science as its means to enhance beneficiaries' competencies and skills towards active citizenship. In its first prototype, released in the context of Ciscode project, the Partners of Experience has an alternative research group who co-created solutions for their city everyday living challenges, environment, public health, active citizenship, and with their city as they strongly collaborated with the university and representatives of the municipal authorities.
If you could make almost anything, what would you do?
I would believe very strongly there's a kind of a dignity in making things.
Fabrication is being digitized and becoming personal.
This is the craft of our century.
Fab Labs are about digital fabrication, which means you can design something and then a robotic machine will make it, bring it into life.
It provides the means to create what you consume. It includes a 3D printer, a precision machine that can make electronic circuits.
Fab Labs are in, we believe, about 75 to 80 countries, doubling in size every, say, 12 to 18 months.
Probably the best single toy that mankind has ever invented.
Where can they now make a societal impact, just like it is done in Kenya, Rwanda, India, China, the floating Fab Lab down the Amazon that they're trying?
Putting a Fab Lab in a refugee camp provides creation and bootstrapping.
It fits in a shipping container. It's a pretty cheap and efficient way to build relatively robust housing for refugee scenarios.
It's not hard to find people who want to pay for one lab. What's harder is sort of creating the network that makes it all possible.
It's been a problem trying to expand the network in Ghana. The more Fab Labs we have in a particular location, the better the chances of reaching people.
Very often we say, oh, you know, the world is moving so fast and technology is so advanced. It's not advanced everywhere. It's not advanced with everyone.
People who come in as novice are able to capture and make use of the tools and equipment within a short period of time.
Fab Labs are used exactly the same everywhere. They're used for play, for entertainment, for education, for creating businesses.
When we introduced the lab, like people started trying new things, and now some users, they are making profit out of it.
The person who worked in the lab showed me how my drawings can be translated, and we've made a couple of 3D prints. This way I can make my work much larger, and that way I was able to create large-scale permanent public art.
You use it as a space where you can bring divided communities together.
We can connect people to work with Jewish and Arab together. And you see that when you make things, people don't think about religion. They only think about how to make it and collaborate.
As much as anything, the social engineering is almost more important than the technical engineering.
We expect for this to be a vehicle to develop projects that are actually addressing the two big issues that we are facing today. One is the social crisis we have in the inequality of distribution of resources, and also the dependence that we have as consumers of other supply chains.
Give to the people the power to make things, not only to buy it.
We like to create the conditions to empower the people and to empower the community.
Aquaponics is self-sufficiency regarding to food. To grow the same lettuce, let's say in conventional agriculture and in aquaponics, you have a difference of 95%, which has a huge impact in the context of resource efficiency.
It's going to get faster, better, cheaper.
Using tools in Fab Labs to build more tools that can do other stranger things.
Commoditizing of those resources that I think is a real game changer.
We should take pride in the technology that we own, that we make, and we should take pride in our own ability to create those things.
If we produce things more locally while we are connected globally, then we'll create new society.
It doesn't just simply address the root causes of inequality, it really fundamentally changes that discussion from money and jobs to creation.
Brazo tendido y chuchuan, chuchuan, chuchuan, chuchuan, chuchuan, chuchuan, compañía. Brazo tendido, puño cerrado, dedo hacia arriba, hombro fruncido y chuchuan, chuchuan, chuchuan, chuchuan, chuchuan, chuchuan. Compañía, brazo tendido, puño cerrado, dedos arriba, hombro fruncido, cabeza hacia atrás, cola hacia atrás, pie de pingüino, lengua afuera.
Well, we have arrived to our last station in this Latin America and friend country. I am so honored and pleasure to be part of this experience. My final words and invitation to all of you, my friends, it's keep flying the highest that you can. And remember, in a world divided for many different reasons, we, Fab Lab community, are a big heart that are pumping blood. So reconnect, as Fab Chairman said, as Nuria said, reconnect with people, reconnect with the partners that you know we have in the network, and stay together. So talking about heart, it's my pleasure. Welcome back to Super Sharing.
Oh, thank you, Super Benno. It's always a pleasure to see you. Perhaps next year we will reconnect in person in Bhutan. I really, really hope so. Anyway, that was an amazing tour from South America to Spain to Central America and back again. And I thank you to all the labs that contributed to the programming today. It was truly wonderful and inspiring. And so with that, I think we're going to come back to the USA, and our next video, our last video, is from the North American Digital Fabrication Alliance, or I'm going to call it NADFA. And Sarah Boisvert, whom some of you may know, and her Fab Lab Hub organization in Santa Fe, they really help support the start of NADFA. It's a body for issuing digital badges or micro certifications in digital fabrication skills. And so it was started by a really interesting group of labs, Fab Lab Tulsa, Fab Lab El Paso, I think Fab Lab Roxbury, Fab Lab Baltimore at CCBC, and of course I'm sure you all know that Lorain County Community College Fab Lab, as well as the Fab Lab workshops, Insight Focus, and the Gregory School, all together along with the 3D printing store, put together this organization to do micro-credentialing. They work with Fab Labs and maker spaces, schools, and nonprofits all over the country to advance digital fabrication training for new-collar jobs. So let's see what they're up to. We'll go to their video now.
Today, the new-collar workforce is replacing the old blue-collar one. But how and in what ways? And what exactly is a new-collar worker? Well, just as the automobile, electricity, and television once disrupted the way business was done, today we face our own set of disruptive technologies, including everything from robotics, digital design, and 3D printing to cybersecurity, artificial intelligence, and more. These new-collar jobs are born from these technologies. In fact, contrary to popular myth, these technologies will not be robbing people of their jobs, but rather transforming them, and additionally doubling workforce demand, creating an entirely new-collar workforce, and a collaborative relationship between human and machine, where robots do the heavy lifting and humans do the more innovative and creative work. In addition, many of these jobs do not always require a traditional degree, explains Ginny Rometty, former IBM CEO, who actually coined the term new collar. What they do require is the right mix of in-demand skill sets. And according to author of People of the New Collar Workforce and co-founder of the New Collar Network, Sarah Boisvert, one of the most important of those skill sets is problem solving. 95% of 200 employers she interviewed said they were seeking workers with, above all, problem-solving skills. Other needed skills are being taught and utilized in Fab Labs around the world. Skills that include laser cutting and marking, 3D printing, CNC machining, vinyl cutting, microelectronics, for wearables especially, robotics, and AR and VR. These Industry 4.0 demands now require a more efficient and effective educational model to fill this skills gap in the workforce. Enter the digital badge, a modern version of what could be called today's high-tech VOTech. Short-term, affordable, skill-specific training in these technologies that can be utilized in everything from the aerospace and automotive industry to cosmetics, filmmaking, dentistry, bioengineering, microfluidics, and more, including all things artistic. Nearly every industry is being impacted by what is being called this fourth industrial revolution. And these digital badges are the new professional currency that provides the evidence needed for employees and employers to verify these skills. Currency is a measure of digital badge program value. A group of nonprofits, Fab Labs, maker spaces, businesses, colleges, and K-12 schools saw the enormous workforce development need for both 21st century employees and employers, and as a result, started the nonprofit, the North American Digital Fabrication Alliance, to offer a new way of providing this in-demand workforce training. They recently obtained 6 new members and are a growing organization. And they utilize what is called project-based learning, where students create a project portfolio that acts as the supporting evidence to show how the badge earner identifies and solves a problem using new-collar skills. In addition, they adhere to the Open Badge International Standards and have made these micro-certification programs available online, which levels the playing field, offering the same opportunity of career advancement to all, regardless of race, gender, economic status, or location. A person in a remote location like Roswell, New Mexico, now has the same opportunity and credibility as someone from Boston, Massachusetts. These badges offer a prime avenue for economic growth, especially during times where we have faced one of the greatest economic downturns in history. These micro-certifications stand as a beacon of light to transform not only our economy, but our world in a way never seen before. New Collar Network co-founder Sarah Boisvert talks about the important role these jobs will play in the larger context of human history.
I grew up in a traditional middle-class family. We never wanted for anything. I went to private school. I had piano lessons. My dad would pile all the kids in the car. On the 4th of July week, all the factories closed, and all the kids and their parents would go on outings. You'd go to the shore, you'd go to visit historical places like DC, and it was a really idyllic lifestyle. It was a wonderful way to grow up, and that has really changed as we have seen our jobs go away. All of those things that we need and want, the new Tesla, the new electric car, those smartphones, or being able to get to Mars to colonize outer space, all require people to make these new technologies. We entered a digital age for smart manufacturing, and that has really changed what manufacturing looks like. These new technologies have transformed our blue-collar jobs, and they've become digital. A CNC machine now needs CAD design. We're now working with robots. We're working with lots of different tools and technologies that didn't exist in its previous incarnation. These are jobs that incorporate new technologies that come out of science fiction and are the things that kids today see all the time in video games and movies coming into the real world. But with that, there's become an enormous skills gap. So these new technologies have changed the way that we work with traditional tools. And many different groups have done research that shows we're facing enormous gaps in the number of skilled people. Just having a warm body isn't enough. We actually do need to have people who have the kinds of skills to operate these new technologies. And it's particularly severe in manufacturing, where we're seeing exponential rates of change on the factory floor. We're also seeing that jobs are becoming automated. This is one of my favorite products. It's produced by a company called Local Motors, and Ollie, which is the name of this people mover, is a 3D printed electric autonomous vehicle. So now we're incorporating in this one device 3 major changes in how we think about a product, how we think about moving people around, how we think of transportation. I was interested in looking at what are those skills that we need brought on by these new technologies, these disruptive technologies. And to do that, I interviewed about 200 manufacturers that ranged in size from Fortune 10, so companies like GE, Apple, General Motors, Ford, Boeing, Boston Scientific, all the way down to startups and companies that are working on new technologies for the future. And I was interested in knowing more about the needs that they had for workers in the operator arena and technicians, because that's where the real skills gap. We've been encouraging people for a long time to become engineers, and we've lost people who have the skills that we need for operating machines and for servicing them. I shouldn't have been surprised because I owned a factory but the number one skill that people said they needed was problem solving. 95% of the 200 companies listed problem solving as their ultimate problem. And I really think it's because the technologies are so new and are changing so rapidly that a new worker on the factory floor can't go to Joe, who's been there 20 years, and say, how do I fix this machine? What am I going to do? It's not running. And I think that that is driving a lot of the need for problem solving. And also a lot of the companies that are developing these new technologies are startups and don't have the customer service in place like a big established industry would. And so problem solving has really come to the forefront of a job skill that's needed in today's workplace. The manufacturers also talked about hands-on experience. And that's not very surprising. When I was a kid, guys would get an old car, fix it up, and they had lots of experience with taking things apart, and today that doesn't happen. And one factory told me that they go to the farms. They're in Louisville, Kentucky, so there's lots of farms around them, and they're able to go and find people who have experience with manufacturing things on the spot and making things happen. They also, of course, mentioned digital and computer skills, but that wasn't until in third place. The digital skills they mentioned the most was CAD design, and CAD design has now become the key to manufacturing. We have very few tools that do not work digitally, and CAD has really taken over how we think about advanced manufacturing. Whether it's laser machining, CNC machining, or 3D printing, CAD is the basis of all of those processes. They also mentioned predictive analytics, so we have big data, and suddenly what do we do with all that data, and how do we analyze that? And so experience with these new software programs that help us to take all of the information coming from the sensors on the production lines is a key skill if someone wants to work in manufacturing. A big topic is, of course, 3D printing. At the Rapid Show a few years ago, HP introduced a production 3D printer. And all around me, a meeting of about 10,000 people, I repeatedly heard people say, I'd love to buy that 3D printer from HP, but I haven't got anybody to run it. And one of the real problems that I see, I get invited to visit a lot of factories, and invariably when they hear I've worked in 3D printing, they will ask me to come look at their 3D printer. It's not running well, they're having issues with it, and the big question is, can you recommend a better 3D printer? And in fact, there probably isn't a better 3D printer. They've got some poor IT guy who happened to build a home version in his basement, so he must be the expert, and he has to run the 3D printer out of his back pocket in his spare time. And I visited a wonderful factory in Attleboro, Massachusetts, and they make custom jewelry for like the Super Bowl rings and the sports rings, and as well as corporate things that have to be designed individually for each job. And this poor IT guy is having to run the 3D printer and figure out how to make it work while he's still got this heavy workload. And what I suggested to them was that they go to the local college, find an intern, and call me in 3 months. And sure enough, they called me in 3 months and said, you were right. You know, we just needed somebody who could spend the time. The kid that they hired, it was actually a young woman, engineer, was so thrilled because she got to work with this $50,000 3D printer and to do some really fun work. And but what I hear over and over is, I have problems with my printer, and the real need is to have somebody who understands CAD and also understands how to run the machine and troubleshoot it. Which comes to my favorite slide of the need for 3D printing service techs. I can show this picture because the cube, which actually is what I use to make my cube earrings, is no longer in production by 3D Systems. And so this is not anything about their machine. They decided to go more into the production and industrial world and no longer make the cube. The cube, though, was one of my favorite printers. And one day my intern came in, we were making 3D printed parts for a prosthetic hand, and he came in and the other half of it was spaghetti. So he got a few parts out of it, but this is not unusual. 3D printing is better than it was. It's starting to come more into the forefront, but without someone to really take care of it, without someone to really monitor it and to unclog it when it's clogged. Extrusion clogs all the time, no matter what kind of work you're doing, even extrusion for PVC pipe clogs. And so it's really important to have somebody who knows how to repair these machines. I'm also hearing from the manufacturers that they're having a hard time finding people to hire as service techs. There's a company in Albuquerque that had a job opening for 6 months that they couldn't fill. They couldn't find anybody who could they could hire with the experience that they needed to go into the field and actually make the machines work. But these disruptive technologies are changing much more than manufacturing. They're changing all kinds of industries. One of the interesting examples is from finance. There are now robotic programs that do a lot of the automation in these huge numbers of transactions, and it allows their people to be able to do higher level work. So there is a company that I believe is in the UK, and they use these robots to monitor. It's a software robot. It's not a person robot. It doesn't look like a person. It's a very interesting concept. It runs 500,000 transactions a day, which for humans to do would take a huge number of people. And you think, oh, the staff is going to be really upset because they're losing their jobs. But the staff is thrilled because it allows them to do much more interesting work that is a whole lot more fun. And they like it so much that they've named their robot software, I think her name is Cindy, and they invite her to the Christmas party. So it's, I think there's lots of change happening in medicine. We know of a lot of robotic procedures that are happening. It's happening really all across all of our industries, and I think it's leading to a lot of change in how we have to think about technology. One of the big areas where people are thinking they're going to lose their job, as I said, is in robotics. And at least at this point in time, my feeling is that we still need humans to design, program, and yes, fix the robots. If you've seen any of the YouTube videos of robots falling over or doing, crazy things, we still need some human to be part of that. I was at a trade show in Boston, and there was a huge booth that had lots of robots in it, and they were running around, and it was really entertaining. And I noticed this kid in the corner, and I went up to him and said, so what's your job? Because he was clearly not a salesperson. And he said, oh, well, I keep the robots running. and what a fun job. I mean, for a young person who grew up with technology and saw it in the movies or has seen it in video games, how fun to be able to work with them. And I always like to say that despite advances in technology, machines do not innovate. It is humans who innovate, and we use those tools in order to innovate better solutions to our lives in the world. I talked a little bit earlier about big data and predictive analytics. A lot of the again, the collaboration there comes between machines and man. So while these sensors pick up the information and the data, and the software can analyze it and give you some indicators, it's still the human who has to take that information and figure out what to do with it. So the machine may say, we're due for maintenance on this date. But if it turns out you're selling the company and you have visitors coming and you really want the machines to look good, you're going to move that up. It still takes that integration of lots of different kinds of information in order to come up with the correct decision. So when I got done the research, I really realized that it's people that are the key to digital transformation. It's not the machines, it's not the technology, it's the people that make it work. And it's really the people who are at the center of all of what we do with technology. I also realized that all of the things that the manufacturers told me they needed are the kinds of things that we do in Fab Labs. So Fab Labs are digital fabrication laboratories that are based at MIT at the Center for Bits and Atoms. And we have all those tools, but we really work in very specific ways in problem solving, and we work with our hands, and we're working with 3D printers and all of these exciting technologies, but in very specific learning modalities. And it seemed really clear to me that a new kind of training is needed. I had thought when I did the research that we were going to write a 2-year curriculum for an associate's degree, and I got done and I realized the employers want skill-specific training. They want employees yesterday. The need is immediate and desperate. I've had people in many parts of the country say, just send us warm bodies. And they want problem-solving skills. They want a very different kind of student than we have traditionally trained in education. And for the students, the world has changed. This picture is a high school student who is the son of the current CEO of Potomac Photonics, the company that I sold. And when he was a high school student, he was working with an Israeli biotech company that is a microfluidic device with embedded sensors. And you know, kids didn't used to work on this kinds of stuff when I was young. But the times have changed, and people are now having so much access to tools, to software, to the videos that are on the YouTube channels. And the kids want careers and not jobs. They want to make impact on the world. And they want something that will not leave them a lot of debt, and they need for it to be time effective. It's particularly interesting because at my labs in New Mexico, we are a state that doesn't have a strong history of education. And a lot of the students, particularly for these kinds of jobs as operators and technicians, don't really have a traditional trajectory. They don't get done high school and go right to college. A lot of the students at the community college where my lab is located have families. They have children. They have a family to support. They often are working with their parents and helping their parents. And so it's a very important thing to have education be accessible to everyone and to people who didn't traditionally think that college was an option. And so as I looked at all of these factors, I realized that we really needed to think about a new way of educating, and digital badges to me seemed like the best way to verify skills, not just for the employers, but also for the students. There's data inside every badge, and so digital badges were developed originally by IBM and Mozilla. Mozilla in recent years has formed an open badge program that is open source. There is an international body that verifies the standards, and it allows a documentation of a skill that is verifiable. And ostensibly, although we don't know in this day and age if something is always secure, but ostensibly is secure. But what's most interesting to me is that there's this back end. And so not only do you have a piece of paper that you come in with that says, I've got a certificate in CNC machining, say, we can put a project documentation on the back end. And so we can, because we're project-based learning, we can have every student document what their problem was, how they identified the problem, which is half the battle in any field, and then how did they solve that problem. And so they can have photos and videos and technical specifications of how they actually came to their conclusion. And for an employer, it's really powerful because I can look at it and say, oh, they got stuck there, but what did they do? Did they go around it? Did they plow through it? Did they come up with a really creative way of thinking about the idea that they had to solve the problem and create something new and different? Or did they get really stuck and not able to come up with a solution? So I think for the employers, it's an incredibly powerful tool to make that connection on a much deeper level. Fab Lab Hub has funding from America Makes, who you saw earlier in Youngstown, Ohio. That was through the Department of Defense to create digital badges for additive manufacturing, because that's our start, that's the most immediate need. But what I'm really hoping is that we can create a new color network where the employers and the people trained in these kinds of technologies can be able to find each other. So if an employer is looking for somebody who has CAD design skills, they can go on to the platform and find somebody and see what badges they have, which particular softwares they have. Do they have design for 3D printing? Do they have 2D design? And I think it will be a very powerful way for us not only to train people, but to help them with that transition to the workplace. And so, as I look at this project, and as a manufacturer, it's an important problem. We really need workers. We need to be able to have a good economy. But going back to thinking about my father and his first job, he ended up becoming an entrepreneur, which is where I probably get this focus. But his first job went away. And when we think about the nice lifestyle that we had, when we think about how our people were able to support their families, that people were able to do interesting work and be able to really have a wonderful sense of community and that middle class that was so strong in the US. What I really hope is that the new collar workforce and all of the technologies working together with people are going to be able to spur economic success, not just for the manufacturers and the people who need workers, but for our communities, in order to build strong communities where people can take care of their families, where people can feel empowered and a part of the greater universe. Thank you so much. And if you would like more information, all of the research is covered in depth in my book, The New Color Workforce, which was published by Photonics Media Press, and you can find it on their website. Thank you again.
We're kind of a complete do-it-yourself, get-it-done all in one system, one set. I can go from a customer giving me a drawing to making any fixtures I need to make their part, to working with their drawings, to programming the laser. And I can do it all. Started here pretty much right out of high school and got all my education right here. So it's been a fun ride. So I was actually brought in by a family member. My aunt is actually the vice president, one of the vice presidents. So she got me the job years ago when I was a kid trying to figure out what I wanted to do with my life. Here it is 14 years later, and now, like I said, I'm setting up my own systems and running my own jobs. It's been a long road, and it's been a fun road, and I've learned an insane amount because it takes a lot to be able to run a laser and do everything involved in it. One of the coolest things that I did was when we got into 3D printing technology. That was awesome because we got the new system. I actually went and got certified on the system. I got to play with the system, from loading the part that is just a picture, because that's kind of how 3D printers work. You put a picture in and you get a finished product. So, watching that whole process, learning how the system works, learning how to clean the parts and get a finished product, stuff like that. And then when I was making fixtures and being able to do everything we needed for the jobs, we have the full machine shop in the back. So getting on the mills and getting on the lathes and things like that, it's really interesting. And that's really fun. I'm very hands-on. So I like when I can go and work with, heavy machinery or tools and do some of those kinds of things, as well as working with the laser. So there's many different aspects, and it's all very interesting to me. I can look back at school when I was a kid or growing up to being a teenager to, a couple of semesters of community college I did on basic coursework. And then I can also fast forward not only through the workforce, but also I've done a few semesters more recently on more focus towards the work that we do here. And you know, I was no straight A student back when I was a kid. You know, when I went and did the more futuristic semesters and the stuff that I've done now, working with the stuff that, you know, we're doing now, straight A's, no problem. I mean, not only are we on the cutting edge of, you know, technology and everything on that standpoint, but I mean, you look at it, you have great days, and no matter where you work, you're going to have your bad days. But where can you go to work and have a bad day and say, I got to play with lasers all day?
Hi, my name is Maite Cardenas, and I'm a jewelry designer who works with 3D. I started 3D designer for quite a few reasons, and one of the reasons it was that there was items that I needed to create that wasn't easy to create by hand, or will take a lot of time, or when I was doing specific jewelry for a person and they needed added their name or different other things that were more difficult to do by hand than doing it actually in 3D. That's when I decided that I needed to learn how to use it. If the tool was there, why not to use it? When I was trying to learn how to design, the first thing I did, I went and talked to a company to buy a program, the program that I thought was the best. And I talked to the company and asked them if they have a class where they could teach me how to use the program. They say, yes, they do have it. So I told them, I want to take a class, and if I like the program, if I think that is what I need, then I will buy the program. So I did buy the program, and I really enjoyed it. It took me a long time to really, I cannot say master it, but to be able to work with it and able to create what I want and what I like to create. Yes, it took me quite a time to learn it, but it's about practicing. When I was hand making the jewelry, just hand making, so I took classes to how to make jewelry, but when I tried to go to 3D design, I had no school. I only went to middle school, so I needed to just always focusing on what my interest was jewelry. So when I decided to learn 3D design, it got difficult point because sometimes when you go to school, they have so many requirements. But then I insist until I found the way, and it was when I bought the program. But then I went to the community college, and then that's when I found Fab Lab or Sarah, who was having some classes on it, and which make it a lot easier. When I started working on 3D and I really love it, I got passionate to it and decided I wanted to buy a 3D printer. And I thought it was easy. I just went and researched some of them. Of course, money was a big thing, right? So I tried to keep it as economical as possible. So I got the 3D printer. I had to learn how to use it, and I had so much trouble trying to use it. There is so many little things that if they're wrong, your pieces are not going to be right. But then I was still thinking that the problem was my design. I never thought that the problem was the resolution of the 3D printer. And that's when the help of Sarah, her special 3D printer, really came out and saved me. The Form 2 3D printer is actually the one that has the best pieces. It's when I design, of course, the sketch and then sit down at the computer and take my time. And when I'm really happy with the piece, I can actually send it to Fab Lab, and they will print it out for me, which saves me time where I can either keep designing or time for selling or time for casting or whatever else I have to do. And it really increases the production of my pieces, and it helps me with time and saving actually the time to do other stuff, selling or promoting or whatever I have to do. But when I was dealing with my own 3D printer and all the problems that I was having to 3D print, then it was taking more time and it was being successful. But then now that I can actually leave the work to Fab Lab, it really gets it much better, faster. The pieces are very clean, well detailed, and when I go to the casting process, I don't have as much trouble as I used to have. Now that I found the batches, the football lab of the classes that we're having at the community college, then this helps me to create much more complicated pieces. It helps me to concentrate on things that are going to be easier to build and more beautiful, more complicated, and because I have the time, so because they are printing my pieces now, so I have the time to concentrate in doing a lot of more things. At the same time, I decided that I want to keep taking more classes because I need to learn more about not just about 3D design, but about 3D printing and how it's advancing, how the technology is moving us in a way that is getting our lives easier, not just easier, but more comfortable and more beautiful.
Hello, my name is JC Ramirez. I am a student at the Santa Fe Community College, and I'm doing a degree in graphic design. How I got interested in the Fab Lab here at the community college is because I did an internship with them. I found out about them through my 3D design teacher who told me about the internship opportunity, and I decided to, try it out and see how I liked it. And once I started, I just couldn't get enough of it. I really enjoyed creating things in 3D and then having them printed out. I just thought that was like a wonderful opportunity for me. I just thought that was a way I could, keep increasing or keep working on my skills for design. So my background is in obviously design, 3D animation, graphic design, website design, a lot of media art stuff. That's what my degree is in. So I kind of wanted to just test the waters with 3D printing, see if that was something that I could, learn more about. Added to my skill set. When I was doing my internship with the Fab Lab, I kind of was taking on more different aspects of 3D printing, like servicing, like the behind the scenes, like taking the machines apart and seeing how they work too. That's also kind of what I got interested in doing this for, is being like a technician for this cool stuff, this cool machines that help with the art process. Here at the Fab Lab, I was lucky enough to use my skills that I've learned before, like my video skills, to create the workforce training videos that we use to train the students, to train anyone trying to learn how to use their 3D printers. My favorite thing about working at the Fab Lab is that I get to use all my skills that I've learned from before, my graphic skills, my video skills, my design skills. It's just a good place to, bring all those together to create something new, either helping somebody else, with their projects, or, having my projects done here. Originally, I thought the Fab Lab was going to be more technical stuff, so more engineering stuff. Like I thought it'd be useful to have a degree in like engineering, but actually I found out just having my media arts degree was kind of like bringing the creativity and the technology together. But for me, I was kind of interested in technology and more of the art stuff, but I still wanted to see how it was for me. I was able to learn the engineering stuff behind how the machines work and to kind of, help with anything they needed. So I think that was very, attractive for me to, bring those two aspects of working at the Fab Lab together. Working with the engineering people here and working with like my creativity and like bringing that into here was like what made the difference for me. So my background is in, again, graphic design and working with programs like Illustrator, Photoshop, and some 3D modeling stuff. So that made it a lot easier for me to kind of get into the 3D printing world. You know, I kind of have some familiarity with how some programs work with 3D models. That kind of made it easier for me to transition into working with the slicers that we use, the slicing softwares that we use for the machines. It was a very natural transition for me to, start using my skills for what we do here. Having a background in media arts definitely helped me, enjoy this job. I very much enjoyed working here. I very much enjoyed using my creativities, my set of skills, and bringing those into this type of field, And I would definitely recommend anyone who has a media arts background to, at least learn a little bit more about 3D printing and the possibilities you have to, at least expand your art. But it's not also just for like the engineering people that use digital manufacturing for their project, but it's also for like the creatives who want to explore new things, explore new medium for their art, to bring their creativity into the world of engineering and design.
My name is Judy, and I work as a program assistant for the 3D printing store in Centennial, Colorado. I was still working in healthcare as a hand therapist, and I had been seeing a lot of fun things going by in social media and various places about how cool 3D printing was, and I really, really wanted to get involved in it. And then I had a patient with a special need come through, and I thought this might be our opportunity. And so I looked in Google for places in Denver, Colorado that were doing 3D printing, and lo and behold, a former patient was running a 3D printing shop in Centennial, Colorado. So I said, hey, can you guys make this? They made it. I fell in love, and they couldn't get rid of me after that. I begged them to come let me hang around the shop and learn some more. And so they said, oh yeah, we call people like you interns. And so it was me and all the other 12-year-olds in town hanging around at the 3D printing store. And so I like to call myself the oldest living intern at the 3D printing store. My master's degree was in occupational therapy, and I worked for 25 years in healthcare. But I was one of those women who, when you're of my youth, when you grow up in a small to medium-sized town, you're either going to go into healthcare or you're going to be a teacher. And I really probably should have been in engineering or in the sciences, but that, I just didn't grow up in a family that was capable of recognizing that. And so I did, healthcare was good to me. I did my time, but when I got a chance to make a break and get a chance to try something new, I just fell in love with it and decided to dig my heels in and make a change. I do a variety of things. It's nice sometimes I'm able to kind of give consult when people come in with healthcare products, and I can help design them. I'm learning to be a designer, so they give me some of the more simple design projects, which is wonderful. I love to do that. I've learned to use all the printers, so I take items off the printers after they're completed. Finishing work, sanding and finishing, and kind of just whatever they need help with around the shop, kind of a gap filler. I'm learning SolidWorks right now, and I love it, it's the most wonderful thing ever in the world. I survived AutoCAD 3D, which the students at ACC call AutoCAD 2.5D. I had a couple semesters of AutoCAD, and I'll start working more with Bentley MicroStation in a couple of weeks. So just hanging on to SolidWorks as long as my student license will hold out. It's just so amazing. The amazing thing about 3D printing is that it's so empowering to innovators. People come in here and they can't help themselves. They're makers, they're creators, they are people who have to try to see if they can do it better. And it just empowers them. They walk in the door with these things that exist no place but in their head, and they walk out with the device in their hands. It's just the most empowering thing. The designers are awesome. They're my tutors for my SolidWorks class. The guys are always available to help me figure out how to design something so that it will print. They oftentimes will set me up with workshops because they have offers for free training seminars, and so they'll always forward those to me and let me get a chance to get in on those. And so there's just always a chance to learn. Recently I had to write a paper on a manufacturing technique for a class, and so I got to go up to Elementum and see where they're doing direct metal laser sintering, and that was amazing. So just it's just been a really great place to get a lot of opportunity. I would love to be able to take my healthcare background, because I was always the therapist that anytime a rep brought something in, I would take it apart and tell them how they should have built it. And so now I'm building some of my own things. But I don't feel ready to do that. I don't feel fast enough and strong enough to do that for somebody else yet. So I've taken a job as a drafter after the end of the semester, and I'll be drafting for a little bit as I continue to develop some of my products and grow my SolidWorks skills. Hopefully within a couple years I'll be able to work as a designer for somebody. That would be the end game goal.
Hi there, my name is Katie Wolf, and I'm a 3D scanning specialist at Direct Dimensions. We are a company that focuses on creating digital models of real-life objects through 3D scanning and processing. These models can be highly technical and precise for applications in engineering or manufacturing, or they can be on the more artistic side for movies or for sculptures. Because of the focus on all things 3D, a typical day for me in the office can vary greatly. Sometimes I'm out on the field assisting coworkers in capturing the architecture of a building, and other days I'm just simply at my desk cleaning up 3D scans. Although I'm one of the newest employees here at the company, I really enjoy working with all of the people in my group, and I especially appreciate that we come from all sorts of different backgrounds. Some of us are RIT graduates and engineers, and others came to the company without a degree and owned businesses prior to working here. You could also say that I came here unconventionally because my background is actually in art. If you had told me 5 years ago that I would be a 3D scanner, I would have not believed you at all. I decided to study art at the Maryland Institute College of Art here in Baltimore, and my initial aims were to be an art teacher or even a museum worker. But 2 years into my degree program, I was introduced to 3D scanning and 3D printing, and after that I was hooked. I wanted to learn everything about 3D printing and 3D scanning, and I started to learn the software that helps you create digital models by taking pictures. And because I had been working in a museum, I decided to start making digital models of objects that were on display at the museum to help with the educational side. So I ended up doing that, and then after I graduated, I was lucky enough for DDI to hire me, and I'm proud to say that I'm still doing the same thing today, helping museums make their collections digital, and I'm also working on a whole host of other things.
The New Color Network Additive Manufacturing Apprenticeship covers FDM 3D printing, since that is the fundamentals of additive manufacturing. We also have programs that cover stereolithography and also production. Recently, through a generous grant from the Northern New Mexico Economic Development Corporation, we were able to get the beautiful Nexa 3D printer that is sitting behind me, that is very high speed and will allow us to get into high volume manufacturing. When we first started looking at how to fabricate the New Color workforce, it was pretty clear that the digital badges we had created were an optimal way to train people for these new kinds of jobs. But there is also the component that we needed for hands-on learning on the job. And I looked back to a very tried and true process, apprenticeships. Apprenticeships have been around since the Middle Ages, when they were known through the guilds, and are still really popular in Europe. In the United States, it's the trades that had really embraced apprenticeships. And what we need today are 21st century apprenticeships. apprenticeships that are upgraded for the 21st century new color jobs. We need apprenticeships for additive manufacturing, 3D printing, laser cutting, AI, and all of the other kinds of disruptive technologies that are now ubiquitous across industries. With the help of Jennifer Odo, who is now the head of workforce programs at Youngstown State University in Youngstown, Ohio, we were able to get a U.S. Department of Labor registered apprenticeship for additive manufacturing technicians. We are just thrilled to work with Youngstown State and really embrace the apprenticeship model with all kinds of new 21st century education alternatives. Our training provider is through the New Color Workforce Digital Badge Program, as well as IBM IT badges and the Society of Manufacturing Engineers and SMEs additive manufacturing certificates. With the help of America Makes and the Urban Institute's framework, our program was readily approved, and we have apprentices right now working in Fab Lab Hub's facility in Santa Fe, New Mexico. We want to tell you a lot about apprenticeships, and to do that, I thought it'd be really fun to talk to our real-life apprentices who started with Fab Lab Hub this past year in the U.S. Department of Labor registered apprenticeship for 3D printing technicians. This is Alec, and I'm going to let Alec tell you a little bit about his background and how he found us.
Before working here, I was learning a lot on my own, through a lot of different resources, trying to patch things together, and then, working a lot of different jobs to sort of support that. And it's just an amazing opportunity to be able to learn additive manufacturing, 3D design, even laser cutting. So just to have it all in one place and be learning every day, every week, something new, it's pretty cool.
So tell us what your job was when you found us.
Yeah, I was in the midst of trying to start 3D printing sunglass company. And what I was saying, I was patching everything together, working for my friend's company, working at a restaurant part-time, and just spread really thin. So it's like just a great opportunity to just consolidate everything and be learning in a much more structured way too. Yeah. And
this was during the pandemic.
Yes, yeah. So throw that in there and a couple other things too, So.
Yeah. And I think that's one of the things that we saw was we had 100 applications, and a lot of the people who applied for the two positions were displaced COVID workers, and it was really gratifying for us to have people come in to learn a skill. We have done some research since, and there's about 1,000 jobs within probably a 30-40 mile radius of Santa Fe, New Mexico, where a technician is required that has 3D printing skills. And so I think the opportunity is really great. And so tell us about the badges.
Right, so that was the first step to working here, was working through each of the badges and kind of the whole progression. And it's such a great way after going to college for 4 years and high school, junior high, elementary school before that, to just have this consolidated education and to see how much you could really learn in a short amount of time is pretty amazing.
Well, it has a lot of focus.
Yeah, exactly, which I think a lot of other things don't. So
yeah, and I think the fun part of the badges is the projects.
Right.
So do you want to describe one of your projects?
Yeah, it was for a different friend trying to start has a ravioli delivery company, and they have these ravioli trays that he's saying are all always too small. And he wanted to put a logo or something fun on the raviolis. So kind of classic moment of, oh, you could 3D print this. So it was perfect timing, taking one of the classes, designed a modular ravioli tray for my friend. And, it was right size project for the class, and it all worked out. And even since I've been learning a lot of that on my own, there's just so much in the badge that I wouldn't have known different processes without the help of an instructor for this specific project. So it's pretty fun.
I think the projects are fun.
Yeah, totally. Yeah.
And we're so excited to have you join us.
Cool. Yeah,
Thanks.
It's been great.
So why don't you tell us about this project that you worked on for the lab?
Yeah, so we have, as you can see, just so many different 3D printing artifacts, trinkets, things we've designed. Be an hour-long video to go through all of it, but wanted to make some sort of shelf displaying them, and came to the idea to laser cut these panels and then to 3D print the hinges. And then it started coming off the wall a little bit, so it has these little inlets for the tacks. And since then, I've just been like falling in love with hexagons, and kind of they're starting to pop up everywhere else too. So
it's a great solution, and it really is aesthetically beautiful.
Yeah,
compared to the mess we had before.
Yeah, the bees knew what they were doing.
Yeah. Yes.
They started that.
The apprenticeship program here at Fab Lab really draws from different parts of our state, and Jed, who is going to talk with us today, lives in Los Alamos and grew up in a rural area. And I really appreciated when Jed applied for this job that he had experience with fixing all manner of things on his dad's farm. And Jed can fix just about anything. Jed, do you want to talk a little bit about what you were doing when you found us?
Well, I lost my job to the pandemic. I was working at a restaurant, and my girlfriend was taking classes, and she emailed me about some 3D printing class and that she didn't want to take, so I took it. And then we were working on it's called a Broleum knob, but another name is a suicide ball for a tractor. And it's like postal workers have them on their vehicles for, like a one-handed operation of the steering wheel. And that was my project. I talked to the instructor about, hey, do you know how I can get paid to do this? And next thing you know, I'm working at the Fab Lab.
And that class I had offered to Rick Bailey, who is the president of Northern New Mexico College.
Oh, he was there before I graduated.
Or after. He's there now.
After, yeah, sorry.
Yeah, he's there now. And it was just, serendipity that I sent an email to Rick, who then passed it on to instructors and who spread the word.
To a student who spread the word to me.
Yeah.
So.
Yeah, that was good. That was good. And I really like that we were able to bring people in who were displaced by the pandemic, because I really believe that the economy needs to be diversified, that we can't just rely upon tourism, that we need high tech and we need well-paying, engaging jobs. And every time I come in, the first thing you always say is,
what do I say?
How much fun it is.
Oh, yeah. Yeah, it is a lot of fun.
So let's do it again. So when I come in, the thing Jed always says is,
how much fun it is.
and I don't pay him to say that.
No, she doesn't.
You really are having fun.
Yeah. It's a lot of fun. I'm always doing something, and it always changes, so it's hard to get bored.
We had a really interesting project of assembling the beast, and That was, I think, one of your more challenging projects.
Yeah, that was a nightmare, to say the least. Well, it wasn't that bad most of the time. But yeah, being able to work with my hands is really cool. But also, I'm kind of not working with my hands. Like, I'm not out in the feet, you know, working on cars or anything, tearing up my hands. But it's cool to be able to make something. It's kind of a dream job. I love it.
That's great. So I think that in the Beast project, it was really challenging, and it forced you to really use a lot of problem solving.
Yeah, I had to get creative. We wound up having to fabricate parts, order parts, rewrite the firmware. I did some soldering. It was kind of all led up to that moment. Like, all the skills build on each other. It's yeah, that Iron Man stuff.
It was a complete redesign. We thought we were going to assemble a machine, and it was a redesign.
It just didn't work from the get-go.
Yeah.
The poignant moment was when I finally got the Z-axis to move, and it was lifting up and up and up, and then it just started. It was like just a fraction from touching the Z probe. It would like almost work, and that's when I threw in the towel.
And we're doing, or actually Jed is doing a complete rebuilding of a variation on it.
Yeah, we're going with this open source design that is it's got some impressive numbers. It's something like the printhead can move at something like 2 G's of acceleration. It's nuts. But we've been printing out parts for a good part of a month, and yeah, we're hoping to get that going.
I think it's really cool that you print parts for the other printers.
Yeah, self-replicating machines, self-replicating rapid prototyping machines, RepRap. It's cool stuff. It's like the first step to living in the Star Trek universe. I'm a big fan of 3D printing and how democratizing it is.
Yeah, it is. Thank you, Jen.
Wow. Thank you to the North American Digital Fabrication Alliance for this great work. So, Monique, we're wrapping up day 3 of FAB16 Montreal. It was quite a day, at least as far as I'm concerned. I'm going to celebrate tonight by going out and eating some making some DIY poutine dinner. What are you going to do to celebrate?
Oh, wow. You're so brave to try to do the poutine. So on our side, we are celebrating that tomorrow we will be able to set up the first zone structure made by a Fab Lab. So we're gonna set it on the Fab City campus, and for me it's quite an achievement. And with the heat wave, it's like a Burning Man challenge for us.
Oh my word! It does. You look like you're kind of out there at Burning Man. I think this structure. So hopefully that's not where you'll be tomorrow.
Not so far.
Well, okay. This is super exciting, Monique. I can't wait to see it. But for tomorrow, just before we wrap up for the day, tomorrow's symposium is the theme is fabricating craft, and we've got the amazing Anastasia Pistofidou starting at 9 a.m. Eastern, 3 p.m. CEST. And then Friday's symposium is Fabricating the Commons, and this is the Fab City Summit, the launch of the Fab City Summit on Friday. So, Monique, do you want to share some highlights from the summit on Friday and over the weekend?
So, as you know, we're going to have the Pledge of Montreal City, so that's a great achievement. We are waiting with more exciting about it. And we would like to invite people to watch the film Apprenticeship Living None Behind, that reveal another aspect of the True North. The film also will be available as a conversation activity on Saturday at 3 p.m. at the summit. And it will be available for 2 weeks in 3 languages And we will send more information about the film to FAB16 and Summit participants soon.
Super, super. Well, thank you. We also have a great lineup of workshops tomorrow. Don't forget, we have all these great workshops. So for the theoretical or sort of discussion-like workshops, we've got STEAM education, thumb finger art workshop. We've got exploring, this is a really good one too, exploring racial equity around the world. I really, really would encourage you to go to that one if you have a chance. And then, I don't even know how to pronounce this one, TSCNC, mid-FDM, and Fabulaser, a replicable machine kit for Fab Labs. Then She Makes is holding another workshop. Scopes DF, we'll be reporting out on our education work in the last year or two. And then we have FREP circuits. So these are the ones that are theoretical. And then we have the hands-on workshops. And remember to go and look up the workshops first to be sure that you have the materials if you want to actually participate. So we've got the Build a Pop-Up workshop, modular fashion garment, and see, with all the beautiful fashion we've seen today, I think that might be a real winner. From soft robotics to biotics is another workshop. Cardboard, code, and creativity, and biomaterials workshop. So don't miss those, starting at about 1 o'clock tomorrow. And then we have our last working group tomorrow. We have the Academy working group. I believe that's at 7 a.m. Eastern, 1 p.m. CEST. And then that'll be followed by the last graduation ceremony for Academy, or for the Fab Academy students. So come and see their incredible work and celebrate with them. And so one more thing, we will be announcing the winners for the Stop, Reboot, Learn Challenge tomorrow. There'll be a couple of Fab Academy scholarships given, and this is thank you to SolidWorks and Dassault Systems. And Monique, I think, what else do we want to do today before we leave? I guess we want to do some thank yous, yeah?
Yes, absolutely. I'd like to take the opportunity to thank you to all the distributed hubs for participating and helping this year. It's very, very helpful. And so we have from Europe, from South America, from North America, Africa, and Asia, and also for the local hubs, community partners, and graduation hubs. So thank you, everyone. It's great to have you on board.
You guys are amazing. You all have made this an amazing experience for all of us. And so I would also like to just thank one more time our co-hosts, Communautique and the Center for Bits and Atoms, as well as our community partners, which include Cooperative Fab Labs Quebec, and Fab Lab Barcelona, Tourism, Montreal, McGill Engine, McGill Musculoskeletal biomechanics. It's easy to say at this time of the afternoon. Biomechanics Research Lab and Procédurable. And then we're supported by Trotec, by Dassault Systems SolidWorks 3D Experience Lab, and by the governments of Quebec, of Canada, Montreal, and les jeunes. It's too small, I can't read it. But at any rate, we thank you all so much for your support and your participation. So, and last but not least, I think we have one more group that we want to thank. And so I want to thank the Fab TV team, all of you across the world, Norella, Francisco, Christian, Adrienne, I think they're all in bed right now, Rebecca, you guys have been amazing, and our Montreal team, Dennis and Valentine, and of course our co-hosts for the day, Marco and Benno. So thank you so much. We could not have done this. We really couldn't have without you. This was a very special day, a very special experiment, and maybe one that we'll repeat. So thank you all very much. And Monique, I think
that's a wrap.
I think that's a wrap. Yay! Okay. Bye, everybody. Good night. See you in the morning. Bonsoir. À vous.
See you soon.
Bye.